Sharpie. I will ask
class.
somebody. I will go buy somebody who are custom and printing on my school shirt and things, man, and let them put it on it.
Exactly. Just
But
take a
you know,
screenshot the logo and then
hey
or
boy,
no, you know them
Yeah, I
printed
can ask her
paper
for the logo.
where you could just like print it out and then iron it on the
Yeah.
shirt. Boy, I
Yeah.
got
so
do that.
somebody check YouTube. Make sure we live.
Yeah,
We
it's
live?
showing. It's
Yeah,
live.
live.
Nice
Yeah.
man.
Now
Nice. Let me
getting
start TikTok. Let me start TikTok there.
Welcome to the live with you. I know nobody here.
I heard they say we had a come tonight with your voices too.
This is my shirt. I drew that.
Okay. That look
Wow.
nice. That look real nice. You look real nice. Right? I think I am live.
Well,
Okay.
that was
So
great.
I'm now getting notification.
Excuse sir,
Yes, Nikolai.
I won't be here for long, because I have technical drawing exams.
Yeah, same.
Okay. I will miss you guys.
And
I
this
will
was
miss
the
you
shirt
guys.
after everybody
That was
signed
the
up.
OG. That
Oh
was the
God. The
Oh
Burman
God,
still
start
here.
again.
How he get in, bro? How he get in? How did
Wait,
he
get
get in?
turn off the participant settings where you can rename yourself.
This was after everybody signed on it.
Okay,
How can I do
girl.
that?
It's supposed to
Huh?
have
Okay, I do that. Nice. I remove the settings so you carry name yourself.
Right.
Nice.
I wasn't gonna
Nice.
rename myself.
Let me see them. Let me see them. As soon as they unmute, kick them out one time. Let me make Romano a co-host. I make
So
a
you could
co-host.
make me a
I've
co-host.
been saying Romano need to be a co-host with Nikolai now.
Nikolai, when Nikolai there, boy, I can't see Nikolai nowhere. Nikolai, talk then. Leona, making you a co-host. Make sure you utilize it. If you see anybody doing anything out of time, kick them out one time.
Excuse me, sir.
Alright, so cinnamon.
Where's Nikolai, boy? I see Nikolai nowhere.
Right here, no, sir.
Alright, Nikolai.
Hi, sir.
Yo. We have Lucas there, boy. Lucas, somebody here, man.
Yes, sir.
Lucas, I feel like you're trustworthy, you know. I could trust you to kick anybody that being disruptive.
Sure, sir.
The bet. Alright. Let me start
I
now.
wish so they trust me like that. What?
Excuse me, sir.
I trust him, man. That was my inside turn, not my inside turn. Right?
So someone
sir.
said that YouTube have a lag.
Huh?
Yeah,
Danny?
YouTube will have a lag, right? I tried the best I could. This is a bit tough. Right? What we gotta do what we gotta do, right? Okay. Are you seeing the screen? Yeah? No?
Yes, sir.
Maybe?
Yes, sir.
Yes.
Alright, what do we?
Yes, sir.
What we? Okay, nice. People, my TikTok live? I'm on my TikTok live. Is the TikTok live? Somebody check your TikTok for me.
I'm going and check soon.
Nice. Oh yeah, I had to catch up on some of these, boy.
TikTok right now.
Nice. Yeah, boy. I needed to get some sleep, so I start late because the boss can't function without massive amount of sleep. I need sleep too.
Yes,
Even though that song, I'm a bit weird to hear from me. Yeah, I need some sleep. All right, are you ready? Let me get some gas, boy. Let me get some gas. Are you ready? Let me go.
Yes,
Right.
grass.
Vroom, vroom, vroom.
Boom. Right. So we're gonna look at bearings. How much are like our bearings?
Me.
Me, I literally cannot bear bearings.
Me.
Literally.
I do into you.
Oh, me too. I do in geography and
Alright.
I can't bear bearings.
All right. So the first question is: I'll even know what bearings is though. I'll know what bearings is.
No, sir.
No.
Compass
Okay.
direction. or
So
something.
when
Yeah.
I think
Direction.
All bearings is just directions. In case
Like-
I didn't know, bearings is just direction. Right. So let me show you what I mean by that.
south, like east, west, north, south type of thing.
Yeah. Exactly. Guys, make sure the people in the Behave group chat they get any link, because I trust those batch of students because have real trolls out there. I have to be careful who I let into the meeting. Right? So, Dina, let me just say I already know south, east, and west, right? You know what does look like?
Yes, sir.
Right? We're going over here.
That's north,
Right? We're going over here.
south,
Right? And if you just forget this like me, just remember
east,
we.
and west.
Just remember we. Just remember we. Alright, so Dina, let me just say that you were over here, right? That you over there. Yeah?
Mhm.
And let me just say Romano over here. If you wanted to go to Romano, what direction you want to travel in?
East.
East. People on the Zoom, people on the TikTok, YouTube, all understand that? If Dina was over here and she wanted to go to Romano, and she would have go east?
Yes, sir.
Yes, sir.
Yes, sir.
Hope all understand that. Let me look at another example now. And then I'll hit all with it. I'll hit all with the bearings. All of this is bearings now, but you just don't know about it. Okay, what about... Alright, anybody want to volunteer the name?
Sure, you could use me, Sarah.
Sarah, okay. Sarah, let's just say you was over here, right? You over there. And let me just say Romano again, Nikolai. Let's just say Nikolai. Nikolai, let me just say Nikolai, you over here, right?
Who we had to kick now?
We kick the Brahman out? Apparently, I'm not sure. Alright, so I have a question, right? Sarah, if you are over here and you want to get to Nikolai, what direction you travel in?
South.
South. So everybody understand the gist of this, right? Let me know if you understand the gist of it.
Yes, sir. Yes, sir.
Okay. Now the question is, Enter might have to go in a direction that's in between south and east or something.
Mm-hmm.
Yeah.
Yeah.
I'll live with me, right? People on YouTube and TikTok and thing. And at some point, I might want to travel at a very specific direction.
Yes, sir.
Here, what I gonna do? I gonna say north, north, east, 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 or something like that. I mean, it has like a 2-point cardinal system and thing, but that's very unreliable. So here's what you're gonna do. So check this out. So I don't know if all you realize this, right? But if you want to travel in an eastern direction, what bearing you think that is? Somebody take a guess.
What was the
90
question?
degrees.
That is 90 degrees.
degrees.
If you didn't know that, tell me now. How much of you guys didn't know that east is just 90 degrees? A bearing at 90 degrees.
Me, sir, I didn't even know that.
Yeah.
Yeah.
And let me continue the logic. What bearing do you think south is?
180 degrees.
180.
180.
180.
Right. So you've been knowing about bearings your whole life. North, south, east, and west is just bearings, guys. But you didn't know that. I'm sure you didn't know that. Bearings is just directions when it come down to it. But
To be
like,
honest, I didn't know about it until like home 4. I always used to refer to it as cardinal points, but
well, it cardinal points come from bearings. Yeah.
okay.
So like, so let me go to let's see these examples, right? Let's generalize it now. So anytime you're working with bearings, anytime you see the word from, we're gonna put down by from.
Okay, please excuse me.
Starting.
Point.
You're gonna put down the north line. Put down the north line.
Sir,
Yeah.
can we like low-key kick out Alicia because she bullying Romano in the
So
chat?
just lock
What?
it up until somebody not able to join because
What
the
happened?
chat
Wait,
out
what?
again.
She bullying Romano in the chat.
Ole, we bigger than this, right? Ole, we
I
bigger than
even
this.
realized.
Hey,
Yo,
Ole.
Alicia, somebody kick this girl out. How you gonna say
Wait,
something like
wait.
that in a man's chat,
She
bro?
leave.
Okay, Ole, try to have some decorum, right? Okay, let me continue. So anytime you see the word from, you're gonna put down an outline. Anytime you see the word to, so like let me explain something, right? I'm gonna call somebody by Lucas. Lucas, if you was over here, right? And you want to go by me for math lessons. right? Best math lessons in the Caribbean. Lucas, and you would have to leave from your starting position to go to me.
Yes, sir.
Yeah. And so, if you have to go from by you to me, the statement would say from Lucas to Rajiv, would it not?
Yes, sir.
Yes.
Right. So this is going to be the other point. The other point. What are you going to do with the from and the to? If you want to go from here to here and try to connect it,
Yes, sir.
right? Connect. It's somehow a bit weird. Connect from to somehow a bit weird, right? But that's essentially what you're doing. And the other very critical rule in bearings, watch this. What direction am I measuring my angle in? What direction am I measuring my angle in?
East.
Clockwise.
Clockwise.
Clockwise. Clockwise. I'm measuring my angle in a clockwise direction. So the angle is measured. Angle is measured in a clockwise direction with respect to the what?
Not like
Right, with respect to the north line. Now, no. So let me give a little example. So I'm going to write a statement here, and I'm going to say from Lucas to Rajiv. So everybody in the Zoom on TikTok, everybody, right? Do you guys understand that all I'm saying here, all this is just directions? It's just directions, you know?
Yes, sir.
Just
Yes, sir.
directions. Okay, good. I hope all you understand that it's just directions. You guys could send the link to everybody in the group chat. Behave sure in group chat. Send the link there. Make sure everybody join in. Right? Because I see the numbers a bit lower than usual. So if I am starting from Lucas, what am I gonna put by Lucas? What will I have to draw by Lucas?
A north line.
Exactly. Yo, wherever you see the word from, wherever you see the word from, you can't put where by from. You can't put on what?
a north line.
A north
Exactly.
line.
Take that away. North line, north line. From, put on your north line. And to measure the bearing, I'm going to start from the north line and I'm going to measure in what direction?
Clockwise.
Clockwise. So would this be correct?
No, sir.
No.
Sir.
Oh, no, this would be very, very wrong. You can't do this. You cannot do this, right? You cannot do that. And so let's actually measure the bearing now. Let's actually measure the bearing. Oh, that looking less than 90 or more than 90? What the angle looking like?
Less
Less than 90.
Less than 90.
Yeah, that looking like less than 90. So I need somebody to help me read this off. What that looking like?
65.
65.
65.
Right. Now when you're writing bearings, you typically use the 3 number notation. So you would say, I would say 0, 6, 5 degrees. Okay? And so if Lucas, right? If you had a compass, all you had to do is get you 65 degrees and keep walking in that direction. And let me show you something. I sure most of you never see this before. So everybody understand this black line, this black thing over here, this is the angle at 65 degrees. I'm gonna call it seeing that.
Yes,
Right.
sir.
Yes, sir.
So this is Lucas's compass. If Lucas keeps walking in this direction, where is he gonna eventually end up at? Where is he eventually gonna end up at?
R.
R. Yeah. Bearings is just directions, guys. That's all. I teach you knowledge geography here. It's just geography. Yeah, see Satish right here. Satish,
Yes,
talk to me.
sir. Yes, sir. Afternoon. So, question, right? With bearings, is it that you have to use the what was I use the that half a circle thing? I forget what you call that.
That is a protractor.
The protractor, right? You have to use that to measure what you do in the exam, or you have to try and calculate this thing yourself. I can't remember this at all.
Okay, not a problem. Wait, not a problem. It depends. It heavily depends. Right? In the January 2026 paper, you had to use your protractor to actually draw the bearing. But in all the years I've seen previously, it's given to you and you have to use either sine or cosine rule or the co-interior rules to figure it out.
Oh, okay.
Yeah,
No problem.
No,
Thanks.
sir.
no problem. Yeah, I've seen real people talking. Yeah, talk to me, Kelly.
In geo, like it looks more, it is done more easier than in geo than in comparison to math.
Very true.
Yes, so she have
Serious?
a point. It's not like this in geography.
Nah, it's the same thing. It's the same concept. Like, it's literally the same thing. I don't see how anything changing. This is literally
Maybe
geography.
they
This is
probably.
literally geography. Literally geography. I don't see how anything could change. This is
Oh
bearings.
yeah, this is the thing we would just use with the trad or something.
Yes, yes. You would connect two
It's
dots.
just
You would connect two dots and you would measure the angle. That's all.
So but I don't understand how they just do it with the trad.
Well, all
so
you do when you,
there's go ahead.
well, I don't teach geography. Yeah? I don't teach geography, so I don't know what it is you try to think. But what I'm showing you here is how to go from one point to another point. So let me look at another example, right? But before I do that, do you all know about co-interior angles? Yes or no?
Yeah.
Yes.
Yes.
Yes, sir.
Yeah.
All right.
So
No, sir,
Yeah.
I don't.
If you don't, that's fine. That's fine. You'll learn it here. Okay.
Excuse sir,
Check.
before you move on, I have a
See,
question
yeah,
to ask.
corresponding.
I have a question to ask you.
Yeah. Ask me fast. Talk to me.
That is bearings in map work, right?
Yeah. Bearings and map
Okay.
work.
That's why
All
I wanted to know.
all bearings is just direction, a direction to go from one point to another point. That's all. That is all direct. That's all bearings is. So let me ask you a question, right? If I were to put on a note line by Rajiv and I put on a note line by Lucas, like so, those two note lines would be what? What would they be to each other? They'd be what? Perpendicular,
Parallel.
parallel.
And
They'd be
there's what
parallel.
Parallel.
the co-interior angle form.
The
'Cause
co-interior angle
when you
form.
have lines that are parallel to each other,
Traversal, right? You have a traversal here. Yeah. Right. So yeah, you're going good. So this is a traversal, guys, and these are the parallel lines. So if I know the angle is 65 there, we think it'll be over here.
65
degrees. 5 degrees.
But then it'd be
Right.
the same
And
65.
yeah. Over here will be 65. And if you wanted to calculate this angle, it'd be 180 minus 65. Because the sum of angles about a line is
180.
180.
and so how I just tell my students, even though it is co-interior angles, I just tell them, hey, just think of this like a line, just minus 65 from 180, and you get the angle there. But the proper thing is co-interior angles add up to what? What do co-interior angles add up to?
180.
180 degrees.
Right. So I'm gonna run them back one more time. So we have two note lines here. The note lines will be what to each other?
Parallel.
Right. The note lines will be parallel. And over here, I have a traversal. Are you seeing that? Oh yeah, a traversal is just a line that passes through two parallel lines. That's all. I know it's sounding complicated, but that's all it is. It's just a line passing through two parallel lines. That's all. So are you guys seeing a line, a traversal? Are you seeing a traversal?
Yes, sir.
Yes, sir.
Good.
So to have a co-interior angle, you must have a traversal.
Yes, and you must have two parallel lines. If you're having a really hard time seeing it, watch. So this angle over here would be equal to this angle over here, right? I'm going to call it catch that.
Yes, sir, we catch it.
Yes, sir.
Okay.
And as such,
So-
this angle over here would be equal to what?
So I have a question.
Yeah?
They call that and alternate angles as well, right?
Yes. So you see this and this, these are alternating angles.
Or is that angle?
Yeah. And you see this angle over here and this angle, what do you think they'd be?
180 minus the next angle.
180 minus.
Yes. And they would also be the same. So the two red angles would be the same and the two green angles would be the same. And if you guys could notice this, this is corresponding angles. I don't know if you guys know about that. But
Yes.
we typically don't use corresponding angles much in bearings. We typically use co-interior angles and 180 degrees. That's what we use. So I'm gonna run through everything one more time to make sure everybody's on the same page. Note line, and note line what to each other? They what?
Parallel to each other.
Parallel, right. This is what call a line? What call a line? How about T? What call a line?
Transversal line.
That's traversal, right? That's traversal line. And so therefore, this angle and this angle have to add up to what?
180. 180
degrees.
180.
Good. Alia, please lock that in. Alia, lock that in. You see this angle over here and this angle over here, it must add up to what?
180.
And the proper thing to say is co-interior angles must add up to what?
180
degrees.
Add. Good. Lock that in, guys. Lock that in. Have that locked in. I suppose at some point TikTok is going to remove the live. I suppose at some point. At some point. I know that's gonna happen at some point. TikTok. People on TikTok, all they good, right? I hope all they good. Alright. So does everybody understand the basics?
Yes, sir.
Alright. I try not to move too fast, right? I try not to move too fast. I don't want anybody to be confused. So I have a question. This black angle over there, this angle over here, right? Would that be a bearing? Yes or no?
No.
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 No, it wouldn't.
And if you're thinking, it is a bearing, pause. I'm asking a question, right? Bearings are taken from the north line in our direction.
Clockwise direction.
Hear what?
direction.
Hear what? If I want to figure out the bearing here, don't I need to know the angle, black angle over here?
Yes, sir.
Yes, sir.
Yeah. Because remind me, what is the sum of angles about a point?
360.
360.
360 degrees. So if I know what the black angle is, what do I do to find this angle then?
Subtract
minus
that
from
360.
Yes. Look, you see, look how I get in it. So how would I find this angle over here?
Minus it from
65
180.
from 180.
Yeah, I would say 180 minus 65. And what's that?
115.
150.
Right. Good. And so, if that is the case, could I now find the bearing from Rajiv to Lucas?
Yes, sir.
Yes.
Right.
Yep.
So this is what they would do, right? They might ask you to find the bearing from Rajiv to Lucas. So you see, I switching the directions. Now I'm going from Rajiv to Lucas. So here what? If you see the word from Rajiv, we're gonna go to one time. Where am I gonna go to?
The north at Rajiv.
At Rajiv.
Right, and I'm gonna start to measure in what direction?
Clockwise.
Clockwise.
Direction.
Until I hit the line connecting
The angle.
L to R.
The L
R
to
to
R.
Right. I'll big up all this self, boy. All I get in this. Nice. So, how would I find the purple angle then? Somebody tell me.
360 minus
150.
150.
360 minus 115. Okay, if you're confused, right, here what? This is 360 is a circle. You want to see, you just say a point, right? At a point. I hope you can see the circle. We know that this is 115. How do we know that? Because co-interior angles must add up to 180. So we figured out that this was 115. This piece is 115. But the whole thing had to be 360. So to find the missing piece over here, which is what we're interested in, yeah, I said 360 minus 115. And what again?
245.
45.
Right. So the bearing from Rajiv to Lucas is
240.
ah boy. How you feeling about bearings, guys? That's the whole concept of bearings, you know.
Easy.
That's the whole concept of bearings. And if you do understand it, we will look at some more examples. Don't worry. So I'm gonna give you an example, right? So the bearing who we have in the Zoom, boy? We are in the Zoom. You know, yeah, can I hear you now? Yeah? I see in Kiel raise her hand. Yeah, Kiel.
Yes, sir. It's Kelly.
Kaylee.
Yeah.
Okay. Tell me if you don't understand our parts. How you feeling?
Just from like the 360, why would we like just like this?
Good. Say that again.
I don't know how to explain, but like, why would you just assume you have to go for a circle?
Wait, I'm struggling to hear, but I believe you're confused as to why we saying 360 minus 115.
No, like how, why we just like go for a circle and get the 360?
Why we don't just got struggling to hear. I'll try to go over the concept one more time. So number one, co-interior angles must add up to 180. So that's how we found the 115 over here. But that is not the bearing, because the bearing is from the north line in our direction. What direction, guys?
Clockwise.
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 Right, so that is this angle over here. So if you want to find that angle, you just say 360 minus 115 and you get your answer. Yeah. So let me look at another question, right? So the bearing from anybody want to sacrifice a name? Not sacrifice a name, but give me the name.
So me,
Anybody?
Risha.
Shania.
Right. All right. So Shania and Renisha, big up for yourself. So the bearing from Shania to Renisha, give me an angle.
75.
75. Okay. One moment. Have anybody on TikTok? I mean on YouTube? Have anybody on YouTube? I wonder if it have anybody on YouTube, boy. I don't know what's going on YouTube. Can't see anything. Yeah. But I will let me know what's going on YouTube, right? So the bearing from Shania to Renisha is give me an angle.
75.
Okay, it's
75.
75 degrees. So where are you guys seeing the word from by? Where seeing the word from at? Where seeing the word from?
Shania.
Shania.
From Shania. So I'm gonna put on a point, and who are gonna put by the point?
A note line.
An
Wait,
outline.
before that, I'm gonna put Shania over here. Right? I'm putting on Shania over here because this is the from point. From. And so I'm gonna put on my note line. I'm gonna put on my note line. And if I want to go from Shania to Renisha, I had to take a bearing on what?
75 degrees.
75.
Clockwise.
Would I measure 75 degrees like this?
No.
No,
sir.
so that's
You
anti-clockwise.
have to go clockwise.
Right. So the angle might be somewhere over here, right?
Yeah.
Right. So let me measure it. Right. So all it tell me when to stop, right? All it tell me when to stop.
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 Right. I hope you understand what I do, you know. I hope you understand. From Shania, I start from Shania, I put on an outline, and I measure how much degrees in a clockwise direction.
75.
75 degrees.
Right. I promise all your bearings not hard. Bearings not hard, guys. Come on, bearings not hard. Or you could do this. And this point over here, this will take me to where?
Renisha.
To me.
Yes, to you. Now, let me switch up the scene, right? Let me switch up the scene. Let me just say I wanted to find the bearing. So you want to find the bearing from Renisha. Hey, I switch up the scene here. From Renisha to Shania. Somebody, am I unmuted? Sheila, am I unmuted? All right, thank you. So the bearing from Renisha to Shania is question mark. How are we gonna do that? How are we going to do that? Oh, wait, before we move on, we're supposed to label the angle here, right? So I will put an arrow here going to the traversal, and I'd call this what?
075 degrees.
075 degrees. That's the way you write bearings. Now I admit in some of my videos on YouTube I didn't really bother with the zero, and I accept accountability for that. It should have the zero. It should have the till zero. You know, if it's a 2-digit number, it should. right? Don't forget that. So, Renisha, in the second question there, where you see the word from by? Where you see the word from? Where you see the word from?
From by Renisha.
From by Renisha, going to where?
Shania.
To Shania. So here what? You see the word from, put on an outline by who?
Renisha.
Right? You can put on an outline by Renisha. And if I want to find the bearing from Renisha to Shania, I'm going to start from the north line and I'm going to go in what direction?
Clockwise?
Right. Like this?
Wait, hold on. Wait.
No, the other
Wait.
side, the other way.
No, sorry, sir. Anti-clockwise. My bad.
No, you was
Clockwise.
correct. You was correct.
Clockwise. No, this is wrong, guys. I can't stress enough. This is very, very wrong. That's very, very, very wrong. I trying to see if Olia know what they're doing, right? Like somebody said. Because I hate when I ask a student that question and the only thing I hear from them out is yes. If I tell you to jump over a cliff, you're gonna say yes? No, you're not gonna say yes. You're not gonna say yes. So let's think before you answer.
When I said that, I was like, wait, hold on. Something in right. And then I changed it. So
Just because I say something, that don't mean I have to be correct. If I tell you gravity is 0 meters.
Kimora, leave me
Am I
alone.
wrong? Earlier. So I need to think, right? So Renisha, we always measure the bearing in what direction? Clockwise or anti-clockwise? Clockwise or anti-clockwise?
It's clockwise.
Right, clockwise. So imagine you're checking time.
Clockwise.
You're checking time. That way you're checking time, right?
Yes, sir.
So Renisha, this is the bearing, right? How are we gonna figure out that bearing? How are we gonna do that? How are we going to do that?
Find the bearing. So
Minus 75 from 365 from 360.
360.
Nah.
No, 180.
180 minus 75.
Yeah, 180 minus
Yeah,
75.
and then you
That's it?
and then minus it from
Yeah.
360.
Yeah.
Right, so here we're gonna happen, right? Here we're gonna happen, guys. If I knew what this black angle was, what would I do to find this bearing?
Subtract.
Subtract it from 360.
Right.
Subtracted from 180.
And which rule is this? Which rule is this over here?
Co-interior.
Co-interior angles.
Add up to 180.
Right, co-interior angle up to 180. Right? Okay, cool. Right? Alright, cool. So, what would this angle here be? Let me make it tell no?
105? 105.
Right. Because it will be 180 degrees minus 75 degrees, which is what?
105.
Good. And so if this angle over here is 105, what do you suppose this would be?
255.
255. 360 minus 105 is 255.
Right. 360 degrees minus 105 degrees is 255. Now here they said when we're doing bearings, we had a touch on sine and cosine rule. Because all of these bearings questions, the first part is cosine and the other part is sine most of the times. Alright? So, in other words, the bearing from Renisha to Shania what's the bearing? What's the answer?
255.
255
degrees.
Right.
So
now let me show you.
I try it.
You understand it or not?
Yeah, I understand it.
Alright, good. Now let me show you guys another. Yeah, talk to me.
How did you get 105 again? I missed out on the fact.
Alright, so Dina, the angles here must add up to what?
180.
It must add up to 180. So if this one is 75, right? What do you think this one will be?
75 as well.
No. They must add up to what? What do they must add up to?
180.
Right. So if this one is 75, what would I have to put here to get 180 when I add it?
Oh, 105.
Right, 105. So I just say 180 minus 75 and I get this angle. Right? Cool. Let me show you guys another way you could answer the question, right? Another way. Guys, what angle is this? What angle is this?
180
180
degrees.
180 degrees.
Right? Stay with me. Stay with me. Stay with me. I don't know if all you could see this, right? All you see in your alternating angles.
Yes, sir.
Yes,
So what this angle will be?
75 degrees.
95 degrees.
75.
What this angle here will be?
180.
90 degrees.
Where's 180 plus 75?
255.
255.
Yeah, that's another way you could work it out too. Using the alternating angles and the 180 degrees. Yeah? Nice, man. How you feeling about bearings, guys? You good?
Cooking.
Real
Yes,
good.
easy food.
Right, so I would have answered the question from January
So I
2026.
would like to say we're not cooking yet. We're boiling on the stove. We're boiling.
Okay, I'll put the
I
ingredients
still
here.
boiling. What you stupid for? I still boiling. I ain't cook yet.
All right, no problem. Let's do the question from January 2026, right? So, Renisha, you real have to correct me with the way I say this word, boy. You real beat me down on that, boy. You remember how she beat me down yesterday?
Boy,
Yes,
is
sir.
mommy and the homophone is boy and boy. Boy, B-U-Y. B-U-O.
B-O-U-Y is on the
Yes.
C.
Right, that is the one on the C, and then the
English
O-Y
vibes,
is
boy.
boy.
Best I call this English vibes, boy. English vibes? Wait.
Sorry.
English.
Nah, sir.
Nah, math song is better. Math song is
I
better.
find so. So, let me read the question fast, right? A
Yeah.
boy and a lighthouse are 95 kilometers apart. The bearing of B from L is 230 degrees. Hear what? When you read that, I want you to look out for the word from. Where you see the word from by?
B.
L.
Whoa.
L.
Yeah, I'll
Wait.
take your time now.
Wait. Hold on.
B
L.
from
B
Wait,
is from list 2.
The bearing of B from L. Entered
wait.
and from after B and it before
From,
L.
yeah. So from L.
From
I'm telling you,
L.
from L.
All right. So it's
From
starting
L.
from L. From L.
Exactly.
Right.
So they already labeled it for us here. You see L over here? Yeah?
Yes, sir.
Right. And it's saying the bearing is?
230.
230.
Here what? Let me do a little sketch, right? Let me do a little sketch rule. So I'm gonna call this point L, right? I'm gonna put on my note line. And 230 degrees, is that less than 180 or more than 180?
more than 180.
Right, Renisha, 230. That's less than 180 or more than 180?
More.
Right.
230 is
So,
more than 180.
so remind me, when we doing bearings, right? We always start from the north line and we go in what direction? What direction we just go?
Clockwise.
Clockwise.
Renisha, clock it, right? Let me run through the rules one time. Wherever you see the word from, you put on your north line. Put on your north line. From, put on your north line, right? You measure the angle in a clockwise direction from the north line. From north line. Please remember this. Please, guys, please. Because
So
this is
you
one
think
thing.
parents coming to see actually?
Hey, even if it come or it don't come, you should be prepared for it regardless.
Still studying it.
Let we not
I'm
go with
still
that. Let we
studying.
not study them kind of thing. If
Because
you
if
had
it,
study, if you had a study, if it coming or not, you're not ready for it. Hey, just be ready for it. That's my advice. Just be ready for anything. Right? Just be ready for anything. Make sure you know your work. I'm not gonna give all you any advice as to like predictions and things. Just learn all your work. Right? Just learn all your work. You sure? Yeah, see, raise your hand.
Yeah, hi sir. Just watching the YouTube chat. People asking what we're doing today.
All right. So today we will be doing bearings. Right? Bearings, measurements, right? And vectors. This is what we're gonna do today. Right? So right now we're on bearings. After bearings, we're gonna handle up. Wait, let me ask all you. Are you wanna look at measurements first or vectors first?
Vectors.
Vectors. We get the predetermined topic
Okay.
out the way and then do the least one last.
The least one last. Let me see what happened on TikTok. TikTok, what do you want to do? TikTok. I'm looking at all the TikTok. Measurements or vectors? People on the TikTok, measurements or vectors? Oh yeah, let me know fast. Oh, let's stick in, boy. Let's stick in.
If only they had an icon like this way, could
So
talk
if you
about
jump,
like
if you
People
pick, so
saying
you pick.
measurement.
I hear real people saying measurements. Hear what?
Yeah,
Vectors.
you pick, so you pick.
Hear this, hear this. Vectors low key easy. And I know they'll come from with all the pitchforks and thing, eh? But vectors low key easy, right? Vectors is just directions.
So,
All you know how to travel. All you know how to
Yes.
I
travel.
think we should do all the
Yes.
directions and everything first to get out the way.
Okay, no problem. That makes sense. Because vectors and bearings the concept is similar, right?
They go
Vectors.
hand in hand.
Right. Anybody from south side over here? From South Trinidad?
Yep.
Yeah,
yes,
Right. Big up South. Big up South one time. Big up South one time. Big up Baby. Big up Penal one time, right? Let me ask you a
Yeah,
question.
Southeast in here. It had no
Yeah.
central, no north. Hey.
I show you that central and north people, right? But hear what? If you want to travel to Port of Spain, and you have to go from DB to Sando, and then from Sando to Port of Spain,
Yes, sir.
Yes, sir.
that is vectors,
That's the
guys.
only
That's
logical
vectors.
thing. That's the only
That is
logical
vectors. Vectors is just logic. Easy. What does make it look complicated is the fractions and the letters.
And
That is
them
what is
shape
make
that is okay. Them improper shape that is be shaped like people who improper.
Huh?
Renisha,
What?
I doesn't know what to say about Renisha, yes? Anyways, let me continue. So, Renisha, we're going to measure the angle in what direction? Clockwise or anti-clockwise? Get it right this time. Clockwise or anti-clockwise?
Clockwise. Clock it
Right.
clockwise.
So, I am going to measure. Tell me when you think is more than 180, right? Tell me when you think the angle is more than 180. Over here is more than 180.
No.
No.
Over here is
That's
more than
less.
180.
That's
Over here is more than 1. Right.
no.
How about here?
Yes, sir. That's more than 180.
Yeah, that's more than 180.
So that looking like it might be 230, ain't?
Most likely, yes. But
Yeah.
I'm not too sure.
So,
So you teaching here and they teaching in the group chat.
well, let them teach, right? Let them teach. Okay, I focus on my mission, right? Yeah. So, Renisha, do you understand
sir.
that 230 degrees might look like this? It might look like this.
Yes, sir. Yes, I do.
Okay. There are two ways you can think about this, right? Two ways. I'll let me know which one I prefer. So if the bearing here is 230 degrees, I'll live with me, right? If that is 230 degrees, what do you think this will be?
360, if I'm correct.
230 minus 230.
Right, 360 minus 230.
230.
Right.
And that is
130.
130 degrees.
130 degrees, yeah.
I'll live with me, right? So this piece over here, this is 130 degrees. And if that is 130 degrees, and this would have to make this other piece what?
230.
Right. So let me show you a hack, right? And when you do this hack, you'll have to avoid using your protractor twice. Because I'll show you what most people are going to do. This is what like the 1% would do. So our bearing was what again? 230, ends?
230 degrees, yes.
Right. And how far is the boy and the lighthouse?
95 kilometers apart.
Right, and they gave us a scale, right? 1 centimeter to 10 kilometers. So how much centimeters do you think we're gonna put on?
9.5.
I put on 9.5, right? We're gonna put on 9.5. Cool. Right. So here what? Let me do this thing here, right? So bam. Or let's tell me when you think it reach 130. So we starting off at 0 degrees here. Tell me when all you think reach 130.
So 130?
130?
You go understand why I'm saying 130, right? So this is 130, yeah?
Ready.
Yeah.
Now, are they probably saying, sir, you lost me there, boy, you lost me there. We start off with 230. We start off with 230. Where you get 130 from, boy? Let me ask you that question, right? If you know that this is 130, what would this be automatically?
270.
Somebody said 270. Nah, 230.
It's 230. That's 130 plus, well...
Let me go through the logic one more time, right? Or like here what I'm saying. If we know that this is 130, right? Remind me, what is the sum of angles about our point?
360.
360, right? 360. So if I know this entire thing is 360, yeah? And I know that I already know that this is 130. What would that make this other angle?
130 because it just moved 130.
230.
230. If you do understand it still, I'm gonna explain it one more time. So this angle over here, we know it is what? We know the angle is what?
130.
And we know that the whole thing's supposed to add up to what?
360.
360.
Right. So if you want to find this angle over here, you're going to say 360 minus 130. And that would automatically give you the what?
The 230.
230 degrees.
230.
Right. Are you understand what I was going with it now?
Yes, sir.
Yes, sir.
Right. Because let me explain something, right? Your protractor. What is the biggest angle it can measure up to?
180.
180.
180.
But the bearing here is 230. So if you was gonna do the other way, most students would do it, you'd have to use your protractor twice. But if you think outside the box, you realize you could just do this and do it in one shot.
Yeah.
Right?
Makes
So
sense.
what did we do? Well, we measure 130 degrees here. Do you guys understand that is not the bearing?
Yes,
That's
sir.
not the
Yes, sir.
that is not the bearing. That's
because
not
going
the bearing.
anti-clockwise.
Right. However, it's taking us to the same place. So this is 130 over here, and well, automatically this is 230. And this is the bearing 230.
Yes, sir.
Yes, sir.
Yes, sir.
Good. I'll show you guys the other method just now. But we're gonna put here
230.
30 degrees.
230 degrees.
30 degrees.
And how did we figure that out, right? How did we do that? Well, we know that this is what? What we know that is?
We know that it's 150.
Right.
Yeah, that's 130.
Good. And they said it had to be 95 kilometers apart, right? And they say 1 centimeter to 10 kilometers. So we had to use 9.5 kilometers. So I'm going to Summer. Nah, way boy. 9.5. Yeah, boy. So 9.5 looking like is right here, yeah?
Yes,
9.5. Right here.
Yeah, right there.
And so what would I call that point? Somebody tell me.
B. B.
That would be point B.
Yeah, this could be point B.
Boy.
Right. I'll be point B. And what should I put for the distance here?
One more time, please.
No problem, I'll do that. Don't worry, Sarah. And what would this distance over here be from here to here?
95 kilometers.
95 kilometers.
95.
Right. Cool. So Sarah, let me run through the thing one more time, right? When you read the question, and by the way, this is like a outside the box thinking kind of way, right? I don't think most people would do like this. But it's the easiest thing once you see it. So Sarah, where you seeing it from?
From L.
From L. So the north line is by where? Where's the north line?
By L.
Right. And it's how much degrees?
230.
And this would take me from L to
B.
L to B, right? Now is 230 degrees less than 180 or is it more than 180?
More than 180.
Right. And your protractor only measures?
180.
So you'd have to use it 2 times then. So to avoid that, Sarah, here what I'm thinking, right? Remind me, what is the sum of angles up for a circle?
360.
Okay. Okay, so here what I could do, right?
Mm-hmm.
I can measure from the other direction. I could measure 130 here. And if I measure 130 here, right, Sarah?
Mm-hmm.
Or would I automatically make this?
360.
No, wait, Sarah. What does all the angles have to add up to, Sarah?
360.
Right, the full thing is 360. And if I put that this is 130, automatically, what does that leave this to be?
230.
Right. Isn't 230 bearing?
Yeah.
Right, so you understand the logic.
Okay. I see what you mean. Okay.
So if I could measure 130 over here, then automatically, Sarah, what would I make this angle here?
230.
Right. Yeah. Now let me show you guys the other method, which most students would do. So I'm gonna put down the node line here. And do that. Right, so Sarah, stay with me, right? So if I want to do 230 degrees, and I using my protractor. The protractor only measures how much degrees?
180.
180 degrees. But 230 is 180 degrees plus what?
130.
Nah, not 130.
Oh, wait,
So
sir, what
50.
question?
50.
Yeah. So, Sarah, if you want to figure that out, you could just say 230 minus 180. 230 minus 180.
Okay.
And what would you get? Do you think your calculator now? Do you think your calculator now? Don't stick. 230 minus 180.
Okay, sir, let me find my calculator.
Are you find Renisha a bit too comfortable, Olya? Are you seeing Renisha, Olya? Are you seeing she?
Yes,
I
sir.
find so
Way too
too.
comfortable.
Like she in her exam
Way
today,
too
sir.
comfortable. Get up.
I don't know what to say about Renisha, Olya.
But so why do?
People on TikTok, are you seeing Renisha right now? People on TikTok, are you seeing Renisha, right?
I find only on my case so
Renisha
much,
is an
you
educated crackhead.
Renisha, this is bullying.
Yes, cyberbullying.
Olya, let me continue now. So, Sarah, where's 230 minus 180?
What he gonna say about me?
Hey, Dina, I'm not talking about you.
50.
Talking about Sarah. Right, so Dina, I see no. Oh, I'll tie up my head, like.
Oh
Yes,
my God.
Sarah, it will be 230 minus 180, right?
Yes,
Dina, if you're not
50.
talking, mute your mic, right? If you're not talking, mute your mic. So 230 minus 180 is 50. So, Sarah,
Mm-hmm.
hear what I'm trying to say, right? Hear what I'm trying to say.
Mm-hmm.
Stay with me. Stay with me.
Mm-hmm.
You know that this angle here would automatically be what?
180.
Right, 180. So
Mm-hmm.
to make the 230, how much should I go again?
50.
50 again. Yes. So I'm going to put on my protractor over here. And how much more am I going to go?
50.
I'm going to go 50 more. Correct. So you tell me when to stop, right? You tell me when to stop. So, okay, does everybody understand that so far we already have 180 in the bag? We already have 180 in the bag. Watch. 180 in the bag down there. Yeah?
Yes, sir.
All you
Yes.
understand now, all you don't understand now. 180 already in the bag.
Oh, yes, sir.
So we understand.
Yes, so we
Right.
Check
understand.
up.
I
When you
Right.
say get up, take off the
Just-
blankets.
Right. So, Sarah, tell me when to stop, right? And we kind of have to see. Give me a second.
Yes, sir, I could see from there.
Tell me when to stop, right?
Mm-hmm. Right there. Yeah.
So let me go through the logic here. Let's go through the logic quickly. So we already know that this is how much degrees,
180.
right? And I want my bearing is
230.
right 230. So I would have to go how much more?
50 degrees.
50 degrees more, right? And I would take me to 230. Make sense?
Yes, sir.
Right. And altogether, this would be what?
230 degrees.
Honestly, what do you prefer? Or you prefer the first method or the second method?
So the first method
First.
easier or
method,
less work.
easier.
First method. First method.
The first
It's,
method.
First.
it's just
First
that
one.
I don't know how much I'll go think about that. I feel like that's an outside the box kind of thing to do. Because all you know that bearings is clockwise, right? So I don't think most of you guys will think to go the other direction.
Yeah,
I don't
that is
think
true.
people do.
That is true.
So
Yeah, talk to me.
you can go by the second method. I didn't quite understand what you do.
Okay, no problem. That's the thing. I feel like if all you do the question, mama, and all you take all the time, there's no room for confusion. I think this all you want to show you what I think is hard. Because I think it's easy, you know. I think it's easy. When we
Yes,
do in
sir. I will
vectors,
see what you think is hard.
when we do in vectors and they have those multi-step problems with collinear and they're asking your ratio, all kind of thing, that is why I call hard. And it would tire people. But this not hard. Right. So who was confused? Somebody was confused. All right. We're gonna run it over one more time, right? One more time. So our bearing is what? From L, our bearing is what?
230.
Right, 230. Our protractor only measures what? What does our protractor only measure? Up to what?
180.
solid with me there, right? The protractor only measures 180 degrees. Only 180 degrees. But we need to measure how much degrees?
230.
230. When you draw the note line already covers how much degrees?
230.
Whoa. Take your time. Take your time. What is the angle on a straight line?
180.
Right. So we know the straight line. The straight line is what?
180.
So we already have 180 in the bag. But we need to go to.
230.
So how much more would I need to go to reach 230? So I have 180 in the bag, you know. I have 180 in the bag. I need to go to 230. So what do I add next?
50 degrees.
I have to go 50 again. And so this angle over here, we think this angle over here is 50. So we have the 180 over here. We already have that. You don't have to do anything. You know that is 180. And you just measure this 50 and bam, 230. Adds up to 230. And watch. If I measure the angle here, what should it be?
50.
Are you seeing it?
Yes, sir.
Right. And this angle over here is
180.
180. So 180 plus 50 gives me
230.
right. Hopefully you understand that. So we're gonna move on now. Just like that, all you understand the whole concept of bearings. Great. That's the whole concept of bearings, right? That's it. That's literally it for bearings. You don't know anything else again. Now we need to look at sine rule and cosine rule. Because that's coming all the bearings questions. So we use sine and cosine rule anytime we're dealing with what kind of triangles?
Right angle triangle. Right angle
Triangle.
Now I hear people say right angle triangles, but that's
Non-right angle triangles. Non-right angle triangle.
All right angle triangle.
if you watch my YouTube video, you will hear me say this a million times. You do use this for right angle triangles. You just use trig ratios and Pythagoras theorem for right angle triangles, but you do use this for right angle triangles. You
So
don't.
is this equilateral triangles?
Well, an equilateral triangle will be a non-90 degree angle triangle. Because if it's equilateral, all the angles is the same. 180 divided by 3 is 60. So all the angles will be 60. So yeah, you could use sine and cosine rule for equilateral triangle.
Isosceles, you can use it for isosceles.
Here what, right? Once it don't have a 90 degrees in the triangle, you could use sine and cosine rule. Right?
Oh, so you could also use this for irregular triangle?
You technically could. You could. Because sine and cosine rule are generalized formulas that work for any triangle. Yes, you could. But I mean, let's just use Pythagoras theorem and trig ratios. But let me show you something, right? I can't blow all your mind here. If it are people that like maths here, they will appreciate this a lot more. So, but it's fine. I'll show everybody it. The cosine rule. Anybody know what the cosine rules look like?
A squared equals C squared plus B squared minus 2BC cosine E.
Now, let me ask you a question, right? You can tell me what Pythagoras theorem is.
A squared plus B squared equals C squared.
Squared plus B squared.
Well, I'm gonna say a squared is equal to b squared plus c squared. It means the same thing, right? It means the same thing.
Yeah, it's the
Right?
same thing, basically.
But it would have to be the what for the right angle triangle. It would have to be the what?
Hypotenuse.
No, I can't blow. This is what I can't blow all your mind, right? This is what I can't blow all your mind. So this is Pythagoras theorem, and we use Pythagoras theorem for what type of triangles?
Right angle.
Angle triangles.
Right. That's what we just do. I tell you, the cosine rule is a generalized formula. It works for any triangle. So let me show you something, right? Stay with me. If you're dealing with a right angle triangle, what do you think the angle here gonna be?
The included angle.
Yeah, but just a right angle triangle, right? So it's a right angle triangle, and they're trying to find the hypotenuse.
90 degrees.
90
degrees, right? So let me show you something. I don't know if I could see it, right? But and the cosine rule kind of looks like Pythagoras theorem. Low-key.
Yeah,
sir.
like the
Watch
beginning
this.
of it.
Yes, sir.
Watch this, eh? For a right angle triangle, what the angle will be? How much degrees?
90 degrees.
90 degrees.
degrees.
So let me show you something, right? Cosine 90. So this cosine 90 is 0. Where's anything by 0?
0.
0.
So for a right angle triangle, you get a squared is equal to b squared plus c squared, which is
Pythagoras theorem.
Pythagoras theorem.
So the cosine rule is a generalized version of Pythagoras theorem. Yeah. I don't know if you see that, right? Cosine 90 is what? What's cosine 90?
0.
And then you have minus 2bc by 0. But we don't care where you multiply by 0. Anything by 0 is what?
0.
Yeah. So that will make this whole thing 0. So we end up with.
Pythagoras theorem.
Pythagoras theorem.
Yeah. I surely didn't know that. Right? Cosine rule is just a generalized version of Pythagoras theorem.
I like that.
Yeah. All right. One of these days I want to do a live where I delve into the deep concept behind math. So like deriving cosine rule, deriving sine rule, all these madness. Yeah. So this is where you know cosine rule to be. And sine rule is generally look like A over what? A over
Sine A
Sine
equals B over sine B
sine B.
equals C over sine C.
here what? If it's looking scary, don't worry. I have all your hands. We will make it through and we'll get through, right? It'll be okay. I know it's looking complicated, but it's gonna be okay. Promise. So this over here is the what rule?
Sine rule.
Sine rule.
This is the sine rule. And this, what's this?
The cosine rule.
It's cosine rule.
Cosine rule.
Now again, when do we use these rules? When we have a what kind of triangle?
Any triangle except right angle triangles.
Well, you could use it for right angle triangles. You could, like I just showed you, you could. But we typically use these formulas for triangles that don't have 90 degrees in them because they are generalized formulas. So I could use these formulas for any triangle I want. Absolutely any triangle will work out. But in our use case, we typically use it for non-90 degree angle triangles. So use in non-90 degree angle triangles. But you should know in brackets that these could actually work for anything. Actually works for anything. But we typically use it for? We typically use it for what? In C-sec maths, we typically...
Any other
Non-90 degree
non-90
triangles.
degrees angle.
Right. So cool. Here what? Let me run through the cosine rule first. So okay, if you do know what a non-90 degree angle triangle looks like, that's fine. Let me show you what I mean. So everybody could recognize a 90 degrees by the L shape.
Yes,
Yes,
sir.
sir.
Yes, sir.
Alright. If you do see that L shape, is it 90 degrees?
No.
No. Alright. Keep that in mind, right? Keep that in mind. Are you seeing the L shape anywhere here?
No, sir.
No.
No.
No, sir.
Right. That's not a 90 degree angle triangle. Right? So I would say this is not a right angle triangle. Here what? If somebody say a right angle triangle and a 90 degree angle triangle, it means the same thing, right? A right angle means 90 degrees. Yeah?
Yes.
Yeah, right angle and 90 degrees mean the same thing, right? So if it's not a right angle triangle, why do you use one time? Tell me, guys.
Sine and cosine rule.
Sine or cosine rule.
Right. Let me show you.
Cosine.
Let me draw another triangle here. Are you seeing the L here?
Yes, sir.
Yes, sir.
Yeah, I see the L, you know, guys. I seen it right here. So like, gosh, man, good notes. But we talk about this in our good notes. We had a conversation as a class. I tell you, stop playing up.
Bad notes.
Bad notes, bad notes. Right. So, is that seeing the right angle?
Yes, sir.
Yes, sir.
This is the right angle we're talking about. This is the right angle or the 90 degrees. What would we typically use for this? A right angle triangle. What would we use for that right angle triangle?
Pythagoras.
Trig ratios.
Right. You would use Pythagoras' theorem,
Yeah, trig ratios.
or you could use trig ratios.
But we use Pythagoras theorem if we have two known sides.
Right.
Yeah, we use Pythagoras when it had two known sides.
And you use trig ratios when you're trying to find for an angle, or if you have a non-90-degree angle and one length. Yeah. So cool. So would I typically use sine or cosine rule for this?
No.
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 Yeah, Shaya, see, raise your hand. Talk to me.
You could just big up the YouTube chat a little bit because they're feeling neglected.
Oh shucks. Sorry, people. Wait, here what, right? I have two phones. I'm gonna make use of it. I'm going to pull up the YouTube chat. Yeah, I'm pull up the YouTube chat. So let me see what's going on in the YouTube chat.
So,
This is,
There are 206 people on there.
this is why streamers have more than one monitor.
Well, now I literally went. I literally went and buy a new phone just for the purpose of this month. That is what I literally do that. People in the chat, I seen all there, right? I seen all there in the chat. God is good. Bro talking to good notes, but not us. Oh my God. Hi, sir. Finally. Yes, I've seen all that.
so I have a question.
It's something like Romano was shaming you for neglecting your YouTube trend.
Oh, yeah.
It wasn't Romano though. It was
Wait, let me drop something in the chat. Love you guys. Love you guys.
So
Yeah.
I have a question.
Yeah. Talk to me.
But wait, what you say we just typically use the Pythagoras theorem and the trig ratios for?
Right angle triangles. Right angle triangles.
No, when they say that you have to calculate trig ratios with no.
Wait, yeah. Let me explain something, make it real clear, right? Let me make something real. If you have all you see this, all you see in the upside down L, all you see in that? All you see in that, right? Let me know if all you see in that. All you see in it, right?
Yes,
Yeah.
sir.
If you see that in your triangle, it's a right angle triangle, right? Let me just get out of the way. It's a right angle triangle. Right angle triangle. It's a right angle triangle. And what I'm saying is, if it's a right angle triangle, you could use Pythagoras theorem. But I think you're asking about when you would use Pythagoras theorem, right?
Yeah, that's right.
Or it's like, I see somebody say, guys, we officially have side piece now. Yeah, I'm going to do past papers just now, guys. So you use Pythagoras theorem anytime you have two sides, two known sides, right?
Okay, so
Right. So like if I give you a length here, say 10, and I give you a length here 5, you could find for this. If I give you a length 10 here, I get a length 7 here, you can find for this. Pythagoras theorem. Two known sides. And Pythagoras theorem is only used to find for another length. Lock that in, right? We only use Pythagoras theorem to find for our what?
other length.
Right. Find for a length. No angles, all the no angles. None. We're not using this to find for angles. No, we're not using this to find for angles. If they ask you for an angle, Pythagoras theorem is not your friend. You have to use trig ratios.
Yeah.
Right? And to use trig ratios, here are the conditions, right? You must okay, if they ask you for an angle, right? For an angle, you must have two known sides. You know why? Because let me give a simple example, right? Sine theta is equal to over h, right? If I tell you O is 5 and I tell you h is 7, what is the only unknown there? Don't tell me sine is an unknown. Sine is a function.
The angle is the unknown.
Theta is the only unknown, right? So, and in maths, if you want to solve one equation, you need one unknown. So that's why I'm saying if you're trying to find for an angle, you need two known sides. If you have to find for a length using trig ratios, you must have a non-90-degree angle. And you must have at least one length. So I think that's what he was asking. So anytime you have a right angle triangle, this is what you have to do. Pythagoras theorem if you have two known sides and they're asking you to find for a length. Trig ratios, if they're asking you to find for an angle, you must have two known sides. If they're asking you to find for a length, you must have a non-90-degree angle and at least one length. So have this locked in. Good. Alright, we're gonna move on to non-90-degree angle triangles now. Yeah?
Wait, sir. Can I take a screenshot of that, please?
Take a screenshot. People on the YouTube, are they good? Wait, boy, nearly 300 people on YouTube, boy. That's crazy.
Thank you, sir.
Big up people on YouTube. Let me check the scene on TikTok. We're going on TikTok, all
144 people on TikTok.
That's crazy, boy. Mass vibes to the world, all Make sure you like, subscribe. People in the Zoom, tell them how it does go. Tell them how it does go. I don't want to be saying it.
It has been going like Michael Jackson song.
It's good. It's
Skinny
good.
jeans.
I don't think the joke line no more, and I just laugh and now.
Oh me, oh gosh, I don't like Bob, so I'm up to you, girl.
Yeah. All you had to like, subscribe, share, tell your auntie, tell your uncle, tell your sister, tell your brother, tell everybody.
Tell your great grandmother.
Tell your great grandmother. Mass vibes is the boss.
Excuse,
Right?
sir.
Yeah, talk to me.
Sir, you wouldn't
Yeah.
be sending this document in the group?
I just send all the documents in the group. I just send every
Okay,
single
thank
document
you.
in the group. Let's move on. So if you have a non-90 degree angle triangle, the first thing you need to do, my friend, you need to know your label in your triangle. That's the first thing you need to do. So we use capital letters for angles. We use capital letters to denote angles. Capital letters to denote angles, right? Now we're doing capital letters to denote angles. And we're using common letters to indicate what?
Sides.
Sides. Sides and length, any way you want to say it, right? So let me give you a quick example. If I call this angle A, so this is angle A, right? Then the side opposite to would be the corresponding length. Because, okay, again, if you're a math person, you'll understand what I'm saying. Because this length, because the angle here is subtended by this length. If you're not a math person, it's fine. All you have to know is the angle here, the corresponding length would be on the opposite side. So if this is angle A, what we will call this? We're calling this.
Baby.
Right.
Baby.
My students have a habit of saying baby A instead of common A, right?
Yeah.
So bear with them.
Sir, it's
Right.
more fun.
Yeah, I suppose it's more fun. If this is angle B, what would I call the opposite length?
Come on.
If I call in this angle C, this is angle C. I call in this.
Baby
Come
C.
on. Come on, see.
Right. And you guys understand how I did that, right?
Yes, sir.
That's the first thing you need to be acquainted with. You need to be able to label your triangle if you're dealing with a non-90 degree angle triangle. Alright? Hey, Olia, we're doing this, right? But please don't forget about bearings because you have to utilize sine and cosine rule in bearings. Okay? So, like I said, let me start off with the cosine rule first now. Let me hear, most of you have a sharp or a Casio?
That's
Yeah.
Casio.
Sharp.
Yes.
Oh no.
Wait, Jaime, you have a sharp or a Casio?
I have a second edition Casio.
Sharp to the
Wait, Jaime, you have a sharp, boy?
I had to see my face. I had to see my face, but I had to see my face.
they hate again sharp users.
Wait.
The
I
audacity.
mean, I'm not gonna lie. I still have my sharp, but again, my Casio soon.
By sharp done by one sharp.
Romano, you're making the good choice. Trust. Casio on top. I'm so sorry. Casio on top. You're making the right choice. Trust.
The
Trust.
Casio
I don't-
founder, it's
hey.
just not in my location
Wait,
yet.
I don't think all your sharp people understand the things you can do to a Casio, and that's why all acting like that.
Exactly. I've had a
Oh, yeah.
Casio since third form, and that thing has done so much.
All you know a Casio could solve equations on fair, right?
Yeah.
Yeah. Alright. Well, let me
You just
continue.
plug
Let me
the whole
continue.
equation in, and you would get the answer.
You don't have to put no brackets or nothing. You get entry. Get the answer.
Exactly.
You don't have to hurt your head over nothing. Where's brackets on, boy? You don't have to worry about them thing. Right. Let me continue. So cosine rule. My friends, where do you use cosine rule? Anytime you have
Whenever I
You have
include
two
an angle.
lengths and an angle.
If
That angle.
You have an include angle.
now the next question is people gonna be saying, but what do you mean by included angle, boy? What I mean?
When it's between two known sides.
When an angle is between two known lengths.
Exactly. So an included angle is anytime you have an angle between two known lengths. And this will allow you to find for the side length opposite the included angle. So let me give you an example, right? These are examples. Let me call this DF. Alright, let me call that DF. By the way, big up all the moms that are watching this, that are supporting the children. Big up all the moms. Happy Mother's Day. Forget to say that. Big up the moms. Alright, I see my mom come and bring watermelon from her. Big up my moms one time.
So my
Right?
mother said thank you.
Alright. Yeah, but nice. So, guys, if I tell you this angle here, let's just say it's 39, right? And I tell you that this is 5 centimeters, and I tell you that, hey, this is 6 centimeters. Then what would be the included angle here?
39 degrees.
Right.
39.
Can everybody see that the 39 degrees is sandwiched in between two known lengths?
Yes,
Yes.
Yes.
Yes, sir.
Yes.
Right. So that would make it an included angle. So I would say angle D is an included angle. And if that is the case, what could you use to find the opposite length? Decide the length opposite the included angle.
Cosine.
Right. I would use cosine rule to find length D. Yeah? So here what? I wanna apply it one time?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
no problem. So here what, right? Again, people on the YouTube, people on TikTok, all they see the included angle, right? Wait, before I do anything, I should probably show you what is not included angle. I need to see that. Because what's gonna happen when it do have an included angle now? They're not gonna be able to recognize it. Call this C. Give me some letters, guys. Give me some letters. Give me some letters.
B.
XYZ. XYZ.
B.
R.
I'm gonna use XYZ, right? I'll use XYZ. And
It's a
let,
good sequence.
let me just say the angle here is 38 degrees, right? I tell you that this length is 9 meters, and I tell you that this length is 5 centimeters. Would this be an included angle?
No, sir.
No.
No, but how do we know that though? How we know that? If you look at it very carefully, we have the 9 meters on for this adjacent side, but do we have the other length here?
No, sir.
No, sir.
No, we
So it's
don't.
not sandwiched between the two of them. It have the 9 there, but the 5 is all the way over between X and Y.
Exactly.
So it's not
Exactly.
sandwiched.
So this is not an included angle. So I cannot use cosine rule for this. All you understand?
Yes, sir.
I cannot use cosine rule. I cannot do that, sir. I cannot do that. You need an included angle, guys. Get with the
That's
motion.
illegal.
Alright, wait Tibon there, boy. I'll send you link to Tibon now. Romano, send you link to Tibon.
I guess
Tell Tibon we missing him. Right? Dan illegal. I need a sticker.
Tavon not being here, not legal, right?
I still have my blanket. Yeah, but I still have my blanket right here. If all I want, I can put on like camera and like be part of the blanket club.
Welcome to the blanket committee.
The
That's
blanket
not
committee.
funny, by the way.
Sir, try to get your cozy, you can fall asleep.
Listen. I really don't think all them men know who they're talking to, you know. I don't think all them men know who they're talking to. All they think I really gone sleep. All they think I really gone sleep.
Is Mr. Rajiv Dwarka, he not going to
Can't
sleep?
get comfortable yet.
Wait.
Try to put them in the place.
I don't think all you know who I am. I do 24 hours on match before, you know, and I didn't feel sleepy after that. I not gonna sleep now. All you mad, all you have things in a lot. I not gonna sleep now, and over the holidays I gonna do 48 hours on match. So I look forward to seeing all you.
Yes, so you don't like yourself there.
Going to be
Sir, as a matter of fact, that's illegal.
It is
That is
illegal.
very-
Yeah, well, let me continue, right? Let me continue. Let me continue with the legalities. So here what? We have this triangle over here. Remember how I showed you guys to label it? So if this is angle D, what do you suppose I'm going to call this length?
Baby D.
Come on, D.
Come on, D.
Right? If this is angle E, which length am I going to label baby E?
Come on, E, 6 centimeters.
6 centimeters.
right? And if this is angle F, what do you think I'm going to label this? I was saying, yeah, angle F.
Common F.
Common F, right?
F.
So how are we going to write the cosine rule for this? Well, the cosine rule is always, you're always going to start off with the length opposite the included angle. So what's the length opposite the included angle?
Common D.
Common D.
D
Right?
squared equals
Yeah.
F squared.
5 squared.
Oh, E squared plus F squared minus 2 EF cosine D.
Right. If you're having a hard time remembering the cosine rule, let me explain something. You see this over here? This is always the length that's opposite the what?
The known angle.
known angle.
I don't want to just say known angle because I could know an angle but not included. Right? Don't say that. It's the length opposite. Right. Length opposite.
Included.
Right. And you always end off with the what angle?
The included angle.
So you are starting, my friends, you are starting with the length opposite the included angle and you're ending off with the included angle. So please have that on lock. Please have that on lock, right? Please have that on lock. You two
So I
people
can
are
take a
good?
screenshot of this, please.
No problem. And well, you see the E and EF, right? The E and EF are just, okay, these are lengths that are adjacent to angle D. So the E and EF are just adjacent sides. If you don't know what adjacent means, adjacent just means right next to. And can you see that the 5 and the 6 right next to the angle?
Yes, sir.
Okay, good, good. So these are just at the adjacent sides. These are the sides up. What's in? These are the sides right next to the angle. They're right next to the angle. Look them again. These are just the adjacent sides. The sides right next to the included angle. All right. So please have this on lock. You'll get more practice when we start doing more questions. But this is where you have to know. We always start off with the length opposite the included angle. So common D. And you're gonna have the adjacent sides over here. So E and F. E and F are right next to the angle. They are right next to the angle. Right next to the angle.
So I have a question, right?
Wait a second, a second. Yeah, guys?
What we fighting for here?
Finding for common D. The length opposite the included angle.
And we're using cosine to find it.
Right. Give me a second, right? Yeah, we're gonna use cosine to find the length opposite the included angle. Right? I'm gonna add. Wait, adding some people to the group chat there, or they go just fix them up and send them a link, right? I trust them all. They send back the link. Send back the link, right? Tell them the link and tell them to join. Now my cousin and thing. Big up my cousin. The reason all I had to thank she because she come up, my sister and them do the group and thing. While I teaching them do the group and thing, so big them up. Right? Otherwise, I just had like 5 people in the Zoom and I teaching and I live streaming that. So I get through because of that. Yeah, so if you're using cosine rule and you have an included angle, you'll always be finding for the length opposite the included angle. Later, you'll see that there's an example where you have to find for an angle given 3 lengths. That's the other instance where you use the cosine rule. But for now, have this on lock, right? So let's move on. Now we have to substitute. Do I know what D is, guys? Do I know what D is? Oh, you know what D is?
No, sir.
No, sir.
No. All you can't tell me, let's see in D. I don't know what D is. I just see in D, right? Do I know what E is? Do I know what E is?
Yeah, 6 centimeters.
6 centimeters.
Yes, sir. 6 centimeters.
Do I know what F is?
5
Centimeters.
Right? And I know E is 6. I know F is 5. And the angle is what was the angle?
39 degrees.
39 degrees.
39 degrees, right? Nice. Here what we're gonna do, since most of you have a sharp, I just gonna show you the easiest way to do it, right? You gotta be real careful when you're plugging this into a sharp, eh? Real careful. If I was in Minister of Education, I just gonna get rid of all the sharp. I just gonna make that illegal in the country. That sharp thing, I can't handle it. I see Kristen raise her hand.
So
Yeah?
how to do it on the
Yeah,
shop?
hi, sir. Good night. I have a Casio, but I'm not sure how to change my calculator to degrees.
Alright, what you gotta do, right? You're gonna press shift. Wait, no. Give me a second. Give me a second, right? This virtual Casio just dies sometimes. You're gonna press shift mode, and you should see input output. No, what's in? Yeah, you press shift setup, and you go to 2 for angle unit, right? Shift menu setup, you press 2 for angle unit. 2 for angle unit. You want to go to degrees, so you press 1, and it's on degrees. I'll go it over one more time. You're gonna press shift menu setup. You're looking for angle unit. You press angle unit 2 for me, and I want to go on degrees, so I press 1. I'm in degrees now. Sunway is really good. People on YouTube,
Mine,
Sunway is good, Quast 2 is good, Studmark is good. Just not sharp. Yeah.
mine, I get through easier than that actually.
Oh, you have I have a Casio as well. Another one. You
I
just
just
press
press
shift
shift
mode,
mode and then
right?
yeah, I get the
You press 5.
1
You press 3 for degrees. You press 3 for degrees.
Mm-hmm. Yeah, I'm not seeing it. Thank you, sir.
No problem. All right. Well, there we go, right? So if I want to plug this into my calculator, I'm going to press 6 squared plus 5 squared minus 2 open bracket, 6 close bracket, open bracket, 5 close bracket, cosine open bracket, 39 close bracket. Plug that into your calculator and verify that you're getting 14.37. By the way, guys, the Zoom meeting, it filled up. It don't have more space. Right? So YouTube and TikTok is the best I could do. Right? Yeah. So we supposed to get 14.37124231.
Yes, sir. Sir, I
Yes,
have
sir.
a question. What they want us to like show the working like was 6 squared plus 5 squared, or we could
Nah,
just
you can just write the answer. Just write the answer.
okay.
14.37124231. Again, this is the easiest way I can tell you to do it. If you have a Casio, you can get the answer straight one time. All you gotta do is just find the square root of that whole thing and you get the answer immediately. You don't have to care about nothing. But
So,
take me.
I forgot to put t squared to verify.
See that, right? And so if I want to find for D now, I know that D squared is 14.37124231. So how would I find for D?
Find the square root.
Right, I have to find the square root on both sides. So I'm going to do that. And all right, cool. And so the square root on the D squared. What gonna happen there?
3.7.
3.79.
Right, and in these recent years, they want the answer to 3 significant figures. So that'll be 3.79. Yeah, 3.79. And that would be 3.79 centimeters, right? In brackets to 3SF. If you're having a hard time rounding off, here what happening, right? Here what happening? The third significant figure, well, the first one is 3, second one is 7, third one is 9. What's the number after 9?
0.
Right, 0 is less than 5, so we just round down. Right, so we just say 3.79. So people on YouTube, let me know if I get any 3.79. And here what, your answer is not going to be in degrees, guys. Are we finding for our angle or are we trying to find for our length?
We're finding for length.
Length.
Finding for our length. So your answer needs to be in centimeters. Right? Centimeters. Yeah, centimeters, right? People on YouTube, TikTok. I can't see the people on TikTok. Let me check the people on TikTok, right? People on TikTok, are they good? Right? People on TikTok, are they good? All right. Nice. So let me
I think
continue.
it's time for upgrade where you get like multiple monitors so you can see TikTok, YouTube, and all of that.
Yes, I have to get that. I have to get that. Now, let me just say something, right? I'm just say something. Do you guys know that addition is commutative?
Yes.
Yeah.
Yeah, so if you had f squared plus e squared, would that have made a difference?
No. No, sir.
No, if you had f squared plus e squared, that's fine. You'll get the answer correct. Because addition is commutative. It really doesn't matter. If I had f by e instead of e by f, would it make a difference?
No, sir.
No, sir.
No, it wouldn't make a difference, right? Because multiplication is commutative. right? Let me know if you understand that.
Yes, sir.
Yes,
Right.
sir.
It doesn't matter the order in which you add or the matter. It doesn't matter the order in which you add or the order in which you multiply, right? So if you had root f squared plus e squared minus 2fe cosine d, yeah, that's fine. Get the same answer. But understand why, because addition and multiplication are commutative operations. Good. So let me know if you guys okay with this.
Yes, sir.
Yes, sir.
Right? So we okay with this example. Let's do another one quickly.
Romano, you guys are rocking chair, man.
Yeah.
So people on YouTube, people on TikTok, take a screenshot and we'll handle another question, right? We handle up another question.
So what are we going to do? Past papers.
Here what, eh? You need to understand the foundation before we do any past papers, right? We're going to do past papers after we finish cosine and sine rule. Yeah. Yeah.
So,
Right?
after this, you could do the one where you find it for the angle with the cosine rule.
Yeah.
Yes,
Yeah. No
please,
problem.
sir.
I just want to make sure
Then
they
after that,
understand
we do
this.
measurements, right?
Yeah, after we finish with bearings, I want to do two bearings questions that utilize and everything, and then we're going to move on to measurements. Actually, we could do vectors one time because vectors is also kind of with directions.
Okay, no problem.
Right? So I'm gonna move on now. Let's do another question. You know what? Hear what, guys? Hear what? I'm going to make this. I go on combine bearings in this, right? Call this L M N LMN. Let me just say that. Put on the outline here. Let me measure the angle quickly. What angle are looking like, guys?
$62.
Okay, 50.
54.
54. Yeah.
Oh, yeah, that's 54,
54.
54, 54, my bad.
54.
Right, 54. Somebody in YouTube asking me was an included angle. An included angle is an angle in between two known lengths. So you see how you have 39 degrees here, and you have 5 centimeters, and you have 6 centimeters, and these are the lengths that are right next to the angle. They are sandwiching the angle. That's an included angle, and it signals that you could use cosine rule to find for the length opposite the included angle. So I hope you guys understand that. Right? This, however, is not an included angle because you know what one of the lengths are, but you don't know the other lengths. You cannot use cosine rule for this particular question. So I hope you guys understand that. So an included angle is an angle in between two known lengths. That's an included angle. All right, let's move on. So this is 54 degrees, yeah?
Yes, sir.
Okay, cool. Let me see how bad all it is, right? Let me see how bad all it is. All you think all it bad?
I'm very bad. I'm bad. I'm
I want to
bad.
believe
You
so, sir.
know I'm really bad.
You should.
Boy, man, it's really Michael Jackson. All right. So let's measure the angle here, right?
I think we have our main singer for tonight after the live. It's gonna be Romano first place.
I'm not
Felicia
staying
second
until
place.
after in life. I have TD in the morning.
Yeah, he had to be.
Shoot.
I
Yeah,
leave it
Oh,
around
shoot.
9 o'clock. So
Well,
You're
I
lucky.
will sing on your behalf. I'll sing on your
Yeah.
behalf.
You're lucky,
Thank you,
Romano.
thank you,
You're
thank
lucky. You're lucky. Next time,
Right.
man. Next time. We'll
So
get
what
that
angle?
one show.
So what angle is looking like, guys? This angle over here.
that look like 25.
25.
All lost for them. Nah, boy.
Sir, it's about 154.
155.
Oh my god.
155.
All right,
155.
154.
All right, 155. 155.
155.
155. I'll go see where I'm going with this, right? You guys will see where I'm going with this. I'll just be asking when I got new past papers. Like, let me explain something, right? Everything I do in here, it could come in a past paper. And I just real want to do past papers, but when you open that test paper on the 12th, Are you going to see the exact same question all you do before in any past paper?
No.
Nope, they're gonna put it in a
It
different
could,
way.
yeah,
And they will expect you
Exactly.
to
reword
expect you
it.
to know.
Exactly. So you ought to be able to understand anything, right? So, all right. Here what? My first question I have for you guys, number one. Find, it's like a past paper question, right? Find for LMN. First of all, what angle are you talking about there? If I ask you to find for LMN, what angle is that?
Angle M.
That's angle M. Where's angle M? This angle M?
Yeah. No. No.
No.
No.
Yes, sir.
No,
That's
no,
not
no.
at
Inside the
79 degrees,
triangle.
sir.
No.
Run it, sir. 79 degrees one
Angle
time.
M is
One
from the
time.
M.
north line.
That's
Uncle
this.
At the bottom.
79?
it's
Yeah.
inside
Yeah,
the
79,
triangle.
sir.
Earlier,
79 one time,
79?
sir.
earlier understand that this is angle M, right? This is angle M, yeah? LMN,
Yes.
Yes.
The
right?
north line down is just the direction of the angle.
Right? So LMN. If you see LMN, typically they're talking about the angle in the middle. That's angle M. I see Simon raise his hand. Simon?
Yes, sir. It's element. First, I can stretch that knot line and make an arterial angle. So I know that's 54 right there, and I know that that's a straight line there. So I can say 180 minus 155. That's 25, and 25 plus 54 is 79 degrees.
All right. Okay, cool, cool. I'm gonna guess a lot of you guys in probably lost already. So here what?
Yeah, you
Yeah.
kind of did.
Let me
Say you
show,
lost me yet. I'm trying.
let me show you guys how to use on like an easier way, right? Like an easier way. So here what I'm saying, right? LMN. So LMN. That's angle M, right? Yeah. Here what happening, right? Here what happening. We know that this is 155. Remind me, the summer angles about us about a point or a circle is
360.
360.
360 degrees. Is there any angles you could find for over here?
Yes.
Yeah.
Yeah.
Yes, we could potentially find for this angle here in green. What's the rule I would use for that?
Yeah, co-interior.
Co-interior angle.
180 angles.
Right, co-interior angles must add up to 180 degrees. And so that angle is going to be 180 minus what? Right, and what are we going to get for that?
126.
126.
So here's my question for you all. If this is 126 and this is 155, what would this be?
Yeah, add the two together and take away
Add them both
Add
and
them
360
as
from it.
179.
Exactly. I hear what I was saying, right? The angle about a point. What that's supposed to be? Some angle about a point.
360.
360.
360. So this whole thing gotta be 360, you know, guys. So this is 126, this is 155, and well, this would have to be the 126 plus 155 from 360. So
79 degrees.
79 degrees.
let me put the work in here. So 360 degrees minus 126 plus 155. Everybody could confirm is 79.
Yes, sir. Confirm.
Yes, sir.
Yes, sir.
Okay, good. Now here what, right? Here what I could do. What if I tell you that LM is let me take our measurement, right? Let me take our actual measurement. Because I want to blow all your minds at the end, right?
So you always don't remind so.
That's good. What length are looking like approximately?
3.9.
3.9.
They say just knock it on the phone and that's
Right. So earlier mic unmuted, right? So we could call that 3.9, let's just say 3.9 kilometers, right? And let me measure this length quickly. That looking like 2.1.
2.6.
2.6.
Yeah, we could call that 2.6 kilometers. So a question like this could come in the exam, right? Let me explain. So a question like this could literally come in the exam, and you would have, let me show you what you'd have to do, right? The first thing they'll ask you for is to find for the included angle. To figure that out, chances are you have to remember that co-interior angles add up to 180. That's this part over here. Then you have to remember summer angles about a point is 360. That's how we got the 79. So that's the first part done. So angle LMN is literally 79 degrees. And in part 2, they could be like, find the distance from L to N. So guys, when you look at this question, the second question, they want us to find the distance from L to N. Do you guys know that this is distance that is this distance over here? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yeah, talk to me.
My internet was tripping. How did you get 79 degrees again?
Okay. What is some angles about a circle? Yeah.
360.
360, right? 360.
Mm-hmm.
We know that this is 155. And we could find for this angle here, because some of co-interior angles is what? Co-interior angles must add up to what?
180.
Right. So if this is 54 degrees, what would this be? 126, right? 180 minus 54. So this is 126. This is 155. So to get it, so the full thing is 360, you know. And so to find for this missing piece, I would just say 360 and add minus 126 plus 155 to find the remaining angle. 79.
Okay, understand. Thank you.
No problem. All right. Cool. I'm on the window open. All right. All right. So cool. Let me continue quickly, right? So when you look at this triangle, are you guys seeing any included angles? Yes or no?
Yes, sir.
Yes, sir.
What is the included angle? Is it L, M, or N?
Is M.
And win.
Are you guys seeing that M is the included
Yes,
angle?
sir.
Yes, sir.
I know. Oh yes, somebody. Yeah, it's supposed to put 0 here. My bad. Right? Yeah, with bearings, you have to put the
Sir,
the
would it
extras.
also be 0? Yeah. Okay.
Yeah, 0.79 degrees, right? So when you're doing these types of questions, please put the 0 there if it's a 2-digit number. Okay. And this is 0.79. Do we have the lengths that are right next to the angle?
Yes, sir.
Yes, sir.
Yes.
Right. So here what? Let me label the triangle quickly now. If this is angle L here, what would I call this side?
Baby L.
Common L.
If this is angle M, well, this over here is angle M, right? What would I call this?
Common M.
Come on.
Right? And if this is angle N, what would I call this?
Common N. Common N.
Come on.
Okay, everybody with me, right?
Yes, sir.
Yes, sir.
Okay.
I don't even know. I just want to take a quick.
Right. So let me answer this question. So it's going to be M squared. Remember how the formula does go. It's the length opposite the included angle. So what is the length opposite the included angle here?
M.
M. So we're going to say M squared is equal to what?
L squared plus N squared.
L squared plus N squared.
Does it matter if you say L squared plus N squared or N squared plus L squared?
No, because the community is long.
Doesn't matter, right? And that'll be minus 2 what?
2 ln cos M.
Right. Good. And so to find for the answer, we need to substitute now. What is L? What is length L?
2.6 squared.
2.6 squared.
Right.
Plus
What is
3.9 squared.
Plus 3.9 squared.
Right?
Minus 2 times
Minus
2.6 times 3.9 cos 79.
Yes. So plug this into your calculator, guys, and let me know what you're getting. And I'll verify if it's correct. People on YouTube, let me see what you guys, let me see. Yeah. We are using cosine. Anytime you have an included angle, you use cosine. Right? 2.6 squared plus 3.9 squared minus 2 by 2.6. Let me know what length you guys are getting.
Sir, when we do the square roots of everything, or just like after
No, just summary length. Just summary length. Yeah,
I
summary
have
length.
18. So 3 significant figures is 18.1.
No. Here, what? When you do that calculation, like any, if it's part of a bigger calculation, use put down the full thing, and then in the end, your final answer round that off. You don't want to end up with rounding errors.
Okay,
So,
I have 18.10039,357.
Yeah, I also got that, sir.
right now, here what? I know you could store and recall, right? But I'm catering for the average student, and I feel like this is the easiest thing for the average student. Like literally, you just plug it into the calculator, write the value, and then square root. And so we are trying to find for m. We are trying to find for m. So we have m squared right now. So what would I have to do? Come on, guys.
Square root it.
Yeah. I have to square root both sides. Good notes. We talk about this, you know. We talk about this. Good notes playing up again.
Sir, it ain't no good notes no more. It's bad notes.
Yeah, real bad notes. And so we square root of
I
that.
have 4.25 kilometers
Same.
into three significant figures.
Yeah, again 4.25. And the units for that is what?
Kilometers.
Yeah.
Kilometers.
And I rounded that off to what?
Three significant figures.
Three significant figures, yeah.
Good. Everybody feel like they're okay with cosine rule?
Yes, sir. Yes.
Yes, sir.
Yes, sir.
Sir,
Right.
can I take a picture of that, please?
Sure. People on YouTube and TikTok, let me know if they're good. Right? When we do any past paper questions, I'll be doing more questions. So if you're confused, your confusion might be rectified at that point. But take our screenshots and we're gonna move on.
Excuse
So
me, sir.
yeah?
So you think you could do a question like this one more time?
Okay, I could do one more. Alright, one more. Alright, so people on TikTok and YouTube, right? We use the cosine rule anytime you have a what angle. What's the name of that? Anytime you have a what angle? A what angle? Anytime you have a what? Some guys, drop it. You use the cosine rule anytime you have a what angle?
Included angle.
Included angle, good. And in this question, what was the included angle?
Sir, sorry. Somebody in the Zoom comments asked how you get 155.
Oh, 155 was given to me in the problem. 155 was given to me in the problem, and that would be the bearing, that would be the bearing of n from m. So that was given to me in the problem, right? 155 was given to me. Yeah.
Sir, I have a question.
Yeah, talk to me.
So, if you use the cosine rule when you have an included angle, when would you use the sine rule?
You use the sine rule anytime you do have an included angle and you have a pair of information, as you'll see just now.
Okay, thank you.
All right, so let's move on to a question. I'll pass you by a question quickly. Look up on that question. I even had to look hard. Guys. All right. Olio, big up Titanic one time. Big up Titanic. You know. People that was on the Christmas lives. Olio get it. Olio get it.
Yeah.
Whoa. What is this? What is doing here?
Oh, Lord.
Boy.
What are they gonna do, guys?
Well, you're sick,
It is since
So
Christmas.
since John honestly had to get it in it.
Where you do that?
Since last year, then.
Hey, Romano, that was there since last year Christmas. Alright, okay. So let me do this question, right? This is a full scale exam question. Who wants to help me with the question?
Me, sir.
Alright, well, there we go. What's your name?
And
What's your name? I don't know the name.
Sir, her name is Anne.
Oh, Anne. That's a short name. Anne. Right. So, Anne, give the question a read for me, please.
Excuse me, read it?
Yeah, read it. Move on,
Okay,
please.
a ship sails from point A to point B, which is 15 kilometers from A on a bearing of 42 degrees.
Right, wait there.
Uh-huh.
Yeah, wait. Every time you read one sentence before you move on, try to understand what they mean. So they're saying a ship sails from what point to what point?
From point A to point B.
So where did it start from?
Point A.
Right. Are you with me, right? They're saying from point A. Are they saying that, yes or no?
Yes, sir.
Yes, sir.
If you're saying from point A, chances are the boat is going to go from A to
Point B.
Point B. Good. And so, where am I going to put on my point? I'm going to put on my point by A. Yeah? Are you with me?
Yes, sir.
Yes.
Right. Where do you guys think I'm gonna put B, boy? Are you think I'm gonna put B here or B here?
Honestly, I don't know, sir.
By the
That's it.
second.
Wait, wait. Don't tell she. Wait, don't. Ollie, helping somebody. Don't tell she, right? I want like helping this person. Nobody else talk, right? I'll ask questions after. So, Anne, you understand that we're going from point A to point B, right?
Yes, sir.
On a bearing or what?
42 degrees.
Right. Let me do a sketch, right? You hear what I'm saying? Let me do a sketch. So I'm gonna put on A, right? I'm gonna put on A, and I'm gonna put on my node line, like so. The bearing, when I'm measuring the bearing, it has to go in a what direction?
Clockwise.
Clockwise, or starting from A. And you tell me when to stop. You tell me what looks like 42.
Okay. Stop.
Okay, so you tell me now, where you think I'm gonna put our 42? Do you think I'm gonna put it over here or over here? One or two?
Oh Lord, I don't really know.
Wait, that's a bad question. That's a bad question. The bearing is from A to B. So where do you think I should put it? 1, 2, or 3? If you could understand this, you have it in the bag. So the 42 degrees would go over here, right? So where would it go on the diagram?
The second one?
Nah, it's going right here. Going right here.
Oh, okay.
Let me run it back again because I feel like you don't understand it fully. Alright? Let me run it back again. So you are going from where to where? We're going.
From point A to point B.
On a bearing of?
42 degrees.
Right, so this angle over here is?
42 degrees.
Yeah, and this point over here will be what?
Um,
We went from point A to what?
Point B.
Right.
Oh, that would be point B.
So I want you to look at this and compare it to our diagram we have in the exam. Right? And everything will fall into place, hopefully. Alright, I want you to compare this to the diagram we have. Where do you think I should put the B? 1, 2, 3, where?
Oh God. Sir, this question kind of confusing me.
Okay.
2.
Wait, don't tell her the answer. She needs to think about it and figure it out. So Anne, you understand this, right? You understand this?
Yeah, I understand it.
If you understand this, then you should be able to understand what's over here, right? So where is the starting point on the diagram?
Point A.
Point A. And then we went to where? Where did we go to?
We went to point B.
Right. On a bearing of?
42 degrees.
Right. So where do you think is the 42 degrees? So we started from A here. Where do you think the 42 degrees would be?
Well, it would just be going downwards, like clockwise. I don't know how it would look on the triangle.
Watch. You see what I was telling you now? If you understand that, then you understand the problem. Watch. You understand this, right?
Yeah.
You're sure you understand that?
Certain.
Certain? Okay. Watch. So you tell me you're seeing where A and B is, right? And you're seeing the bearing.
Oh. Okay.
So what we're gonna put here?
You're gonna put 42.
Right, 0, 4, 2 degrees. And if I take this bearing, where am I gonna end up at?
B?
Yes, I'm gonna end up at B. You understand it?
Yeah.
They're on the back again, right? The first line said the ship sails from point A to where?
Point B.
Right. On a bearing of what?
42 degrees.
Right. Tell me, what looks like 42 degrees? This angle over here or this angle over here? 1 or 2?
1.
Exactly. So this would have to be 42 degrees, and that would take it to where?
Point B.
Point B. Yes. Earlier, please be respectful. Everybody learns at different rates, and I'm not here to criticize nobody. Everybody learns at different rates. Right? And the point of math vibes is to help absolutely anybody. regardless of where you are in maths. All right, try to be respectful, please. All right. So you
Thank you,
understand
sir.
that part, right? You understand that part?
Yep. Yep.
You see how important it is to read one line and make sure you underline one line, because if you had to read all the other lines, you're gonna be a bunch of information in your brain and you're gonna just freeze. Right?
Yep.
Let's read the next line. What the next line saying?
The ships then sails to point C, which is 19 kilometers from B, on a bearing of 130 degrees.
Right. So we're gonna leave B and we're gonna go to where?
C, point C.
Where do you think point C is on our diagram?
The third one?
The third one. Everybody okay with that? We say now this is C.
Yes, sir.
Yeah, sure.
Right. And the bearing from B to C. From where? From where? From
B
to
C.
So it's from B. So I'm gonna take my pencil and I'm gonna put it where? By B or C?
Um,
Anytime you see the word from
from B?
from B, you're gonna take my pencil and I'm gonna put it by B and par dot, right? I'm put on my note line.
Yeah.
So from B, if I want to go to C, where's the bearing I have to take?
130.
130.
Clockwise.
Right. Seeing it?
Yeah.
Because that bearing would take us from B to C.
Mm-hmm.
Yeah. You're sure you're seeing that, right?
Yeah, I am.
So this bearing over here is what?
130.
130 degrees. Are you seeing that here? People on TikTok, people on YouTube, Zoom people. Are you understand this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right, now let me show you something real about it. Because I don't think I'll appreciate bearings. Like I said, bearings is just directions. So Sarah, imagine you had a compass here, right? This is the compass. So like, a compass, it points into here, right? You have a compass, right? And the compass pointing in this direction. You with me?
Yes, sir.
Right. Let me show you how bad maths is. Maths real bad, innit? It just look boring. So earlier, we have our compass here, right? Have our compass here. This is the compass. Yeah?
Yes, sir.
And this is the reference, this is the note line, right? On our compass. Let me just like put this dashed like that. Right, watch this, right? So you understand, this is the compass pointing in this direction. Are you with me?
Yes, sir.
Right. So imagine you have your compass in your hand, right? And you start here. If you follow the compass, we eventually we're gonna reach.
Point C.
Point C.
Right. Right. Just directions. That's all it is. It's just directions. Right? Cool. And the following diagram shows a sketch of the ship's journey. Did we already put all the information? Some guys, did we put all the information already?
No, we didn't
No,
put
sir, we
it
didn't put the kilometers.
Good. So from A to B is what distance?
15.
15.
kilometers.
You see how I tell them no? I like that. I like when I tell them no. Because it means that all you actually understanding rather than just saying yes mindlessly. And B to C is what? What would B to C be?
19.
19 kilometers.
Olia. What are shaping up to be, boy? What are shaping up to be?
I try. Wait, what do you mean, sir? Like what
Okay.
we using or like the shape?
Yeah. Yeah,
Like
what is it?
using?
So
What
you can use cos.
I think Olia could see it already. This is the exact same thing we just do, you know. The exact same is the exact same thing. So like, let me ask you that question, right? And we could potentially find for this angle.
Yeah.
Yes, sir.
And if we could find for this
Yes,
angle,
sir.
which side we could find for? Which side we could find for?
We could find for side B.
Ah boy, there we go. Now we talking about. Right. Bearings is vibes, boy. Big up bearings. So in part one, we already answered part one. They said on the diagram, insert the bearings 42 degrees and 130 degrees. Are you okay with that, right?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
And Alia, look. Calculate the distance between town A and town C. Alia, we call that, you know. We call that. We know that was gonna happen. It's very predictable. And so to answer part two, you would first need to find your what angle.
Yeah, included angle
Included angle.
8K and 19K.
Correct. So we need to find the included angle. So we need to figure this out. Any suggestions? Anne?
Sir.
Hello, not Anne. Eh?
Yes, sir.
Anne. Wait, Anne.
Yes.
Any suggestions?
What do you have to take out one? No, hold on.
Still have a question.
Sir,
Wait,
what do you have to take it up from 180?
Wait, here what I was saying, right? What would all the angles there have to add up to?
360.
Half to add up to 360.
Mm-hmm.
You already know that this is 130, and
Yeah. You would
could
have
you
to.
find for the angle?
Yeah.
Yeah.
Because
You would have
co-interior angles add up to what?
180
degrees.
Right. So to find for this purple angle over here, how are we doing now?
180 subtract
180
42.
minus 42.
And what we get?
138. 138.
Bam. So and if you know that this is 138 and you know this is 130, how are you gonna find for this?
You would add those two. You would add those two and subtract it from 360.
Good. So it'll be 360 degrees. You know how to put it when you're working. 360 minus 138 plus 130. And that would give you how much degrees?
92.
Confirm that, guys. Are they getting 92 degrees?
Yes, sir. She right.
Nice. Alia, and you know how to handle the scene now?
Of course.
Yes, sir.
Right. Watch. Wait. And so they can see have I included angle? Or they see the included angle, right?
Yes, sir.
Yes. Remember, an included angle is an angle in between two known lengths. It's sandwiched in between two known lengths. The angle we have here is 92 degrees. Can you see that it's sandwiched between the 19 and the 15?
Yes, sir.
Yeah. Somebody asked me if you'd have to use your protractor to measure it. No. Let me show you something, right? Do you think they're going to make it that simple? Where you can just measure it from the diagram?
No.
Of course
No.
not.
No. Most of these exactly. Somebody said the exact thing I was gonna say. It is not drawn to scale. Watch. If you go to measure this angle, will that read 42?
No, it's reading
It's
35.
35.
Exactly. So no. If they give you a question like this, where you have to draw the diagram from scratch, use your protractor. If they're giving you a diagram like this, where you have to label, you're not going to use your protractor. You have to actually put it in the diagram, right? Are you understand?
Yes, sir.
Because this diagram is not drawn to scale. It's just like a sketch they do, not drawn to scale.
And just to make sure that that's actually put not drawn to scale in bold letters, bold print. So that we so you can know it's not drawn to scale.
Well, that will put it not drawn to scale. Alright, so just keep that in mind, right? It's not drawn to scale. So you're not gonna use your protractor to measure anything. Not gonna do that. No. CXC not gonna be that kind. You need to label it yourself. Right? So let's answer part 2. So I'm just going to make a simplified version of the triangle, yeah? A simplified version. Right? Somebody tell me what I call this point.
A.
What I call this point here?
B.
What I call this point here?
C.
Alright, what I call this length here?
15 kilometers.
Right? What do I call this length here?
19 kilometers.
And this?
92
92
degrees.
degrees.
I'll hard to see the thing, boy. I'll hard to see the thing. The include angle right there, you know, right there, 92.
Yeah.
So,
Sir, I don't have when you're ready.
Say that again?
I already have the answer when you're ready.
And that's you, right?
18.
Okay, big up on yourself. Drop the answers. Take people on TikTok and YouTube, drop the answers, man. I'm gonna know what's going on, right? So, Anne, if this is angle B, what would this be over here?
Common B.
right? If this is angle A over here, what would this be?
Common A.
If this is angle C, what is going to be?
Common C.
Right, come on, C. Alright, cool. Now remember how cosine rulers look. It is the side opposite the included angle first. What is the side opposite the included angle?
B. Common B.
Right, so you're going to start off with b squared. And b squared is going to be equal to...
Common
C squared.
Wait,
C
let
squared.
Ann do it. Let Ann do it, right? Let Ann do it.
C squared.
Plus...
A squared.
Question, guys. If you had a squared plus c squared, would it be wrong?
No, it's cumulative
No,
loss,
sir.
so it wouldn't matter.
Exactly. It wouldn't matter. It would not matter in the slightest. A lot of students, they just learn one thing off and they think that is it. But in maths is very versatile. But you need to know when to push the boundaries. Right?
My maths just say is a cycle. Like if you learn one thing, it will help you in the next.
Exactly. Hear what? If you sit down tomorrow and you do a past paper and you spend like 9 hours on one past paper and you psychoanalyze every single question to like the T, that one paper will help you with the whole, like, help you with everything. That's my advice. Do one paper in extreme detail. Make sure you understand every single thing. Or alternative ways to work the question. Why it does work, how it does work, and that would help you. Stop looking at maths black and white. Maths real cool, but you had to probe, you had to explore. Right? So b squared is equal to c squared plus a squared what? Minus what?
Minus 2.
Minus 2 what?
C and A.
Right? Cosine what?
The included angle.
Right, b. No, that's one way you could have write it, or you could have write it like b squared is equal to what?
A squared plus C squared.
Right, so these two mean the exact same thing and all. It means the exact same thing. Literally the same thing. Alright, so let me start plugging in, right? Quickly.
Yes, sir.
So C is 15 squared. A is 19, I'll be 19 squared. C is 15. A is what?
19.
And the angle is? What's the angle, guys? What's the included angle?
92 degrees.
92 degrees.
Right, so here what? Plug that into your calc. I forget any b squared. Why doing that? Right? Don't do that. Don't do that. Don't do that. Right? Plug that into your calculator and let me know what you're getting. 15 squared plus
Sir,
19 squared.
You want me to say it on or wait till you finish?
Wait till I finish.
Okay.
I have a question.
Yeah?
How do you get degrees on Quest 2 calculator?
Alright, you're gonna press shift mode setup, right?
Okay.
Then you should see MTH 10 degrees, grad, psi. You can't press 3 for degrees. It's in degrees.
Okay.
Alright? You get through?
Yeah.
Alright. So you should get 605.8927131. Let me know if you're getting that.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right. So to find for B, you're gonna find what on both sides?
The square root.
Right. Odd maths people, did you guys know that square root just means the power half? Odd maths people.
Yes, sir.
Yes.
Yeah. So like when I work in these questions, all I would do from here, I would just press the power button and I would raise it to the power a half, which is 0.5, and I get my answer. Right? So if I run off the 3 significant figures, my first significant figure is 2, my second one is 4, my third one is 6. What's the number after 6? Those is 7, eh? Those is 7.
1.
Those is 1.
One.
1 is 5. 1 is 1 5 or more?
No, it's below,
No.
so it would just be 24.6.
Right, just be 24.6. 24.6, and where's the units we're going to use here?
Kilometers.
Can use kilometers.
Kilometers.
And I rounded this off to what?
3 significant
Three
figures.
significant figures.
And the reason why I'm doing this, guys, let me explain why I'm doing this, right? in the recent exams, there's an instruction. It says numerical answers that are non-exact should be given to three significant figures or one decimal place for angles in degrees, right? So if it's a numerical answer, three significant figures, unless stated otherwise, of course.
Sir, we also have to state that we put it to three significant figures, or we just leave it at that?
I advise you to write there round it off to that, but you don't have to. But I advise you to. You don't have
Okay.
to because, yeah.
Okay, well then I doing it, no problem.
Yeah, just do the proper thing and done, man. Do the proper thing and done. So if it's a numerical answer, right, round it off for three significant figures and write in brackets to 3SF. If it is an angle in degrees, round it off to one decimal place. Are you with me?
Yes, sir.
Yes, sir.
Okay, cool. Good. That's my answer. Yeah, that was hard or that was easy.
Easy.
Real
Right.
easy. Food.
Right.
That's food.
That was really easy, guys.
Yeah.
Romano, we had 238 just now on YouTube. That's crazy, boy.
Damn.
Romano, remember what I say? You can't be the underdog forever. You can't be the underdog forever, boy. Can't do that. Can't do that. Math vibes to the world, dog. Right? So everybody feel like they're good with cosine rule now?
Yes, sir.
Yes, I know it like the back of my hand now.
That's true.
Right, so that's cosine rule. Let me show you another example of where you could use the cosine rule. Or I was supposed to show you something, you know. I was supposed to show you something. Are you ready to be mind
The
blown?
one with sign rules or no?
I'm doing everything. I'm doing everything tonight, right? I'm going to look at an example that's less common. We're going to look at how to find the angle given three sides where you have to utilize the cosine rule. I'll do two examples on that. That's rare. I doubt it's gonna come. But we'll just look at two examples in case. After that, we're gonna look at sine rule. After that, you should be able to answer any variance question. Okay? And then I'm gonna give all you a 10 minutes break. We're gonna come back. We're gonna look at vectors.
Sir, I think I might not be able to come back after the 10 minutes break because I have to study for POB. So
Not a problem. Not a problem. Well, this session is being recorded. It will be on YouTube immediately after we're done. Right?
okay, no problem, sir. Yeah.
Yeah. Okay. So let me show you something cool now. Are you ready? Are you ready? Are you ready?
So yeah, now so we're going on a break.
No, not now. Not now.
We now start.
So I say forget the break soon. I say forget the break. Just
We,
push them. We can't
we
push
now
no more.
start. We in the flow state. We just gotta keep going, guys. Like we
Yeah,
just
yeah,
gotta
yeah.
vibes.
One the break soon.
Alright.
Just go to the
So
cargo now.
let me show you something really cool, right? This question over here I did with you guys. Isn't this a scale diagram? Like it's the scale, right? It's the scale. We
Yes.
literally measured everything. We literally measured everything, did we not?
Yes, sir.
Yes, sir.
And we get the answer to be what?
4.25 kilometers.
4.25 kilometers.
What angle is that, guys? I mean, what length is that, guys? What length is that? Measure that for me.
4.25.
4.25.
Math is badness. Math is badness. Math real bad. Yeah. So if you have enough parameters and you could model things, you could predict the behavior of things without actually measuring a single thing. So like you could simulate a whole machine on paper and figure out what the result could be without even going and making anything. Math's just real cool. Right? Maths have real uses. So let me show you an example now. Where you have to find for an angle. So using cosine rule, right. Let me explain something, right? Anytime you find an angle, you'll have to use the what trig functions. The regular ones or the inverse trig functions?
Inverse.
Yeah. I just put that out there, right? You'll have to use the inverse trig function, specifically in cosine inverse, right? Cos inverse. Right, you have to use the inverse trig function here. So let me give you a quick example now. So let me just say that this length over here is 4. Let me just say that I'll give my length. Nothing too big though. I'll give my length.
6.
6.
5.
How we go? It's
7.
7.
7.
Next one.
Kick
Six,
them.
7.
Kick all of them, sir. Kick all of them.
Six, 5.
bruh. This is a perfect time for the bro person to be like,
Yeah,
bruh.
yeah.
So didn't
But
somebody just say
like
brother?
they're not here.
A man in the life.
I tell you, the man, when we need the man, he not there. When we don't need him, he here.
When we don't need him, he come out
Yeah.
and no
That's why I
be.
say he like to be
Have
noticed.
he have no the dumpling. None whatsoever.
This are dumpling.
Real.
All right, so guys, here, let me just put down the lengths right quickly. The first one was 4. Let me just call that 4 centimeters. The other one was what? It was 6, right? 6 centimeters.
3.5.
And the last one was 3.5, yeah? 3.5. Yeah, 3.5. Let me show you how cool maths is, eh? Let me show you. Are you ready for this? Are you ready for this? So let's see how the last question it magically worked, and we get the 4.25. Like when you measure it, you see in 4.25, right? And that was the answer. You're gonna see that same thing happen over here. But one maths badness, maths real bad. Let me call this LMN. Call it LMN, right? Oh, and you know that meme? LMNOP. You know what I'm talking about? Like when you reach that part, when you reach that part of the alphabet, when you reach that part of the when you reach that part of the alphabet, you just have to say LMNOP.
LMNOP.
Yeah.
Yes, LMNOP,
Yeah.
QRS, TUV, X, Y, and Z.
Y, and Z.
A, B, C, D, E, F, G,
EFG,
H, I, J, K,
HIJ,
L, M, N, O, P.
LMNOP.
QRS,
T,
I wonder.
W,
W, X, Y, and
How we
Now
reach
I
from
know my
maths?
ABCs. Next time, won't you sing with me?
How we reach from maths to nursery rhymes? Like what?
Hey,
And
yeah.
it's a
Wait,
refreshing memory for
It's
us English B
refreshing
students on
memory for
Tuesday,
maths.
right.
and for English B students on Tuesday, because we got English B and maths on the same day. So
Oh, big up all them, big up all them. Good luck.
thank
People are writing English B. Big up all yourself, right? Big up all yourself. Big up all
Thank
yourself.
you. And I'm feeling so big right now because it's
So
like a whole list of poems.
when
and
we
stories
on the
from
last
Kudo.
nitty-gritty for the last part of the exam, I have 2 exams on one day. The
Yeah.
1st of June, I have geography in the morning and I have bio
biology in the
in the
evening.
afternoon.
Is
So I
it
cannot go
only
home. I have to stay in
it's
school
only
one
my
day.
schedule?
Oh, whoa. Things getting chaotic, right? Things getting a little chaotic, right?
And
Let me
sir,
get
I
back.
think
Let me get back on track. Tell me you want to say fast, but let me get back on track.
no, I was gonna say that they also did 3 exams on one day for me on my schedule. I have 3 exams on one day.
That's crazy. Right? But let me continue, right? So, here what? I'm going to measure an angle here, and I'm going to hide it away, right? I'm gonna hide it away. So I want somebody to measure this angle from a measure angle L. What angle L looking like?
35.
Right, 35, right? So angle L, well, specifically MLN. MLN is what?
35 degrees.
35
35.
degrees.
Right. So here what? We're gonna talk away this answer, right? We're gonna talk it away, but don't forget about it. Let me use maths. Let me use some maths now. So if we are using the maths, we need to label our sides first. So if this is angle L, and let we just say any question they want me to find for angle L, right? Let me just say that's what they want me to do in the question. So the question says you are required to find RTF, required to find for MLN. That's what you had to do. So let's label our triangle accordingly. If this is angle L, what would this be?
Baby L.
Right?
L.
This would be common M.
Baby M.
This would be common N. Right. So remind me, guys, in this question, what is the side opposite the included angle?
L. L.
Yeah, L. Oh, let's see now, right? L. So I'll say L squared is equal to what?
L squared is equal to m squared plus n squared minus 2n m, 2mn cos L.
Good. Everybody with me?
Yes, sir.
Yeah.
Not really, no.
Right. So cool. People are new to Math Vibes. My name is Rajiv Dwarka, and I look at things very, very in depth. So it takes a while because I am focused on actual understanding and whatnot. So I'm not gonna rush anything. Everybody learns at different rates. So if you were like a more fast pace, yeah, this is not the place for you. This is not the place for you. Right? Alright, so L. I can write L squared. Where's M? Well, actually know what L is, eh? Where's L? Where's L?
3.5 squared.
Alright, 3.5 squared. What's M?
6 squared.
What is N?
4 squared.
So M again is 6, N is 4. Do we know what the angle is?
No, sir.
No. So in this in that entire equation, the only unknown is what?
The angle L.
Angle L.
Right. If you have one equation and there's one unknown, you could solve for that, right? So let's simplify quickly. What is 3.5 squared?
12.25.
I'm trying to finish like 1 a.m. Right? What is 6 squared?
36.
What is 4 squared?
16, yeah.
Right? And then we have minus 2 by 6 by 4. What's 2 by 6 by 4? 48.
48.
Right, so let me simplify one more line. Here's a mistake students would make, right? I'm calling out people here. How much of you guys would say 16 minus 48 something? Is that a legal move to make, guys? People on TikTok and YouTube and Zoom.
It's
Is that a legal move?
So illegal.
Because 48 is multiplied by cos L.
Exactly. You see it perfectly. This 48 is in a relationship with cosine L. We go break them up just now, right? But not yet, right? Not yet. Please refrain from drawing on the screen, otherwise I'll have to remove you. So you can't say 16 minus 48. If that was a mistake you'd make before, don't make it now. The 48 is in a relationship with cosine L. You can't do anything with it because it tells you how much cosine L you have in the term. Right? This 48 is the coefficient. It's tied with the cosine L. So you can't do that. Can't do anything there,
So
right?
it's basically like you're saying 48x or something like that.
Perfect. I love all the responses, boy. Exactly. Cosine L is an unknown, so it's a variable, right? So we have 48 being the coefficient and cosine L being the variable. Nice. So the only part we could simplify is 36 plus 16. What is 36 plus 16?
52.
52.
So here what, right? If you're trying to find for the angle, you need to have all the cosine terms on one side. You want all the cosine terms on one side. So you need all the cosine terms. You need cosine terms on one side. And eventually you should end up with only cosine L is equal to something. And then from there, to find for L, what would you do? If I know cosine L is equal to something, what do I do next?
Divide.
No, not divide.
Multiply.
No, I would find the cosine inverse of whatever I have on this side. Right, so this is what we want to do. So we need to isolate the cosine terms. What cosine term we have here? What's the cosine term here?
Minus 52 minus 48 cos.
Right. So we want to isolate that. Leave here over there. Isolate that.
So
You
we
see that
bring
52
over.
Right. You bring it across or you say you take away 52 on both sides. Anything is fine. So that's going to be 12.25 minus 52. And that's going to be equal to minus 48 cosine L. What is 12.25 minus 52?
Minus 39.75.
Am I verify that?
Yes, sir.
Yeah, again, minus 39.75. And that'll be equal to minus 48 cosine L. So remember what I told you. At some point, we need to get cosine L alone. we need to make cosine L the subject of the formula. But right now, cosine L is being multiplied by what?
Negative 48.
Negative 48. So if I'm trying to isolate cosine L, I need to cancel this off. So what's the opposite of multiplying by minus 48?
Divided by
Division.
minus 48.
And if I do it on this side, how do it on the?
Next side.
Other side.
Because it's an equation. It's an equation, right?
Yeah.
So in other words, cosine L is going to be equal to this over here. So we need to calculate that. So what is minus 39.75 over minus 48?
0.828125.
Are you okay with that?
Yes, sir.
Right. So here what, right? Remember what I told you. You're going to put this at some point, and to find for L, you need to apply the inverse function for cosine, which is cosine inverse. So L is going to be cosine inverse or what?
0.82.
Yes. Yes. And so we're going to find cosine inverse of that. Let's do that quickly. Cos inverse, answer. Wait. What I get my answer, right?
Sir, is
Yeah, that-
34.090. Well, 34.1 to three significant figures.
No. Not the three significant figures. Let's look at the instruction CXC saying. It says 1 decimal place for angles in degrees, right? 1 decimal place for angles in degrees. Isn't this angle in degrees?
Yeah.
Right. So we have 34.09. What is the first decimal place?
36.
The zero?
I'll write it over here so everybody's with me. So you're gonna get 34.09339081 degrees, right? If we're looking at decimal places, this is the first decimal place, this is the second decimal place, and so on and so forth. All you understand?
Yes, sir.
The first decimal place is 0. What's the number after 0?
9.
9. 9 is 5 or more, so I'm gonna add 1 to the 0, and it's gonna become what?
34.1.
4.1 degrees.
And I rounded that off to 1 decimal place, 1 dp. Are you with me?
Yes.
Yes.
Yes,
Sir.
sir. Yes, sir.
No.
Sir.
All you remember at the start of the problem, we measure something and we forget it for now.
Yeah.
Yes.
Yeah. So you're not gonna get an exact answer, right? Because like small mistakes in measurements and whatnot. But can you see that if it was perfect, if you had put the perfect numbers, you'd get 35?
Yes, sir.
Either that or we didn't measure it properly. Let me measure it one more time. Let me measure it one more time, guys. Measure it one more time. No, that's 34.
Like 34, yeah.
34.
That's 34. Let's see how cool maths is. Let's see that.
Yes.
Yeah, so you could figure out information without even drawing any diagram. Yeah. So let me run it back again. Watch it. This was a scale diagram. And where is angle L if you measure it? If you measure angle L, where are we gonna get?
34.
34. And what we get for the answer?
34.1.
If we run it off to the nearest degree, what that will be?
34.
34.
Right. Right. I'll find this a little bit cool. A little bit cool.
It's nice to see that my answer is exactly the same as what that it's supposed to be.
Exactly, right? Like, hey, imagine you just grab a piece of paper and start doing craziness, and somehow you get the answer. That is what maths is. Maths is like about.
Hear what you say. Sorry, my allergies.
It's legal.
They're making it sound like a cult.
Well, maths is a cult, bro. Maths is the best cult. Maths is the best. Yes. All right. So let's see how bad this is, right? Like literally, if you measure it, what you getting? If you measure it with the protractor, literally, what you getting?
34 degrees.
And what we get for the answer?
34.1.
34.1.
34.1.
That's essentially the same thing, guys. and they come and get to the 4.1. Badness. Right? Are you understand the process?
Yes, sir. Sir, I think we
Take
can
a,
try one on our own now. I think we
yeah,
should
yeah.
try one on our
Take a picture. Take a picture of this, and I'm going to give you all a question to do, right? And I'm going to
Sir,
measure it. Yeah, somebody
sir,
say something.
what's the possibility of them bringing a question like this on the paper?
Hey, don't study that. Just learn how to do it. Just learn how to do it. But I would say a little like a low probability. But hear what? You shouldn't be thinking like that. You should be ready for anything they give you. Just learn your work, and you'll be fine. So you're probably asking that question to focus on it less. But just know how to do the thing. I wouldn't say it hard. I think all you could do it. Right? Learn to do the thing in case it comes.
Excuse sir, until I was getting a break.
Yes, but the break is after we finish with this. After we finish with bearings.
So I'll leave it now.
All right, Romano. Big up, big up.
Sir.
Bye,
All right.
Romano.
Tomorrow.
Sir, me too, sir.
All right, Nikolai. Look, my son's leaving, my boy.
You have to leave too.
You have to
too.
phone. You have to
Worry,
phone.
you have,
I have to leave tomorrow, sir.
Yeah, guys. I'll take care.
don't worry, you have your adopted children.
I wouldn't even say I love the children, just outside children, boy. Just outside children.
Wait.
I would take that. Take
I
that.
have to as well.
They say inside children leaving.
Hey, boy.
So I have a question.
Romano.
I have a question.
What's your question?
So, what song we singing after this class? Because I did knock out last night. I didn't even realize when I knocked out last night, you know. I just wake up in the morning and see everything shut off.
What song all I want to sing tonight, guys?
That's Michael Jackson.
Sing bad.
What song?
Sing bad by Michael Jackson. On behalf of me not being there, sing bad by Michael Jackson.
Right, we were saying bad by Michael Jackson.
Yeah.
Oh, you gonna undo
I don't know how
boy.
that go. How that
So you
go?
want to sing about Marley?
Yeah, you could do that. No.
Right. Hey, you gonna say, don't worry about a thing, because
Right,
every little
everybody's
thing
supposed to know
is
that.
gonna be alright.
If you know that song, it's probably from the Caribbean. Come on.
Don't worry about a thing, because every little thing is gonna be alright.
Oh, you have people laughing and the allergies acting up here.
No,
Right.
but sir, in
Later.
honor of Romano and Nikolai, we go sing bad. Don't worry, we got them.
Thank you.
Right, we got them.
You're
we got them.
welcome, you're welcome.
All right, later.
Right, so all you have a screenshot of this, right? All you have a screenshot?
Yes, sir. Long time,
Yes,
long time.
sir.
Let me do a question now, and after this question, we're gonna look at sign rule. So give me a length.
4.
5.
Now we use 4 and 5 already. Let me use
6 or 7.
7.
7.
Olha, I will kick all out of the zoom in. Kick all out of the zoom in. Olha, on the 6, 7 thing. 6,
Okay,
7.
so 8.
Serious.
Wow.
So
Wow.
what about 8?
How is we moving? Yes. Alright, you know what? For the meme culture, I go put 6.7.
All right.
Right. Minus. That looking like 4.1.
4.4, sir.
4.4. 4.
Yeah, let me just call that 4.4 done.
Yeah.
Alright, that 4.4 bet. 4.4 meters. Now let me just call this. Give me some letters.
QRS.
QRS.
Hey, Radisha.
Hey.
Wait, for those of you guys that don't know that just now come, what we are looking at cosine rule. By the way, we're looking at cosine rule, right? And this specific application of cosine rule is when you have 3 lengths. And they're asking you to find for an angle, okay? And you're required to find an angle. So QRS, which angle do I want to find for?
S.
S? Okay, no problem. Now you don't know what we're gonna do. Let me take a little measurement and put it aside, right? Take a little measurement. Let's see what's gonna happen. Because when we calculated, as you guys saw, our answer is supposed to be real close to what we were measuring.
Yes.
Okay. Somebody measure the angle from there.
So that's 23. Yeah, that's 23.
It was approximately 23, right? To the nearest degree, that's 23. Watch. If
Yeah.
you're not seeing it, watch. 0. You sure that's 23? You
Yes,
sure?
sir. Look,
Nah,
sir, like you
nah.
see, like 20.
So that is 20.
Oh,
28.
28. My bad.
28.
Right. So we're gonna put the answer to the side, right? So that answer, that will be for angle QRS. I mean, what's the name, boy? QSR. Wow. Ollie, forgive me. That's RSQ. RSQ is equal to what we measured just now? What we measured just now?
28.
28 degrees.
Right. And I'll probably wondering, sir, why is it RSQ? Watch. RSQ. What angle forming?
In
What's
the
the angle?
middle.
Exactly.
Included between the lengths, yeah.
Exactly. So I'm going to, you know what we're going to do? We're going to cover this, right? We're going to cover this, and you guys are going to give this an attempt. I'm giving you all 4 minutes. Try something. Good luck. May the
So we
force be
don't
with
give
you.
like 2 minutes as a challenge.
Nah, 4 minutes.
So when you say that part there, you're making me sound like we're the purge, you know.
We in the purge, literally. Maths exam is just now, you know. In 12th.
So whichever
Well,
date doesn't matter, no, we still had a lucky no matter.
you gotta lock in. You have to lock in. You can't just. You gotta lock in. Right? So go. I know I can get the answer, boy. Oh, I should probably put the angle you're trying to find for. You are required to find angle RSQ. If you could get this question correct, you're bad. By the way, guys, let's see the merchant thing. Math vibes, boy. Yeah, but I'm gonna start selling merchant thing soon, man. Right, so after this, we are going to look at sine rule. People on YouTube, I'll get an answer.
So, I get the answer.
Okay, good. And you're positively correct?
Yes.
Because the answer close to this, right?
Wait, what the answer is? I don't know what's it. Oh yeah, I know see it.
Yes, sir. Answer then correct. Answer is correct.
Guys, if you don't get 28 degrees or about that, you're wrong. Yeah, something wrong there. I see morality gonna react to your message. That is okay. If you hear what you nothing to be ashamed about, you know. The point is you're trying to learn, and that's the most important thing. Right? I see people saying 28 degrees, 28.1 on thing. Nice, nice. I seen some correct answers. That's good. That's good. Yeah, yeah. All right. Time is up. Everybody question. So I need a volunteer. Any volunteers?
Sarah could do it.
Bet. So what's your name? What's your name? Somebody said they would do it.
Oh, I say me, sir.
And that's you?
No,
Real
sir.
people, you know.
No,
I had to
it's
tell more than
Sarah.
No, it's Sarah,
Sarah?
sir.
Sarah.
Yeah.
Okay, you know, I tell you, real people here, you know, I just one person. I don't know how. Yeah, but Sarah, I remember your name, right? Yeah. So if
So
this
I
is
think you should
angle,
remember me for real though, because like me, Ranisha, Romano, and Nicolai, like come on, we are children at this point. Like
I remember, right? So if this is angle Q, what would this be?
common Q.
Right. And I feeling for barbecue. Yeah. Right? If this
Yeah.
is angle S, what would this be?
Angle small common S. Common
Right? If
S.
this is angle R, what would this be?
Common R.
Right. So tell me, which side is opposite the included angle?
S.
Yes.
S. S. Yes. S. Yes. That's unintentional. And so we'll say S squared is equal to what?
S squared is equal to R squared plus plus Q squared minus 2RQ cos S.
Nice. Let me plug in everything now. And so S is 3.5, so I'll say 3.5 squared. R is 6.7 squared. Q is 4.4 squared. R is 6.7. Q is 4.4. And the angle, do we know the angle?
No, we just put S.
Because you're trying to find fit. So 3.5 squared is what?
3.5 squared is 12.25. 6.7 squared is 44.89.
And 4.4 squared is what?
19.36.
And what is 2 by 6.7 by 4.4?
Minus 58.6.96.
Everybody
then
else get through with this? Everybody else get this?
Yes, sir.
Yes,
Yes,
sir.
sir.
Right,
Yes, sir.
so when we simplify, right, are we going to say 19.36 minus 58.96? We're going to do that?
No, because
No.
minus 58.96 is in a relationship with cos S.
Exactly. We're going to break them up just now, but not yet. Then, right? Alright, so we're going to add 44.89 and 19.36. And that'll be 64.25 minus 58.96 cosine S. So we want to isolate the cosine term. So what shouldn't be here?
64.25. We bring it over and we minus it from 12.25 and we will get minus 52.
Sarah, big up yourself, boy. Big up your whole self. Talking about W's in the chat, guys. W's in the chat. So far, everything correct. Where's 12.25 minus 64.25?
Minus 52.
That work out nice, boy. Hey, I didn't plan that. Minus 58.96. Remember, you had to make the cosine term the subject of the formula. So we gotta do.
And then now you take the minus 58.6 and you bring it over. Since it's multiplying, it will be dividing.
Exactly. So you're gonna divide both sides by 58.96 such that it will cancel off.
Yeah. And you would get 0.881953867. It always come back.
6-7.
Nah,
Always
boy.
come back. You see, I know it.
Gosh, man. Why this number so common, dog?
So it's a brain rot. It's a brain rot.
Just
Well, let me,
ignore the numbers. Just ignore the number.
I will do that. And so if I want to find for my angle, which is S, I'll have to apply the inverse trig function for cosine and plug that into a calculator.
You will get 28.1212, but we're doing to one decimal place, so 28.1.
Right. I sure if you look at this question before this class and you look at this and you see the working, you will see I can't do it. But like now you see how easy it is, right?
Yes. This was
sir.
a topic. Sir, me and Anne in the same class and we go to the same
Yep.
school. We Martin, and our teacher, when we got this topic, we just ignored it. Like we never got inquisitive. We just ignored it because we did not understand it at all.
But it easy, low-key easy, right?
It is once you explain it, but the thing with our teacher, he would just give you the handout and you would figure it out on your own.
Earlier, let me start our movement now. Maths in the Caribbean is taught bad, real bad. Like teachers would just give people things to read and like just write down things, tell students to follow the steps. But if very little times they explain why you're doing what you're doing, which is bad. You need to understand why you're doing. You need to understand.
They will just give 2 examples
the
and later
teachers.
talk about the rest.
Yeah, we gotta do something about that.
That's why the pass rate so low in the Caribbean.
Yes, somebody say it because most like in the Caribbean, people are just focus on passing maths. They don't try to understand maths. If you try to understand maths, you will naturally pass. Right? You gotta understand it. So watch. 28.1 degrees. Watch. I'm gonna reveal this. Whoa! 28 degrees. Same thing we measure. Right? Badness. So good.
So I get that correct.
Big up
Before
yourself.
you even call it out, I was like, wait, nah. That was the correct thing. I feel glad. It's a victory dance I was doing when I hear you call
I
out
have
the
to
thing.
victory dance. I have to victory dance. But W's in the
Somebody
chat,
take a
guys.
screenshot.
W's in the chat. W's in the chat. W's in the chat. Right.
Somebody take a screenshot and send it in the group chat for the people who like can't do it.
Like I'm telling you earlier, I ain't even gonna lie, right? If you just walk past and you see this, you're gonna say, boom, clot. I can't do this. This looking real hard. But you sit down and you look at it and you see it not that bad. But it looks hard. Most things in
Sir.
math just look bad.
Sir, like my math teacher in my Afro class used to say, if you understand maths and you practice it, it's not that hard. It's like any other subject.
No, it's better than any other subject. You know why? Because like, okay, if you forget something in biology, what you gonna do? Cry, right? You can't really do anything. Right? But in maths, you could kind of logic, you could use some logic, right? Like let me give you an example. If I ask you, okay, so x plus 7 is equal to 14, right?
Yeah.
What plus 7 is 14? What plus 7 is 14?
7
So
minus 14 is 7.
So you didn't even had a minus 7 from 14. Watch. What plus 7 is 14, guys?
7.
The answer for x is 7. You could think in maths. You could think in maths. You can't. What you could do in bio and them other subjects, boy? You'll cry. If you forget the vena cava and the bicuspid valves and the tricuspid valve, we gonna do? Right?
What
You
about
gonna
biceps and
You want
triceps?
suck
If I
salt.
forget
So you're
that,
going to suck salt. You have to suck salt. Sir.
Yeah, you gotta do that.
suck salt,
I'm fed up with body valves. I'm fed up with body valves. Fed up.
Yeah, boy.
So you want to teach us bio?
So
You know, I really didn't. Well, okay, in Cape I did biochem, pure physics. I did all the science subjects essentially. I did really good.
Sir, you good at integrated science?
I get one in everything.
Science.
The only one I ever get was in. I mean, okay, we are saying the only two I ever get. Like in CSEC, the only two I ever get was Spanish. I do 10 subjects. I only got 2 in Spanish, and in Cape, the only 2 I get was in communication studies.
Bomborax! Big up
biochem.
yourself, sir. Big up yourself. Big up yourself.
Sir, how good you is in integrated science?
I could, but like you see, the main focus is like it's one person already teaching maths, maths, and physics. I gotta stretch myself real fast. You know what I mean?
So it's not elastic, Gil. He can't do that. He's
can't do
not
that.
elastic.
I am not Luffy. Although I want to be free like Luffy. Big up all the One Piece people. Hey. Dog, Elbaf going real tough, dog. Yeah. If I watch One Piece, drop it in the chat. Let me know. I see Kristen raise his hand. Yeah.
No
Kristen?
drama, Gil.
Sorry.
Yes, you could give us one more and then we could go on a break.
One more.
Mm-hmm. Just like the
Yes, I would really help.
That's I could
Really,
do it
Sha,
in
I
like
see you died.
Okay,
I see
I'll
you
give a,
died.
hear what? I'll give all 3 minutes, right? I'll give all 3 minutes. Give all 3 minutes. And no, but we had to move on to sign rule though. We had to move on to sign rule, but here what? I'll give all one more question since all they're asking for it.
Sir, now I go kind of have to leave after like the one more question. So
Okay. Thank you so much for coming. All right, big
you're
up yourself.
welcome. Thank you. I learned a lot today.
Do here they said tomorrow. Tomorrow, guys, I go in right down. I will be here whole day, whole night, right down to the morning of the exam, helping all for free. Right?
What time we starting tomorrow?
That I don't know, but I'm telling you, I'll be like, don't worry. I will send you link in the group chat.
We can
And
start
I'll-
from 2
So
o'clock.
now like you could start like maybe like 5. So I have to prepare for English B2. So like I could use the morning and then in the afternoon I could just do pure maths.
I mean, I'm regular maths.
Yeah.
Yes.
So I will do some social studies in the morning because after maths I have social studies right after. So I'll do social studies in the morning. Pure maths after.
We
You
are
have
social
social
studies
maths.
Wednesday.
Social studies, that's Thursday.
Social studies is not Wednesday.
Yeah,
Social
Thursday.
studies is Wednesday.
That's Wednesday.
Bio is after.
Bio is
Time.
Ole, let me get back on this. Ole, let me do this question fast because I want to move on to sine rule now. I want to move on to sine rule. So, let me measure this angle fast. This is 0 degrees, 0 degrees starting from here, going. That looking like, this is 110, 111, 112. Looking like 112 degrees. So the answer is 112 degrees. So if you don't get that, you know you're wrong. So PQR is 112 degrees, and you are required to find PQR. Right? Cool. Let me just
So you're setting the timer, sir, or
wait, let me just double check again. Let me double check this thing again, right? If it's one thing, you can never be too careful. You can never be too secure in maths. You always have to check back. Yeah, really. Hey, because humans just make so much mistakes, eh? Telling you. No matter how good he is, he will always make a little mistake here and there. Yeah, that's
so
112.
literally in IT there's literally something we call human errors. So that's true.
So
In physics,
and in physics, it have
I'm
something
not
called
going to say that.
parallax error.
Yeah,
Parallax.
I know that.
Yeah.
I know that.
Yeah, know my stuff.
Right? So, guys, 3 minutes. 3 minutes. Try to finish it in 3 minutes,
So
right?
I have a question. Is that supposed to be 3.5 or 35?
That's supposed to be 3.5. I don't know where the point went. Yeah, 3.5. Right, go. Fast. Speed. I show speed. Yeah. Roof.
No, sir. No, not at all.
No, sir, that's crazy.
Ole, do the thing now. Do the question. Ole, do the question.
So it's back, back there.
Shh.
Oh shit.
I think we just call it math vibes for a reason, you know. Because it's math and vibes.
Are you barking going, boy?
That's Tavon. That's my best friend. Supposedly. Tavon is your best friend?
I say supposedly. If I ain't your best friend, why doing it?
No. I consider you a best friend, but you consider me a best friend.
Of course.
Big up. One time. Love on the chat.
Who the hell, why?
Alright. Get a friend like Tavon, boy. I only know Tavon for like a year. And he has been with me, helping me right through. Just for the heck of it. Big up Tavon. Tavon, what's your plan? Good?
Boy, I did you.
You getting trade programming?
Programming killing me, that I don't know, like.
Look, I don't want to talk about any lectures or anything on this live or anything.
Don't talk about them lecturers, boy.
Yeah, I want to see now. Because there's plenty of people, you know, Tivon, it had 390 people at some point on YouTube. I know that's 278.
300 on YouTube watching live.
390, 390, Tivon, 390.
Nearly 400. That's
And
mad.
on TikTok is 99. And in Zoom is 107. So a lot of people. I want to see anything sus.
You monitoring everything, boy. And I've been here for a while, honestly. I just ain't been saying nothing. I see when your man and them step out.
Yeah, they have it. They have exams.
Sir,
They
I'm
have
finished.
All right, so the time is, well, they still have 42 seconds.
I never
Hey.
expect you to back, though. The back side. Man turning speed.
Yeah, what's that? Let me explain something. People will be asking me for strategies and thing, right? Here, what? Everybody different. And my advice is just do the questions you're good at. Do the questions you're good at and leave the questions you're having trouble with after. Just try to secure as much marks as you could. But everybody's different. I can't give everybody the same advice.
That's the same thing we're doing in UE, boy. We just do the questions that we feel that we could secure some marks in, get them there out the way, and then run back to the ones that not giving we trouble. I ain't telling no like yeah, a lot of questions that are giving we. There's some that
Devon.
can automatically run through.
Yeah.
And them need the most frustrating questions because like what do you have to do with this? You forget one formula you cook. You
Yeah, you
forget
cook.
you forget the theorem you cooked.
Wait,
This
Tivon, let me show them some questions, huh? So like there's like one question.
That's what so move.
Yeah, it's one question.
And so let me tell you guys, this is my story with this course right here. I went into that exam and I only studied the evening before. So like I was going into a final exam with only like 6 hours of knowledge. Normally people just take weeks, months, even years, but not really years. What do you call it? Weeks or months to study for the final exams. That is a big thing. But me now, brawling, boasting, rolling into that exam with only
Hey
6
Tivon,
hours.
and the Chinese food, Tivon, that kind of mess you up too, boy. The Chinese food. Chinese food.
Boy. But that's before I even know you in this is
Oh,
before I know you. Yeah. This is the
okay,
first
okay.
time we do that exam.
Oh,
First time.
Wait, start on the
I will-
screen.
all right. This is one of the courses I did in UE. This is thermodynamics. Yeah.
Thermodynamics.
Okay.
I roll into
This
that
is
exam.
okay. This is one question. One question in UE. Yeah.
That's
I bet
okay.
it is.
I won't be doing UV because where's that
I'm
question?
telling you.
No.
Wait. Let's see how this look complicated, but you was able to figure it out.
Yes,
Yep.
sir.
Is
So
the
guys,
exact same thing? Is the exact same thing? No, line is the exact same thing. Is the
that
exact
was physics.
Yeah, that's
Compared to the
physics.
one that we
That's
did.
physics.
Oh my god.
All right. So let me answer the question quickly now. So first of all, what is the side opposite the included angle?
Q.
Q. Right,
Common
Q.
Q. Common Q.
So I'm going to say Q squared is equal to what?
Q squared is equal
Q
to
squared.
R squared plus P squared minus 2 RP cos Q.
Right. If you don't know what, this is common Q. This is common R because you know opposite angle R. This is common P because it's opposite angle P. All right. Cool. I plug in everything fast now. So Q is 8 squared. R is 6 squared. P is 3.5
3.5 squared
minus 2
negative
by
2 times 3.5 times 6 cos Q.
right? 8 squared is 64. 6 squared is 36. 3.5 squared was 3. Wait, let me see if I can do it
12.
mentally. Wait, let me see if I can do it mentally.
So we did
Wait,
this
now
already.
what?
So you should
12.25.
remember this.
12.25. I'll tell you something, right? I have ADHD and my working memory is like a goldfish. However, I have the good ability to understand things. So in my exams, I never memorize anything. I just understand it. I just understand it.
Sir, give me a brain now.
You don't want my brain. You don't want my brain.
I was
Because
just going
like
to ask you, was that a good thing or a bad thing to keep your brain?
you don't want my brain. You really don't want my brain. I'll be talking to somebody mid conversation and I forget what they say. I'll ask them back a million times, right? But however, I got out figuring out things on the spot. But to memorize things and remember, I need to understand something to remember it. So I see.
Sure, that's my problem. I need to understand something to remember it, or else I now will be able to like think.
That's everybody.
Real.
Right.
Anyway, 36 plus 12.5 is 48.25.
48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25. 48.25
minus 42 cos q. You want the cos by itself, you can't break them apart, so you have to bring that over. That's
Only it-
15.75. Wait, let me double check that for real.
Yeah, that's correct.
Oh, it's correct? Okay. And then you bring the negative 42 over and divide it.
Right? So alright, let's come tomorrow again, your marks, eh? I mean
Yeah,
not
today.
tomorrow. It's scaring you, the 12, the 12.
That will be 0.368 and then never ending 333.
Wait, eh?
So
15.
0.368333333.
No, but I gain 0.375.
So I got positive 15.75.
Oh wait, no, my bad. My bad, sir. I did the wrong number.
She make a mistake.
Yes, 0.375. I made a
Alright,
mistake. My bad.
but it will be Alright, let me just check something. Yeah, so cosine q would be equal to what?
15.
Negative 0.375.
Right.
Yeah, negative 0.375. And then you would do inverse. And you would get 112.02.
To 3 decimal place, I mean to 1 decimal place is just 112.0
Yeah.
degrees. I wonder what was the
I
answer on the board.
realized I was telling you the wrong thing, but I had the right thing. And I did it in like
Wow.
the opposite order, but I still get it right. Like I just did p squared and r squared, but it's cumulative, so it don't matter.
Yeah. That's correct. That's the correct. So okay, that's the question. That's the day. Same thing as the last question. Nothing changed. Same thing. Right? So we're gonna move on. Right? We had to move on, guys. Right? So we're gonna cover sine rule now. If we want to finish what we had to do, we had to move on. If anybody confused, or they watch a YouTube video, write it down, like do the question one and you'll be fine. It's really not hard. It's looking hard, but it's not hard. I promise you. Right? Now you're gonna move on to sine rule. So when do you use sine rule? Number one. If you don't have an included angle, what do you think you gotta do? Wait, I see people saying wait. Here what, right? I cannot jump the gun here, right? Because I was moving with some speed. If you have cosine q is equal to minus 0.375 when you want to find for q, all you have to do, guys, you have to do what?
The inverse?
Right, you'll have to find cosine inverse of minus 0.375. So people on the YouTube, find cosine inverse of minus 0.375 and tell me what you get.
Wait, sir, I have a question.
Yeah?
Because it's 0 after the point, if I just put 112, would that be wrong?
412. 412.0. 412.0. Because you're showing that the one decimal place.
Sir, I
Right?
have to go now, so I'll see you guys in the next meeting.
Wait, boy. Wait.
Bye.
How much you leaving, my dog? How much you leaving, boy? Wait, boy.
Bye, guys.
Bye.
You know what? I like to move with speed, but I don't think you guys fully understand the question. I'm gonna run it back on one more time. It don't make sense I move with speed and nobody understand. Let me run it back again. What's the question?
So the general formula, right? Does it have to be A, B, and C, or it could vary? The letters could vary.
Wait. It could vary. Watch. In all these questions, you see A, B, and C?
No.
No, watch. In this question, you see A, B, and C?
No.
No. In this question, you see A, B, and C?
No.
No. Right. In this question, you see A, B, and C?
No.
In this question, you see A, B, and C?
No.
No. However, if your triangle have A, B, and C in it, yes, then it would have A, B, and C because your triangle have A, B, and C.
Okay.
Yeah. Let me explain this quickly because I feel like a lot of you guys are lost all here. Bad. So guys, you want to find for angle Q, right? So the first thing you have to do, you have to isolate cos Q. What is the cosine term there, guys? What is the cosine term on this side?
40 before.
No, this is the cosine. Yeah, the negative 42 cosine q. That's the cosine term. We want that to be the only thing on the right hand side. If we want this to be the only thing here, does the 48.25 belong here?
No. You have to
No.
move it across.
You
Right.
bring it to the next side.
Right. And that will be 64 minus 48.25. And that'll be equal to negative 42 cosine q. What is 64 minus 48.25?
15.75.
Right? Go back with this, man.
He just showing up when he feel like, you know, I just he
You see, that's why I say you have no this a dumpling.
Right. Okay, and then we continue, right? So guys, we're trying to find for before we can find for the angle, you first need to make cosine q the subject of the formula. So right now, cosine q is being multiplied by negative 42. So you're gonna divide both sides by
Negative 42.
and the reason why you're doing that is because you want to find for cosine q, so you need this to cancel off, right? And if you do something on one side, well, you have to do it on the other side. Right. So cosine q is just 15.75 all over minus 42. Plug that into your calculator and let me know what you guys getting.
Negative 0.3. Negative 0.3.
Minus 0.375.
Right, and you want to find for q, which is the angle. So now you need to apply the inverse trig function for cosine, which is cos inverse. So cosine inverse will be negative 0.375, and which is 112.0. Listen, people on YouTube, wait, I'll show it just now. That will be 112.0243128. And if you run it off to the nearest, to 1 dp, the first decimal place is 0, right? The number after 0 is 2. It is less than 5. So it's going to be 112.0 degrees. Right? And we round it off to 1 decimal place. Everybody okay with that?
Yes, sir.
Right.
Yes.
People that new to Math Vibes that don't know about my page, hear what, right? Or they keep asking me if I have vectors and all kind of thing. Hear what, right? On my YouTube channel, I have ultimate playlists for art maths, physics, and maths. And especially for maths. If you go, you're going to see a crash course. You're going to see circle theorem and geometry, kinematics, patterns, areas, and volumes and transformations. Algebra part 1, factorization with the problem, subject, of formula, proportionality. Algebra 2, functions, part 1, quadratics, computing the square. Functions, CSEC math vectors, statistics, probability, combination, and construct arithmetic. CSEC matrices, past paper drills, trigonometry, 90 degrees, not 90 degrees. Bearings, matrices, all our matrices. Everything. Just go on my YouTube channel, guys. And everything is extremely in-depth, like what I do here. Right, so sine rule. Obviously, you would use sine rule anytime you don't have a what? Anytime you don't have a what?
Included angle.
Right. If you do not have an included angle, so obviously, if you have an included angle, you're gonna use cosine. So if it does not have one, obviously you're gonna use sine rule, right? Does not have. And you use it when you see a pair of information. What I mean by this, boy? What do I mean by this? I mean, like, I have a length, and I should probably say the angle first. Yeah, you have an angle and the corresponding length. So, like, what I mean now, if you have angle B, then the corresponding length will be what?
B.
Right. Right. So this is one thing you're looking for. If you have an angle and a corresponding length, that's a pair of information right there. And the other thing you're looking for is a length or an angle. That's it. Right? Cool. What the S going by? Yeah. And sine rule typically looks like A over sine A is equal to, but all you understand, it don't have to be A, B, and C, right? It don't have to be A, B,
It
and
could
C.
be R, S, and horizontal or
It just depends what you have on the what you have on your triangle. That's all. It depends on what you have on your triangle. Understand?
yes, sir. So if it's there is the one way you can like cross divide or what way to call
Yeah,
it.
yeah. Cross multiply. Cross multiply. Yeah,
Oh, cross
kinematics is in CSEC. Right. So you use sine rule if number one. If you don't have an included angle, you use it. Number two, you use it when you have a pair of information. So but what I mean by that, when you have an angle, what? Oh, you see this? No, they didn't see that. As well angle correct, right? Yeah, as well angle correct, right? I was crashing out there. I was like, did I spell angle wrong? Like I
Yes,
looked at
no,
the,
you spell it correct. If you
you know,
put the E before the L, it could be
the angel.
angels, not
Yeah, man.
You spell it
All you know
correct.
what I mean, right? All you know what I
Yes,
mean, like you go look at a letter, and I mean a word, and the more you look at the word, the more wrong it is look. Yeah.
yes, sir. I tell you, that has happened to me.
Right. So let me give you an example now. So here what? When you're using sine rule, you're only using 2 out of these 3, right? At any given point, you are only going to use 2 out of the 3. So, will I ever, at any point in time, be using A, B, and C?
No, sir.
No.
No, sir.
I could use A and B. I could use B and C. I could use A and C. Yeah, and I understand that, right? Hope you understand that. Good. So let me give you a quick example of what I'm talking about now. Here what? I ran show you about this, right? Let me use the same question, huh? The same question, shall we? Copy. Right, so you have a question here, right, guys? And I know what the angle is, right? And from your last question, what was the angle? Remind me.
112.
It's 112 degrees, yeah?
Yes, sir.
So what it typically like to do, right? Here what it typically like to do. In the exam, you typically have to use cosine rule first. Typically, you use cosine rule first, and then you use sine rule. You know why? Let me explain why. If and I use and by using cosine rule, I was able to figure out this angle.
Yes, sir.
Yes, and now I have angle Q and I have
Length Q.
right, and this would be called a
Pair of information.
right because I have a
Angle and a corresponding length.
right. So that's why you typically see cosine rule first, then sine rule. So watch. We have angle Q and we have
Length Q.
yes, yes. Right. So I'm gonna change up things, right? What all I want to find for in this question? We could find for another angle. Which angle do I want to find for?
R.
Angle R. Okay, no problem. So I'm gonna give you a question required to find for R. Now you see, like the first piece, our advice does not have an included angle. It's not the best advice, right? Because you see an included angle in the question, but you already have the angle and the corresponding length. So the best, this is what you're looking for. You're looking for a pair of information, an angle and the corresponding length. That's what you're looking for. So let me apply the sine rule here. So let's write the full sine rule. So the full sine rule would look like, I'm going to start all off, right? So common R over,
Sine R.
right? Common R over sine R, and that'll be equal to what?
Common Q over sine Q.
Right? And like I said, if you're confused, remember I tell you, it could be any letter, you know. It depends on the triangle. And that will be, what else it will be?
Common P over sine P.
Everybody with me, or like, are they confused?
Which
All you
is
understand that this, I use an A, B, and C here, but it could be any letter, you know. It just depends on what type of triangle. What do you have in the triangle? That's all. That's all. Right?
Yeah.
Now, at any point in time, am I going to be using all of these 3?
Nope.
No, sir.
Nope.
Only
No.
two.
So, yeah, there's never use all three. There's end up using two.
Now, this is the next question. Which ones to use? I feel so bad for the people I'm not seeing this live because with this trick, you're never going to have a problem again. Which ones to use?
Sir, excuse me, sir.
Yeah,
What does RTF stand for? I'm sorry.
required to find. It means required to find. So you're required to find for R.
Okay,
Required
thank you.
to find. Yeah, so like to figure out which ones you're gonna use, number one, you're looking for what you're looking at what you have. What you have. What you have. Right? And what I mean by that, I mean like the payoff information, guys. Talking about the payoff information. So you're looking at what you have. That's the first thing you're looking at, what you have. And the other thing you're looking at is what you're trying to find for. What are you trying to find for? Okay, so answer that question for me, guys. What is the payoff information I have in this question? What's the pair?
Q.
Let's see in that, right? Let's see in that. We have angle Q and we have length Q. I'm gonna follow see that.
Yes, sir.
Yes, sir.
Yes, sir.
Starting the blue guy back in the zone.
I can't do anything about that. We just had to focus, right? Tiffon, I'm gonna make you a co-host, right? So if you see any suspicious behavior, you know what to do. Right. Pick up yourself. So
Hi, sir. I joined late.
Ishana, that's you, and I know that is Ishana. For those that don't know, Ishana is Mrs. Math Vibes. Yeah. Love you. I love you too. Yeah. Right. I hope you eat food and thing and drink water. Eh? Make sure and eat food and thing. All right. So what's the pair of information let's see in here? Right. Am I somebody mic muted? Somebody mic unmuted. Mute yourself, please.
Okay.
All right.
But tomorrow I'm going to end up sleeping.
Yeah, somebody mic is Nathaniel. Yeah, Nathaniel. Could I mute somebody? I should be able to mute them. Again, all if they're not talking, mute all your mic, right? So the pair of information here is Q. I'll understand why I'm saying Q, right? Because I have angle Q and I have length Q. So immediately, I am going to parallel tick by Q. I know how to use that. And then, what are you trying to find for?
Angle R.
Right. So immediately, I'm going to tick by R. I'll what more no?
Yes, sir.
That's all. You're just looking at what you have and what you're trying to find. So the formula I'm gonna use is R over sine R is equal to Q over sine Q. That's literally all I want. And why I use this two? Somebody tell me fast. Why are you using these two?
Because we have the angle.
Yeah, the angles opposite to each other.
Yeah. I have this is a pair of information. I have angle Q and I have length Q, so I could use Q. And I'm trying to find for R, so automatically I have to select R. Cool, let's move on. So do I know what length R is? Do I know what length R is? What's length R, guys? 6
centimeters.
Do I know what angle R is?
No, sir.
Negative.
Leave that blank. Do I know what length Q is?
Yes, sir. 8 centimeters.
8
Do I know what
Yes, sir.
Do I know what angle Q is?
Yes, sir. 112 degrees.
Aha. Are we like working with fractions?
Yes, sir.
Yeah? No.
To extent.
No.
No,
No,
we have
no,
to
no.
cross multiply.
Whoever said I'm lying.
You could cross multiply and then make
Right.
it magic.
Now let me
That's
say
why I
something,
say
right?
to extent.
Right, let me explain something. A lot of you guys are going to go in the exam on the 12th and write sine 8R. Is that legal?
No.
No,
Not legal.
No, it is sine R. It is sine R multiplied by 8. So it's
Yes,
going
I
to
know that.
8 sine R,
8 sine R.
8 sine
It's
R,
sine R.
and then that's going to be 6 Again, some of you all are going to go on the 12th and multiply 6 by 112. No, no, don't do that, sir. I'm going to make me go bald. I don't want to go bald. I don't want to go bald. Right, so that's going to be 6 sine 112 degrees. Right? So look what I do, right? I multiply sine r by 8 sine r. I multiply 6 by sine 112, 6 sine 112. Are you understand that?
Yes, sir.
Okay, good. And hey, you see how we handle this question over here? We was trying to find for q.
Yeah.
It's the same process more or less, you know. So we first had to isolate what we had to isolate first.
The
Cosine
I had,
Q.
I had to isolate cosine q. And then I had to find cos inverse. It's the same thing over here. It's just sine. So what do we need to isolate over here? Well, no, not
Sine.
over here. Right? No, not over here. Over here. What we need to isolate.
Sine R.
Right. But sine r is being multiplied by what?
8.
So to isolate it, what we gotta do?
Divide by 8.
Divide.
Right, you divide by 8, it cancel off, and I'll leave you with sine r. What's the next step?
Find
Or
the
if
inverse of that.
you want, I'll plug this into a calculator, right? Plug that into your calculator and let me know what you guys getting. So 6 sine 112 divided by 8. What are you getting for that? So my guys, 6 sine 112 divided by 8. What again?
0.695.
538.
Yeah, all that.
Yeah, you could just put 6 decimal places. It's fine. You could put 6 decimal places. I recommend that. And so if you're trying to find
Sir, for some reason, I'm not getting that answer on my calculator.
first question I'm gonna ask you, have a sharpens?
No, I have a Casio.
What? Your Casio could do fractions?
Yeah.
Next question. You have a D on top? Like, is it saying a D on top or is it saying R?
Oh, yeah, let me see. Oh, I have a R. Hold on.
Right, so you have to press Shift menu, and you're gonna press 2 for angle units, and you're gonna press 1 for degrees.
Okay, no problem.
Co-host, just mute some people now. I don't know why they had their mic unmuted and they're not talking. All right, let's move on now. So sine R is 0.695387. Okay, how am I gonna find for R now?
Inverse.
Right, it's the same procedure like last time. Same thing, you know. Over here, what we do to find for Q?
Find the inverse of it.
Right, so over here, we're just gonna find sine inverse.
So I get 44.1.
You get 44.1.
Yeah.
Anybody else can
By the
verify
answer,
that?
yes. By the answer.
People on TikTok, people on YouTube, let me know all again. Yeah, again, if I round it off to 1 decimal place, the first decimal is 0. Number after 0 is 5. So I'll add 1 to 0 since it's 5 or more. So it's going to be 44.1 degrees.
Yes,
right?
I get it.
And if you have trust issues, you know what, we could measure it. We could actually measure it. So when I measure this thing, what am I supposed to get, guys?
44 degrees.
Are they trust any maths?
Yes, sir.
Yeah, I
Wow.
trust the
Yeah, what angle is that, guys?
44.
Bam. Bam. Badness,
44.
badness, right?
We do it again. Yay!
Yeah. So if you are required to find for an angle using the sine rule, you're looking for a pair of information. You look for what you have and you look at what you're trying to find for. That is going to tell you which two to select. After you select the two, you're going to substitute and cross multiply. Then you're trying to isolate the sine term because it is sine r. You're going to isolate it and then apply the inverse sine function to find for the angle. So I hope you guys understand this. Are you okay with this?
Yes, sir.
Okay, now I'll give all a question. I'll give it
Yes,
So I don't know.
So let me run through the process one more time. Can somebody tell me why I choose r over sine r?
Because there's the angle you're trying to find.
Right. I am trying to find for angle r. If I'm trying to find for angle r, wouldn't I need the unknown in my equation?
Yes.
Yes, I need. If I'm trying to find for something, of course I need it. So I'm gonna select r over sine r for sure. And why did I select q over sine q?
Because you have a pair of information.
Right. So I have the angle and I have its corresponding.
Length.
Exactly. So I choose q over sine q. Then I plug in the information. I cross multiplied. If I say something like sine 8r, that legal?
No.
Legal.
No, that not legal.
That's not legal. That's not legal, right? So hope you guys understood this example. Take a screenshot. Please take a screenshot. I'm going to give you another question to do. All right, Alia, have your screenshot, right? Yeah, no, maybe potentially.
Yes, sir.
Yes, sir. Yes,
All right.
sir.
Here what? Somebody mic Alia. You go follow for that, you know. Follow for that. If you're not talking, mute yourself. All right, let me give Alia a question. Again, this is heavily integrated in bearings, eh? Heavily integrated in bearings. So all of this what we're doing right now, you need to use it in a bearings question. Just imagine how lost all it'll be if I just jump straight to bearings without going through the foundation. Right? So I had to go through the foundation. Had to. So 34.1. Right. So I'm gonna give all that question. And what angle I want to find for? What are you feeling to find for?
M.
Are you feeling to find for n? Okay. Required to find. And how would I write that in the three letter notation? How would I write that in three letter notation?
M and M.
I would say M and L. Remember, the letter in the middle is the angle we're talking about. So angle N. Right? Would. So I'll fix up. 3 minutes, go. When the TikTok live ended. Gosh, live studio access suspended. TikTok, yes? I'm fed up. I real fed up at TikTok, boy. I don't know what to do, yes?
The man coming after you, boy. Careful when you reach 20K.
They say suspended due to inactivity.
But then what you do, run?
I feel so.
Yo, I backflip on stream, boy.
Hey, Tibon, is a good thing I buy 2 phones, you know? Dog. Things gonna be crazy.
I mean,
Because, like, I watch any YouTube comments on this phone. I go on live stream on TikTok on this one. Yeah.
nah, boy. That way too much. I don't know what you doing. And plus, you teaching one time. You have some moderators in your chat, boy.
Yeah, how do I get some moderators?
You have plenty volunteers.
That's good.
You have plenty
Ooh.
volunteers, boy.
Yeah, people on TikTok. Let me see the TikTok. People coming back. Right. Right. 51 seconds. I fed up on TikTok, you know. I real fed up on TikTok. Like, what do you expect me to do, boy? I'm teaching. You know what I mean?
Yeah, mom was he think he's a butter or something, boy.
Apparently. All right. Time is up. Are they got through?
But of course,
Nice.
Yes, sir.
So let me measure the angle so you can kind of get a gauge to see if it was correct or not. Measuring the angle looking like what?
what this is?
I'll get your answer close to 40.
Yes, sir.
Yes, 39.85.
Yes, sir.
Right. If you run out of to the nearest degree, where I'll be?
Maybe what this is?
40, right? Blessings. So somebody tell me, how would sine rule look like for this question?
Well, shucks, I'll use sine rule. Lord, sorry, I forget about that test.
You know, you could use cosine rule. You could.
Nah,
Because you have
because
you have an included angle. Yeah.
I mean, I
You see,
understand you have to practice the sine rule there, but or I should already cosine rule, but next question I'll
now,
do to the sine rule, so
now, but you see how cool maths is, right? So long
Yes,
as you
sir.
do the correct thing, you'll get the same answer. Right? So
Understood, sir,
guys,
thanks.
yeah. So sine rule. What would sine rule for this question look like, guys?
So
L
common.
over sine L
Right? Common L all over sine capital L. Yeah.
equal to common N over sine capital N.
Right? Sine capital N, and that'll be equal to what, guys?
3.5.
Wait, tell me just monitor the live chat on YouTube, right? Yeah. Yeah. And that'll be equal to what other letter?
Common M over sine capital M.
Am I going to use the three of these?
No,
No,
sir.
sir.
No.
No. How am I going to figure out which one to use?
You need the one with
The one with the
Figure out what you need to find and you pay
L sine.
attention.
Well, I had to use L. Can anybody tell me why I had to use L?
because
because
that's
it's
a
a
So
pair,
pair.
that's what you
a
have.
corresponding
Because you
pair.
have both
I have both.
lines.
So
A pair of information.
I'm gonna select L one time. What angle are we trying to find for? What angle are we trying to find for? We are trying to find for N. This is what we're trying to find for, yeah, guys? N. So if we're trying to find for N, automatically I had to use N, yeah?
Yes, sir.
Yes,
Right.
sir.
One more time. What is the pair I have? L. I have L, right? I have angle L and I have length L. So automatically I select L over sine L. And why did I select N? I selected N because I'm trying to find for angle N. So I need to include that in my equation to solve for it. Good. So let me substitute now. So the equation by itself would just look like this, and now we're going to substitute. So what is common out?
2.5 centimeters.
Right, so we'll say 3.5 all over.
Sine 4.1.
And that'll be equal to, what's N?
4 centimeters.
And that's going to be over sine N. What is capital N? Do we know what that is?
So you can explain about that part, please.
No.
Which part? The part?
Okay.
All right, so I'll tell you. Wait, so do you understand why I selected L over sine L and N over sine N?
No, so that was asking you to explain over.
All right, so you're looking for a pair of information, right? A pair. You're looking for a pair. What I mean by that? I mean like you're looking for an angle and a corresponding length. So we have angle L over here. Do we have common? Do we have length L?
Yes, sir.
You say no?
So I said yes.
Yes.
2.5.
To look for that, you're gonna look at the length that's opposite the angle. So you have length L and you have angle L. So isn't that a pair? You have a pair, right?
Yes, sir.
You have a pair. L over sine L. And so immediately I'm going to select L over sine L. Yeah?
Yes, sir.
Right. What are we trying to find for? What are we trying to find for? Which angle? Which angle are we trying to find for? Right. If you're having a hard time with this notation, let me show you what it means, right? So M, N, L. Where does the angle look like it's forming? By M, L, N, M, N, or L?
N.
Right. So we're trying to find for what angle?
Angle N.
Yes. So immediately I have to select the one that have N in it. So N over sine N. You understand?
Yes, sir.
Yes, sir.
Yes, sir.
Again, you're looking for the one that has a pair. So like a angle and a corresponding length. And then you're looking for the one we're trying to find, right? I'm trying to find for angle N. So immediately I choose N over sine N. And then I substitute. So common L is 3.5. Put 3.5 here. Angle L is 34.1. Put 34.1 here. N, common N is 4. I put 4 here. I don't know what angle N is, so I'll leave it blank. I just put sine N. So I hope you guys understand that. Yeah,
Yes,
yeah.
sir.
Simply Shania. Simply Shania. Yes, yes, it is easy. It just looks complicated. Most things in maths just look complicated. So we hate working with fractions and all here. So what I could do? What I could do?
Cross multiply.
Cross multiply.
Right, I could cross multiply. So typically when we cross multiplying, I like to multiply the one with the variable first. That's what I like to do. I like to apply the one with the variable first. So what I multiply first? 3.5 by sine N or sine 34.1 by 4?
3.5 by sine N.
Right. So I'll say 3.5 sine N. And so if you're confused, right, all I did was I multiplied 3.5 by sine N, 3.5 sine N. And then we're going to do the same thing over here. So what is that going to be?
4 sine 34.1 degrees.
4 sine 34.1 degree. Nice. So here what, right, guys? We have to isolate the sine term. Right now, the sine term is what happening to the sine term. What is happening to the sine term?
Is being
It's being
multiplied.
multiplied 3.5.
Right. So we're going to divide both sides by 3.5. Right. So you're going to end up with sine N and plug this into your calculator fast and let me know what you're getting.
So I got 0.643073.
Right. Let me just. Yeah, 0.6407 30. That's fine. We could just write the 6 decimal places. And if you want to find for N now, what you how to do, guys?
The inverse of sine.
Right. So you'll say sine inverse of 0.640730. What are we getting for that?
39.8.
39.8.
39.8 degrees. Bam. That's it? That's it.
Yes, sir.
Yes.
Yeah. And when you measure the angle, it's literally saying 40. Yeah, it's saying 40. So if you round this off to the nearest degree, it'll be 40.
Yes,
But this
sir.
was still one decimal place. Nice. Here what? I want to do. Let me speed run some other cases quickly, right? You guys need to know how to find the angle. We're done with that. You also need to know how to find the length using the sine rule. Okay. So let me show you how that would look like. Same triangle. I'm going to remove some information really fast. So, so we know how to find for angles. That's not a problem.
Sir,
Yeah.
so I have a question. How you got the sine n equals to that decimal? How you word out?
I just plug it into my calculator. I just plug this into the calculator. Yeah, so watch. So if I presume most of you guys have a sharp, so I'll show you guys how to use it, how to do it as a sharp user. So 4 sine open bracket to the 4.1.
So I have a stub mark. Is that better? I'm not sure.
Stud mark is better. Is it the same layout like this?
Not really.
You have a fraction button.
Yeah.
Okay, press the fraction button.
But it's not like that.
It's not like this.
No, it's like A with B over C.
All right, just do this. Just put 4 sine to the 4.1 close bracket, right? Divided by 3.5. Should get that. Let me know if you guys getting that. Yeah or no?
Oh yeah, I got it.
Yes.
Thank
Right,
you.
cool, no problem. So here what? We're gonna find for length n. So in this question, we had to find for angle, right? I'm gonna switch things up on you guys. So require to find for length lm. So here what? We already know what the sine rule would look like for this question. That's right. I'll just copy and paste to save some time. Guys, again, we're looking for the pair of information. What pair are you seeing? What pair of information are you seeing in the question?
L and N.
L and let's see now, right? We have angle L and we have length L. So I'm going to select L. Yeah, I'm going to select L. And then the question is asking me to find for what?
Length N.
LM is what length?
N.
N. So immediately I have to select what?
N. Sine N.
Good. So all you understand, I'm going to pick L all over sine L. And that's going to be equal to N all over sine N. And now I just substitute, right? So what is length L?
54.1.
Now, length L is 3.5. What is angle L?
34.1.
34.1.
All the common letter is length, not angle. Right? And that would be equal to N over sine N. Do we know what length N is in this case?
No.
Now, so I write back N. Do I know what angle N is?
Yes, sir.
What's angle N?
39.8.
39.8.
Right. So do we like working with fractions?
Yes.
Olya, why?
No, sir.
Olya,
No. Lying.
Olya tweaking, boy. Olya tweaking. I don't like working with fractions, so I'm going to cross multiply, right? Now, for the math people out here that like maths and understand maths a little more than the average person, you guys know there's an easier way, right? You don't have to cross multiply. You're trying to find for n. Right now, n is being divided by what?
9.8.
Right, so if you're trying to find for n, you want to cancel this off. So what's the opposite of dividing by sine 39.8?
Multiplying.
Multiplying.
Right, so if you wanted, you could have multiplied both sides by sine 39.8. But I understand most students just they're okay with cross multiplication, so I just stick to that route. But I just saying what you could do now. So you cross multiply. I'm gonna cross multiply the one where the variable is. So cross multiply this and tell me what you get.
N sine 34.1.
Right, n sine 34.1 degrees. Let's cross multiply the other diagonal. What would this be?
3.5 sine 39.8 degrees.
All right, okay, bet. So we are trying to find for n, right? Right now, n is being what? What is n? What's happening to n?
By sine
They
34.1.
multiplied.
Right, let's see now, right? Watch, n multiplied by sine 34.1. If you're trying to find for n, should n be multiplied by anything?
No, sir.
No, sir.
We're gonna divide.
So I had to do the opposite of multiplying. I had to divide both sides by
Sine 34.1.
34.1.
and when I do that, n is gonna cancel off to leave me with n.
Yes, sir.
Right. Right, so good luck plugging that into the calculator. If you have a Casio, it's real easy. if you have a sharp, it should still be easy. So you're gonna put 3.5 sine in brackets to the 9.8 close brackets divided by sine open bracket to the 4.1 close bracket. Let me know if you guys getting 3.99.
Yes, sir.
Yes, sir, that will be it.
And if you round that off to the nearest degree, while saying degree, right? We find if our length, that'll be three significant figures. If you round that off to three significant figures, what that would be? You know, I should probably explain that. Watch 3 point.
It'll be 4, sir.
Watch. All right, three significant figures, right? Because it's a number. First significant figure is this. Second significant figure is this. Third significant figure is that. What's the number after 9? What's the number after 9, guys?
6.
6. So you're gonna add 1 to 9 and you're gonna get number 10. You're gonna take that 1, you're gonna add it to 9, you're gonna get 10. You're gonna add that 1 to 3, you're gonna get 4. So n is just what?
4.
4.
Right.
4.
4.4. So three significant figures. Are you understand that? And the units, what's the units, boy? It was centimeters. Remember, we're trying to find for a length, right? So the length in this question is measured in
Centimeters.
Yeah. So, and again, all you're gonna be mind blown, right? I use the same diagram. I use the exact same diagram. So watch. I shouldn't be surprised that watch. Are you seeing that or no?
Yes, sir.
Yes, sir.
Yeah. Everything in math is interconnected. Right? Yeah. So let me run through the process one more time now. So again, in a sine rule question, what are you looking out for? What are you looking out for? Yeah, 4.00 will be correct. 4.00 will be correct. The reason why I didn't put 4.00, in case all you're wondering, is because I round off to three significant figures. So if I had round off to three decimal places, then I would have to put, if I didn't have anything, I'd put the 00 to represent the decimal places. But three significant figures, I could just write 4 centimeters. Yeah. So let me run through the process, right, guys? What's the first thing I'm looking out for when I'm doing the sine rule? When I'm doing the sine rule, what is the first thing I'm looking out for?
A pair.
A pair. Right. So I see we have angle L and we have length L, which is good. So I'm going to select L over sine L. Next thing, I see that I'm trying to find for length LM. Length LM corresponds to what?
Length n.
Right, so I'm going to select that one time. You see n over sine n, select that one time. So the two that I'm using is L over sine L and n over sine n. So now we're going to substitute. What is L, guys? Fast. L. What is L?
3.5.
Right. What is angle L?
34.1.
Do we know what length n is?
No, sir.
Blank. Do I know what angle n is?
Yes, sir. 39.
Yes, 39.8.
Right. So now we're going to cross multiply. And my advice is typically you want to cross multiply the pair that has the variable in it. So what's the variable we're trying to find for over here?
N.
N. So I multiply sine to the 4.1 by n first. And that's going to be n sine to the 4.1. Right? N sine to the 4.1. And then I'm going to multiply the other diagonal. And so that's going to be 3.5 sine to the 9.8. Let me follow with me.
Yes, sir. With you.
Right. We're trying to find for n, right? But right now, n is being multiplied by sine to the 4.1. So we can't have that. We have to divide throughout by that. So you cancel off now. And if I do something on one side, I'll do it on the
other side.
Other side. It makes sense.
I divide both sides by sine to the 4.1. And remember, numerical answers are to be written to three significant figures. So my third significant figure is 3. Number after 3 is 6. So I'll have to add 1, and go back to the 3, 4 centimeters. Do you understand?
Yes, sir.
All right.
Yes,
So here what? We can now do past paper questions because you're okay with sine rule, right? We looked at all the cases. So we looked at a case where you have to find the angle in sine rule and a case where you have to find the length in sine rule. So let's finish that question from 2025, shall we?
Yes. I just want to say we busting up this paper.
Yes. That is what I want to hear. Math's not hard. It just look hard. I have a light earlier, like, okay, I'm not talking about people I'm not talking about people that join later. I'm talking about people that was here from the start that had trouble with it. What do you think about it now? Was it that hard?
Nah, it really easy.
So,
No, sir.
it
No,
really,
sir.
Easy
No.
now.
it get easy as I do more
No,
practice
it definitely was hard.
Yeah.
It's
and they
simple
explain it
now,
more.
but still need more.
Yeah, it get more easy now.
But I
So
never,
like it's stick in my head.
but I never lied to you though. I would tell you guys what is something that's like genuinely hard. Like if I'm talking about things that even if I explain to you, you still wouldn't get. This is not one of them. Right? So let's answer part 3. Part 3 says to determine the bearing of town A from town C. I should probably get an empty diagram for this. Big up Titanic again. I don't know if I'm a little too young to know about Titanic, but big up Titanic. Yeah.
Oh, and Titanic, yes.
So that was a bit of a disrespect, by the way.
Yeah.
Are they just be calling me uncle and all kind of thing? So like,
Like when Sir
So
asked
you
if
so
you know
you
what
don't even
DVD
know
was.
so you don't even know
Such
that
a-
one altered. Considering Titanic, they're not even like the coolest, like proper
I can tell you
old
something,
movies.
sis. I can tell you something.
what's that?
All I remember from that movie is Celine Dion song.
Oh, we gonna sing that at the end. We gonna sing that at the end. Forever you are.
So you mad,
And
you
I
mad, so you
know
mad,
that
so you
was
mad,
what you.
so you mad, you mad. If you want to be a proper old, so what you buy me a win?
I thought you're dancing, my
Poem.
dear. That's so bad.
He's making them
On behalf.
notes.
My heart
Right.
will go on. That's the name of the song.
Badness. Well, let me tackle this question, right? So, in the previous parts, we had labeled this. We had figured out that this angle was what? Look back at the previous notes. We had found this angle was what?
42?
Right.
42, 04, so that you can't forget to put the 0.
Right. Happy all correct, and good. And we had said that this was point what?
B.
Right?
Point B.
And this is?
Point C.
Point C.
People that wasn't there with me from the start might be a bit confused. Just go back into the live, like scroll back, right? But I had to move on. So A, B, and C, right? What we had to find this angle to be?
92 degrees.
92 degrees. 09092.
No. If it's just an angle, you don't have to put the 0, right?
Okay.
Yeah. For bearing, you have to put the 0. Okay. And well, we had found this angle here to be what?
138.
138.
If I forget, remember, co-interior angles add up to what? What do co-interior angles?
180 degrees.
Right. Cool. And well, we had found out this was what?
150.
Everybody with me, right? People that was there with me from the start. Everybody with me, right? Nobody confused?
Yes.
sir.
All right. Now in this question, they want us to determine the bearing of town A from where?
Town C.
Right. So stay with me, guys. Please stay with me. From where? From where? From where?
C.
Right. So I'm gonna take my pencil and I'm gonna put it by which point?
Point C.
Right. And I want to go to?
Point A.
A.
Right. So I'm gonna start from the northland and I'm gonna measure in our direction.
Clockwise direction.
Right. So that's the bearing we want to figure out. Are you with me, right? That part makes sense?
Yes, sir.
It makes sense. It makes sense.
Because I want to go from A to C. So yeah, you know, I had to go until I hit the line connecting A to C. Good
Yeah, it
notes.
does ever go anti-clockwise.
No. I addressed it now one time. It could never go anti-clockwise. The bearing itself is always in a clockwise direction with respect to the what?
Northland.
Northland.
Right.
Yes,
Good.
sir.
So here this, this question is a bit tricky and it requires some higher level thinking. Remind me, what is the sum of angles about our point?
360.
360. Somebody saying 365. That is the amount of days in a year, not the
It's not a
angles.
circle. That's the months of the year.
Not the months, the days.
Uh-huh. Sorry.
Renisha, you are easy boy. You gonna answer that 365 months. But
Sorry, so the allergies.
what
Sorry.
kind of allergies is that? What kind of allergies is that, boy?
I'm allergic to dust specks, okay? Dust.
Hey.
Oh my days, you
All
have
right.
that.
Well, let me continue. Let me continue. So the summer angles about our point is what?
360.
360.
Good. 360. Wouldn't it help if I knew what this portion was?
Yes, sir.
Yes, sir.
If I knew what that portion was, how would I find for the bearing?
You subtract it.
Yeah, well, that's how we use cubes. That's not how we angle from 360.
Correct. So here what? That's our mission currently, right? We need to figure out as a team what this angle is. That's what we need to figure out. So that angle could be broken up into two angles, right? This angle and this angle. Are you confused or do you understand?
Understand.
Understand.
Right. Again, are you seeing the knot line here? Are you seeing the line here? And you're seeing another knot line. What rule to use here?
You can
You have to take
subtract
it away
the
from 180.
180.
Right, because co-interior angles add up to
180.
correct. And so if this is 130 over here, what do you guys suspect this would be?
50 degrees.
50 degrees.
Everybody understand that, right?
Yes, sir.
Yes, sir.
Right. So this is 50 degrees. How I know that? How I know that? Again, because co-interior angles add up to
180.
right. And this angle over here. Wait, you wouldn't say 050, yeah? Let me ask you that question. Is this a bearing?
No, it's just an
No,
angle.
sir.
No. People on the TikTok, people on the YouTube. Oh yeah, this is not a bearing, you know. That is not a bearing. That's just an angle. Remember, bearings are taken in a clockwise direction. So it's only for bearings, you'll put a 0 in front. Okay?
Okay,
So it's
so
180
I have a question to ask.
Yeah.
How you gonna know the difference between the bearing and the degree itself?
Let me ask you a question, right? A bearing is measured in what direction?
What?
No,
Clockwise. Clockwise.
clockwise.
Clockwise. Right.
So if it do go clockwise, is that angle or a bearing?
Angle?
Yes.
Yes,
Because
my judgment was correct. Okay, so
because
thank you.
good. So we already figured out that this is 50, right? Now we need to figure out the angle that is inside the triangle. Now, Alia, ain't I just show you how to do them kind of thing? Yeah. Remind me, what was the length for this side?
I think like 15. Yeah, 15 kilometers.
Right.
50.
So it's 15 kilometers. And what was this length?
19.
19. 19.
19 kilometers. Okay. And well, in the last part, what did we find A to C was?
24.6.
24.6. Yeah, I remember that vividly.
I want to stress something earlier. In the first part, they make we use cosine rule. And I tell earlier, they ask you for cosine rule first, then sine rule. If you don't have your angle here, will you have a pair? I mean, when I say an angle, if you don't have your length here, will you have a pair?
No, sir.
No. So that's the logic, right? In the last question, we found out this was 24.6, making this angle and this length are what?
Pair.
A pair.
A pair. And when you have a pair, you could use
The sine
rule.
right. That's what we're talking about. You see, everything is like a journey we're going on, you know, and everything connected. Right. I'm real proud of you, boy. Wow. Okay. Look up for yourself, guys. And so let me make a simpler. Actually, I'm not gonna make it simple. Let me just continue. So here what, right? We recognize that to find for this angle, we have to use the what?
sine rule.
And what's this length again?
24.6.
24.6.
Good. Let's label our triangles, right? Our triangle. If this is angle B, what is this?
A common B. With a
Common
side.
B, right? If this is, well, this will be angle A, right? If this is angle A, what will we call this?
Common A.
Question. If this is angle C, what would I call this side?
Common C.
Good. Common C. Good, good, good. Nice. So what would sine rule look like for this question?
B over sine B
B over sine B.
is equal to C over sine C.
Okay, tell me the answer one time. Nah, already full thing, right? So people could see why I selected. So
A
if I
over sine A equals B over sine B equals C over sine C.
good, good, good. Now, how do we know which two to select? Again, we looking for a what?
A pair.
Yeah.
Right. Right. See, so guys, so don't we have angle B?
Yes, sir.
And don't we have length B?
Yes, sir.
So I'm going to select B over sine B. Next question. What are we trying to find? To find the bearing, we realize that you had to find this big chunk here and take it away from 360. We already know this is 50, but we need to find the angle in the inside. What angle that would correspond to?
C.
Angle
That,
C.
that, right. This would correspond to angle C. I hope I could see that. I just probably see rather there.
Yes,
Yeah.
sir. We saw what you.
We see it.
That's great. That's great. Low key funny, low key funny. Low key, low key. So this is why I'm going to select C over sine C. Right? So a lot of people asking questions that was answered in the earlier parts of the live. I can't help you much, right? I try to be in depth, but that's covered in the past. We explain that real in depth. Just go back. So B over sine B is equal to C over sine C. Guys, so I'm going to use B over sine B is equal to C over sine C. I use B because we had a pair of information for B, and I use C because you're trying to find for angle C, yeah? So tell me, guys, what is common B? What is common B, guys?
24.6 kilometers.
It wasn't that the answer from the last question?
Yes, sir.
Yes, sir.
Yeah. So you see everything was related, right? Angle B is what? What's angle B?
92 degrees.
And C, do we know what length C is?
Yes, sir. 15 kilometers.
All right. And do we know what angle C is?
No, sir.
If you're confused, right? Look. Length B is 24.6. Right? Are you hearing me?
Yes, sir. Sorry.
Right. Angle B is 92. So I replace that with 92. Length C is 15. I replace that with 15. Do I know what angle C is?
No, sir.
No, so I'll leave it blank. We know how to tackle thing like this. Next part, you're going to cross multiply because we hate working with fractions. It's ugly. Yuck. Right? So we're going to cross multiply. If I cross multiply, what's going to happen?
It will become sine. C.
Wait, remember you put the number in front and you put sign after. So you'll say 24.6
Sine.
24.6 sine C. So we just multiply the 24.6 by the sine C. 24.6 sine C. What are we going to multiply next?
15 by
Sine 90 degrees.
People will say it I remember when it only had numbers and maths. It always had letters and maths, It always. So that's a real stupid thing to say. Yeah. Like I could show you a simple thing, if I buy 5 chocolates and it costs $10, end up our letter there because it represents the chocolates?
Yes, sir.
Yes. So it always had letters and maths. Okay, letters and maths is just me converting what I'm saying into a mathematical way. It always had letters and maths earlier. Always. It just representing a problem in real life that we're trying to solve on paper. Right, so we have 24.6 sine C is equal to 15 sine 92. All you want to plug the whole thing in a calculator, or you want to plug this into a calculator first? What do you want to do?
We could plug
We had
in.
a cross multiply. We had a cross multiply. Divide. Cosine.
Here, what we go plug it into our calculator last minute, right? So I have 24.6 by sine C, but I am trying to isolate the sine term. So what I need to do?
You have to divide it by 24.6 both sides.
Right, because I'm trying to isolate the sine term. And when I divide by 24.6 on both sides, you know what's gonna happen? It's gonna cancel off. Let's see that. And so sine C is going to be this over here. Plug into your calculator fast. I'm gonna know again.
So I got
0.4671.
938,465.
I'm gonna confirm that. Yeah, so I get you can just write 6, right? 6 decimal places. So 0.609384. That's fine. And so C will be what? What I apply here?
Sine inverse.
Sine inverse.
Alright, plug into your calculator and let me know what we get, guys.
37.544975447.
Right. Remember, one decimal place is for angles, right? So one decimal place for angles. So that'll be 37.1.
0.5.
Right, 67.5 degrees. But when we write in, okay, never mind. You know how to remember this is not bearing, right? This is our angle. So 37.5 degrees. So in other words, this angle over here is what?
37.5 degrees.
Everybody understand that, right?
Yes, sir.
So question. So what did I just find? I just found for angle C. Why is this important to us? Well, we know angle C is over here, and we know that this is 50. And we are trying to find this piece over here. So what do you do, guys?
Add that and
Subtract it from 360.
That is it. So I will say 360 degrees minus open bracket.
The 50 plus the 37.5.
Right. We're going to get there, bro.
272.5.
You're all getting 272.5, right?
Yes.
Yes.
Yes, sir.
I mean, this is literally what CXC said, right? If you have an angle, you're on the north, sir.
1 dp.
1 decimal place.
Right. That's what CXC is saying. So we do that. Yeah, so this is
So
the answer.
then you could
What's that?
kind of work how you get back the 50 at the top.
No problem. But let me ask you this, right? Co-interior angles add up to what?
180.
Right, 180. So you had 130 over here, right? You had 130 over here,
Okay,
right?
okay. Yeah, just take 180 and you subtract the 130 and you get the 50. Okay.
Yep. So is everybody okay with the question?
Yes, sir.
So we essentially done with bearings. If all the ones I could do one more question and that'll be it for bearings. All they want to do. One more question or?
One more question to look at it. One more question.
All right, what, give me a year, guys. Give me a year. Give me a year.
2018.
2022.
Here, well, I'm gonna find the average of that to like be like fair. 2020. But 2020 didn't have a June. I write in 2020. I real young, you know. I write maths in 2020. Yeah, we didn't have a paper 2 then. We didn't have paper 1.
Oh, wow.
Yeah. I have a question. When do you think I write maths? When do you think I have write maths?
2019.
Maybe 2021.
Yeah.
So I have a question.
2021.
How old are you?
I am 22. I am 22.
Oh
Yeah.
my God, 2019.
I was right.
Oh, well, so
I believe it's 22.
Yeah, I real young, guys. I real young.
So wait nah. I older than you, boy.
Yeah. Yeah,
I'm my
boy.
early 30s, dog.
Way, boy. Yeah, boy.
So which means when you do C-Sec, I was in Form 1.
Apparently, yeah.
Yeah.
All right. So let me do 2020. Do I have 2020, John? Yeah, I have January 2020. Let me see if I have a question here. Last question to lock it in. Okay, had a question. Nice. Are you ready? Are you excited? Are you excited to use what you learn?
Yes, sir.
Lessons. Let me run it. Let me run it. The diagram below, not let's see that not drawn to scale. So here they say, if they say not drawn to scale, are you going to take a protractor and paste on the paper and measure thing?
No, sir.
No.
Oh, you're not going to do that, sir. Don't do that, sir. It shows the route of a ship cruising from Palm City. You see that word from? That's very important. So it would have start from where? From where? From where?
From P.
Right. And they're saying from Palm City to Quayton. So from P, it's gonna go to where?
Q.
Right, it's gonna go to Q. And I'm bearing on what, guys?
133.
Right. Right. And then they're saying then to where?
Riverton. Then to R. Well, Riverton.
Oh, you understand what happening, right?
Yes.
Right. Start from P, went to Q, then from Q went to R. This one like vectors, you know, dog. This one like vectors. Yeah, boy.
Say that, sir. I was not gonna say that.
Because like in vectors, they might say that this is U, they might say that this is V, right? They might say P to Q is U, and they might say Q to R is V. And if that is the case, then P to R. How we went from P to R? Well, we went U and we went V. So P R B U plus V. Vectors. Right? But anyways, the bearing of Q from P, where? Say that again? The bearing of?
From
133.
Q. From P, sir. From Q.
Right. So like, all you understand now, right?
Yeah.
Yes, sir. Right. And the angle PQR is?
56.
Oh, let's see in that, right? PQR is 56.
Yep. Yes,
Right. So they always calculate the value of angle W. Oh, yeah, this is, nah, boy. Real easy, boy. Real easy thing, boy. Not real easy. Real easy, boy. Angle W. Somebody tell me fast what we have to do.
Find
We
the
need to
value.
find the angle on the straight line.
Yeah.
So what angle I should find here first?
We could find the one
The
on
interior angle, so you have to see
Interior angle.
Yeah. So if we know co-interior angle that up to 180, right, guys? Then how I find for the angle there?
180.
180. So we are 133.
133.
And what you get?
47.
47.
Is that a bearing or is that just an angle?
It's an
Angle.
Yeah. So we can leave it as 47, right? So here the thing, right? We have 47 here and we have 56 here. How are we gonna find for angle W?
Yeah.
Yeah,
You're on a
add
straight line. Add
Subtracting
56
from
and 47.
47 and
Take it away
56.
from 180.
Take away
Wait, boy.
Yeah.
Always like the voices in my head when I'm trying to sleep, boy. Wait. Oh, you know that Rihanna song with Rihanna and Eminem?
Yeah.
Yeah.
Yeah,
I'm
boy.
friends with the
Thing that come to my
monsters
head
inside
when
of
you
my
say
head.
first thing that come to my head when you say voices on a room. First
I'm
song that
friends
come
with
to
the
my head.
voices inside of my head.
That is
Crazy.
77, by the way.
Yeah. They need
Yeah.
to bring a question like this for CSEC.
Yeah, just like this.
Right? So that'll be 133 degrees, right? Are they okay? Are they okay with that?
Yep.
Yeah.
No.
So that's how they get to the tree up there. Oh, okay.
Wait. One. We make a mistake. We make a
Yes,
mistake.
so you're
We make
supposed
a
to add
mistake.
the
Why
47.
Yeah.
I want to know.
Yeah,
That's
boy.
how
Sorry about that.
I
Yeah,
got
boy.
77.
Right. Because I was looking at it, right? And watch this, right? This whole thing will be 133. And so if you want to find for W, you could say 133 minus 56. And you get the same answer. Just check that for me fast. 133 minus 56.
77.
Yes, sir.
Yeah, so when I look at the answer and I see it's 133, I was like, nah, that can't be correct. Because this whole thing will be 133. You know what I mean? Sorry about that. We get lost with the voices in our head.
You get lost in the sauce.
Yeah, I get lost in the sauce.
sauce.
Yeah,
The
boy.
garlic sauce. And the garlic sauce.
Yeah, so
Alright,
all you
right.
understand that W is 77 degrees, right?
Yes.
Yes, sir.
Let me run it back one more time. And let's look at the alternative way to work it. We have the north line here and the north line here. These lines are what?
Parallel to each other.
Parallel to each other.
What do you call that line? Traversal. This is traversal, right?
Transversal line.
This is the traversal. So here
Oh.
I was saying, right? if this is 1 to the 3 here, what do you think this could be?
133.
So
Oh,
this,
it's from minus it.
122.
Hey, you
yeah,
right.
yeah, and this could also be 1 to the 3 minus 56, which is
77.
77.
right,
Okay, you smart.
Agnes
right?
says 77 and not 67. Amen.
Renisha, you have to say that, eh? Renisha and she's 6'7".
It's not my fault.
Careful.
So,
Anybody
before
say
we
that, go get
continue,
locked up.
charge your iPad.
Yeah,
Your
I
phone, your thing on 20%.
Plug in.
why it not charging? I have it hooked up to my laptop. Okay, charging now. That's the good thing.
Okay.
When I give a lady break, I need to charge my Apple Pencil because my Apple Pencil about to die. My Apple Pencil
So
can't
for
keep
the
up with me.
second one.
Nah, the second
So
one's
when the
tripping.
break is?
Okay.
Everybody
So
okay with
your
this
thing
first question,
always
right?
die and so on you.
Yes.
Because I am built different, but the
So,
equipment is built the same. But I'm
but you
different.
know, Samsung S Pens do die.
I
Just
know.
saying.
Okay,
Just
here's the thing.
saying.
I want a Samsung tablet, but you see good notes on the Samsung tablet real bad. Like it bad.
Okay, so Samsung, I see Samsung.
For
Okay.
real.
Because I will tell you something,
I
I don't
tried.
like Apple. I don't like Apple. The only Apple product I like is the MacBook Pro. Are real good. But you see iPhones and iPads and thing, I really like iPhone and iPad. I
So I
have two
shouldn't waste
Android
my
phones.
money. So I shouldn't waste my money to buy iPad. I should buy a Samsung tablet instead.
Yes, you should,
All
you
right.
should.
Yes, I have one. You should get it. It's the best thing ever.
Yeah. If only so much notes, I have like thousands of notes in good notes. So like that's why I kind of locked in here. But anyways, let me continue, right? Only 2 marks for that? Nah, boy, that easy 2 marks, boy. Let me move on. They want us to determine the bearing of P from Q. So I had the diagram here. What was the information I had found for quickly? What was W?
W was 77.
Here it said, as soon as you find information, put it in your diagram for me, please. And what was this angle over here again?
That was
That wasn't 50.
no
47.
No, what?
47.
Right, 47. Let me see if we can answer the question now. It's a 1 mark question, real straightforward. The bearing of P from where? P from where? P from where?
Q.
So start from Q to P.
Q.
Right, start from Q and we go into?
P.
P.
Right, so that'll be this whole thing over here earlier. Let me run it back again. I feel like I confused some people, right? Here what? The first thing I advise you all to do, we want to go from Q to where? Q to where?
To P.
Q to P. So
Right.
I have point Q here and I have point P here. So I need to connect it. Right?
Right.
Right. And so my bearing will start from the north line at Q and it will go until it hit that line connecting the two of them.
Oh, okay.
Ah.
Run it back again. So we want to go from Q to
P.
right. So I need to connect Q to
P.
and when we measure in bearings is an anti. Renisha, you get some of it. You get some. Bearings is measured in what direction, guys?
Clockwise.
Right. So we starting from the
Somebody
north.
was saying I do something wrong.
No. You know how you mix up clockwise and anti-clockwise? I do the
Yeah.
same. I pull out Renisha.
Oh. Okay.
When you pair up in a console, boy, that's not legal.
All right. But let me continue, right? Let me continue. So, guys, this whole thing add up to what?
360.
360.
So,
circle.
Olio, what is this angle over here, boy?
180.
180.
So if this is 180 over here, right? This is 180. What would this
Yeah.
piece be?
Not too
77 plus 56.
That is
Which
all.
is 1
That
to
is
the three.
Couldn't you just minus 360 from 47?
yes. Perfect. Big up for yourself, boy. I love any vibes, boy. Big up on yourself, boy. Well, bad.
I've been yawning so much.
Yeah, but
Trust me, it is contagious, sweetie.
yeah. But one way to work it, you could just say 360 minus open brackets 180 plus 56 plus 77, and where you get?
313.
13.
You get 13, right? And you gotta say again. Wait up. No, if you're doing it like this, you don't have a minus 360, boy. Yeah, what
Yeah,
again?
I'm so confused.
What again? 313, right?
Right.
Yes,
So
Yeah.
Yes, sir.
the thing you have
And
to minus from 360 is 47 if you're doing it
yeah.
that.
Yeah. Because I'm explaining our method, right? If this is 47 earlier, and this whole thing is 360, and you want to find for the other piece, what you gotta do, guys?
Minus it.
Right. So this is one way you could work it, or you could just say 360 minus,
47.
and you get
47,
330.
and you'll get 313.
Right. So let me run it back one more time for anybody that might have been confused by my madness. So, number one, we want to find the bearing of P from,
Q.
right. So you connect P to Q, right? So we're going in a clockwise direction until I hit the line connecting P to Q. That's what we need to find, right? Like somebody said, only if this is 47, right? And the whole thing is 360, what do I do, guys?
Subtract 47 from it.
And you'll get 313. That was one way to think about it. Another way to think about it, right? This over here is how much degrees?
180.
This over here is how much degrees?
77 degrees.
And this over here is how much degrees?
56 degrees.
So all you had to do is just add everything and you get the same answer. Badness. Right? You good?
Yes, sir.
Right.
Oh, so it doesn't matter whether you subtract or you add, it's still getting back the same answer.
Whoa, I had to correct you there. Like it depends on which way you're looking at it. So Renisha, can you see that this is 360?
Yes.
This is 47, right? If you know that it's
Yeah.
47, then to find the remaining part, and you just say 47 from 360 to find the remaining part.
Yes.
That is one way you could do it. The other way, add up all the consecutive angles. So 180, 77, 56.
Yeah.
Right.
And you'll
All
get
right. Okay.
313.
Right. So they want us to find the distance R to P. Ollie, what do you think we might have to use? Ollie, look at it carefully. You know, we want to find R to
Like
P.
use the cosine rule.
Yes. Where's the included
cosine.
angle? Where is the included angle, guys? Where's the included angle?
56.
56.
Right.
Number
Let's
two.
see. Everything we learn coming in clutch. So, question: if this is angle P, what is going to be?
Length.
Common P.
If this is angle Q, what is going to be?
Baby Q.
If this is
And the
angle R,
last
what is
part
going to
is
be?
baby R.
Common R.
Right. So here what? Remember. Okay, we're trying to find for RP, right? And RP just so happens to be the side opposite the what?
Hypotenuse.
No, the included angle.
Oh, sorry, I get too glad. I get too glad. Sorry, sis. I get too glad.
Renisha just cracked me up earlier. Right. So somebody cosine rule for this. What the cosine rule look like?
Q squared.
Q squared plus Q squared
Plus
plus
P
C
squared.
squared
plus P
minus
squared
2B2 cos
squared.
A.
Cosine Q.
Bam. Right.
Yeah.
Cool. We know that P is 290, so I say 290 squared. I know that R is what? Where's R?
210.
Right, so I'll say
110 squared.
Right. And we're gonna say P by R. Where's P?
290.
And R is?
210.
And cosine the included angle. Where's the included angle?
56 degrees.
56.
Plug that into your calculator and let me know what all I get in for Q squared. It'll be a big number, yeah? Very big number.
$60,090.30.
Although, how I write this thing so stupid, buddy? This is 56. Although, hey, buddy. Yeah, I'll again 60090.30436.
Yes.
Yes, sir.
Right. So that is what Q squared is, you know. That is Q squared. Are we trying to find for Q? How to do?
Square roots.
Add a square root. Right. Add a square root. And so Q would just be the square root of that. So when you plug that into your calculator, you should get 245. The full answer is 245.133238. Well, let me ask you a question. Like CXC asking you, they say if you have a numerical answer, they want it to how much decimal places? I mean, not decimal, wait, three, no. You were saying, right?
Three significant. Three
Right.
six.
What? Go back to the instructions. CXC says, if you have a numerical answer, it should be
3 significant figures.
Three
right.
significant figures.
What is the first significant figure here, guys? What's the first significant figure?
2.
2. Second one is?
4.
4.
Third one is?
5.
5.
Number after 5 is?
1.
1.
So that would just be what?
245.
245.
And you could
PM.
you could say 2 3 SF. Right? that's KM and not CM. Yeah. I see Marisha Rishihan. Yeah, Marisha.
Sir, I have a question.
Talk to me.
Okay. I'm wondering why you use cosine because what I was taught is that when you use the sine rule is when you have an angle between two lengths, and when you use the cosine is when you have all lengths and not an angle.
Nah, I don't know where you're doing that. It's the opposite actually. Yeah, you use the cosine rule anytime you have an included angle. So you see how we had the 56 in between 210 and 290?
Yes.
Yeah. Anytime an angle is sandwiched between two
Between
known
two.
lengths is an
Yeah.
included angle, and you have to use cosine.
Okay, I must have confused it then.
Yeah.
Okay, thank you.
Excuse me, sir.
Yeah, talk to me.
Oh, I was wondering, when do I have to do the inverse part? Because I kind of
Any
confused on that.
anytime you have to find an angle. Anytime you have to find an Yeah, watch.
Okay, no problem.
Watch, like, let me just say I had cos theta is equal to 0.9. How I find an angle? I would find the inverse function for cosine. So cosine inverse 0.9, and I'll get my answer. So you use the inverse trig functions anytime you have to find for what?
Angle?
Yes. So if you have to find out an angle, chances are you had to use sine inverse, cos inverse, or tan inverse. Yeah. Understand?
All right, no problem. Thank you. Yeah.
No problem. Good. So Olio, how you feeling about bearings, boy? How you feeling about bearings?
Boss.
Real good.
Nice.
Very good.
Move on, sir. Right, so move on.
Nice, man. So I'll give a little break. Let my Apple Pencil charge, right? And we're gonna be inside after. We're gonna be looking at vectors. Vectors, guys. Vectors. Right.
How long is the break, sir?
How long will it one the break to me?
30 minutes.
30 minutes. 30 minutes.
No break. No
I said
break.
30.
Fight till we start fight. No
15.
break. No
Do
break.
you know we have 30 minutes? 30.
No break.
30
No break.
minutes.
No
Let me
break,
ask
sir.
people on YouTube and TikTok to YouTube and TikTok. Well, how long the break should be? Some men saying 30 minutes, some men saying 10 minutes.
30
I
minutes too
say no
long,
break,
sir.
sir. I say no break.
15.
30 minutes too long. We go lose
Hear what?
momentum, sir.
15 minutes.
Hear what? You know what we're gonna do? We're gonna find the mean between 30 and 15. No, 30 and 10, because you were saying 30 and 10, right?
Come on, now, do that.
How you gonna find
Oh.
the mean between 30 and 10?
Add them and divide by 2.
Right.
Add
20
that
minutes, sir.
and divide by 2.
20 minutes. 20 minutes, right? Right.
Yeah.
20 minutes break. Back in the middle.
All right.
Yeah. Yeah, guys. Pick up all your whole self, boy. All your master bearings in one night. Don't know.
Yeah.
Sanders used to give me real trouble, and right now I'm literally getting it.
Yeah,
Plus
me too.
bearing.
Wait, sir,
Right.
how long is the break is again?
20 minutes.
So, and
You know
just for my assignment, I was not out. I'll see you tomorrow.
Yeah,
Bye-bye.
me too. too.
Ollie, I don't check the time. It's 11 o'clock. That's crazy, though.
So imagine I literally had to sleep out of it just to stay up tonight and understand these lyrics.
Try again?
I had to sleep whole day just to stay up tonight to understand all this stuff because I doesn't can't stay up in the night.
But you understand it?
Yeah.
As you think I want to hear. Nice. Big up. Right. Are we going to do vectors after this?
So somebody say in the chat the 30-minute man get robbed and the 10-minute man had to wait.
That is equilibrium.
Okay.
Do you understand what I mean? Both of them will be equally disgruntled. Both of them will be equally disgruntled, so they wouldn't have no fight. They wouldn't fight amongst themselves.
That is legal.
Somebody say I leave. Yeah,
That's
what?
what I said.
I feel like we should just do vectors, because tomorrow I go in whole day, whole night. So I just do vectors and I call it a night.
What time is starting tomorrow?
So what time you starting tomorrow?
Yeah.
Yes, so what time you starting?
Only I feel this at 4 o'clock,
4
Well,
o'clock.
I got too late.
And what time you ending?
That's too late, start earlier.
We
Yeah,
still
what's
gotta
that?
get rest before the actual.
So you
Body.
don't want me sleep?
Yeah, what's that?
No.
I going to be in a Zoom meeting until the okay, here what's that? I gonna be in a Zoom meeting till all they ready to write the exam, right? Answering any questions that they have. So like anybody could pop in at any point in time as like ChatGPT or as like this is Rajiv ChatGPT, like I just come in the Zoom, ask me any question and answer it at any point in time for the whole of tomorrow.
Oh, I was okay. Okay, sir.
So all they could just pop in at any point in time. I'm gonna be there right down till the exam. Whole night, whole day.
So you're not gonna get a rest something?
Yes, sir. You're not gonna take a sleep.
Me, I
I'm
know.
sure that must be
Well,
tiring.
you're genuinely forgetting we working at the end. But forget
Not bad, man.
It's just
This is not the man that do 24 hours of math straight.
Oh yeah, I'm a mad man.
That's okay, trust.
We could see
That's
that.
okay.
So
Yeah,
now
what
you
that?
me, right?
Yeah, what? Oh, somebody asking, is it that for everybody? Yeah, I'm gonna be on Zoom, I'm gonna be on YouTube, I'm gonna be on TikTok. Come and ask the questions. Yeah.
You wanna go back on the topic, sir?
So good.
Are you going to go back on the topics so that we'll be well prepared for when we go in the exam and understand what we're gonna do?
I'm not sure what you're saying.
Are you gonna go back all the topics so that when we go in the exam we're gonna be well prepared and understand what we have to do?
All I hear was, are you going to go over these topics?
Are you going to go
What I mean,
go over all the topics? I think that's
Hey,
what you said.
I just gonna do whatever they ask. Like whatever time, whatever they wanna do, I just gonna do that. Yeah, whatever. I can't tell you we're gonna do all the topics in the whole syllabus, but whichever topics I need help with, I'm gonna be there helping you.
sir, would you be
So
able to
that's
do like
crazy.
constructing angles?
Oh, that's my
Oh
upset.
yeah, that.
That's my upset because like, oh yeah, it kind of hard to show them thing virtually. But let me try something. Let me try 1 second. Let me teach you a little construction. Let me see how that will work out. Let me see how that will work out. It's be kind of hard to show that virtually. Let me try that thing, right? All right. Well, you know what's a bisector line?
Yes, sir.
Yes, sir.
Bisect just means to what?
Cut the line in half.
Fundamental subtraction.
All right, cut the line in half, right?
I means 2 and sector is the whole thing. Boo!
Wait, where is it?
I was just explaining what bisector means.
Oh yeah, yeah, cut in half. And perpendicular means what? What does perpendicular bisector mean? Tell me
Isn't that
perpendicular.
when I cut it at 90 degrees angle?
Yes,
And
sir.
it passes through the midpoint. So here what? I'm going to show you how to find the perpendicular bisector fast. Real easy. So all you understand that if I were to cut this line in half, that would be at what mark?
3 centimeters.
3, right? 3. Yeah. And
3 centimeters.
perpendicular means 90 degrees too, right? Like that. Wait, like this. I hate this app. It's cooler, but it's frustrating at the same time. Yeah, 90. Yeah?
Excuse sir.
Yeah?
So I now come back. What we doing here?
I just doing a little bit of constructions for them.
Hmm.
Yeah, I'm just taking a little detour. Any break. Yeah, so guys, if you want to do the perpendicular bisector, you need to open up your compass to at least more than half the line. If you don't, the arcs are not going to intersect. Are you hear what I'm saying?
Yes,
So
sir.
like, we know half of 6 is 3, right? So you go a little more than 3, right?
Yeah.
And I'm going to place a sharp point on my compass at one end, and I'm going to draw. Going to draw arc, right? Then I'm going to place the sharp end on the other side of my line, and I'm going to repeat the same process. Bam. And so is it hard for me to find the intersection now?
No, sir.
Nah. So let's see the intersection, guys. Ready? I'm going to let's see it now.
Yes, sir.
Right, that was it.
Yes, sir.
Yes, sir.
And when
Sir, my thing was glitching. For the second one, did you start it by the first point? The
wait, yeah.
second line you just drew.
So you're drawing an arc from the first point and the last and the end. You're drawing it from the start point and the end point. That's what you're doing. That's the thing, yeah. When you're teaching this topic, all you can't afford to have Wi-Fi problems or anything. Like it can't stick. Because like all you had to see it happening in real life. Because I gotta do back the whole like okay, let me show you fast. I'll try to do it fast.
Thank you
But
so much.
watch it, eh?
Yeah.
The first thing you gotta do, you gotta take your compass. You're gonna place it at the end, at the start point, right? At the start point of your line segment. This line is how much centimeters?
6 centimeters.
This line is 6 centimeters, right?
Yeah.
What is half of 6 centimeters?
3.
Wait, eh? This up real buggy, buddy. Yeah, 3, right? So if you want and wash man, wait, eh? Give me a second, right? If you want to create an arc and you want it to intersect, you need to open out your compass to at least more than half the length of the line you're dealing with. So half of 6 is 3, right? So you need to open it to more than half that. So like 4 could work, right? You understand?
Yeah. Yeah.
Right, so you're gonna draw an arc now.
Excuse sir.
Wait, let me finish. And then you're gonna take your compass and you're gonna place it at the other end. And you're gonna repeat the same process, right?
Oh, okay.
And you see where the two arcs intersect?
Yep. In
You're
between.
gonna draw a line through that. And that's your perpendicular bisector.
Okay, no problem. Thank you. I understand.
Yeah, somebody was asking something.
So say for instance if I use 5, it would be the same?
If I use 5?
Yeah.
Well, it's the same concept, you know. You're gonna take your compass, you're gonna put the sharp point at the start point, and you're gonna open your compass a little more than half the length of the line and draw your arc. It needs to be more than half the length of the line, right? Otherwise the arc's not gonna intersect. So whatever line you have, right? You're gonna take your compass, put it at one point, open it more than half the length of the line, and you draw your arc. Do the same thing for the other end, and you go intersect, and you draw your line coming down. That's your perpendicular bisector.
Is there any other angles we have to know?
Yeah, all you had to know a good bit, you know.
Like
bits.
16, 90, and I think 30, right?
Yeah.
Around 120, I believe.
Yeah. Like, watch. Let me try to construct 120, right? 120 real easy. All right. So here we're going to do, right? It doesn't really matter the length at which you open your compass to, right? It's fine. It really don't matter. Promise it don't matter. So here we're going to do, right? Let me just say, I do it at 3, right? It's not a problem. I'm gonna draw my arc. Are you with me?
Yes, sir.
Yes, sir.
It don't really matter the length at which you open the radius to. It's fine. But hear what? Hear what? Once you have that arc, you're gonna take your compass and you're gonna place it at the point where your arc intersected the line segment. And you're gonna keep the same length on your compass. You're not going to change the length. You're gonna keep the same length. And what you're gonna do now, you're gonna draw another arc. Well, you see that?
Yes, sir.
Yes, sir.
If you
You see where
change the
the
length,
you
that's
see where the
illegal.
you can't change the length. So all you see how the two arcs intersect there, right? That is 60
Yes,
degrees.
sir.
We just created 60 degrees. That is 60 degrees already. That is 60 degrees. That's how you create 60 degrees. And I want to show this one real bad, real bad. 120 degrees is just how much 60 degree segments? Hear what I'm saying, right? 120 is just how much times 60?
2.
So I'll watch badness, eh? I'll understand how we create the 60, right? If I wanted to create 120, all I gonna do, right? All I gonna do, watch badness. So I add in another 60 degree angle. And so this angle over here is what?
120.
Yep, that's 120.
It's
Yep.
a question, just not for you to redo it, because I can understand while watching. I just want to make sure again. 360 degrees is I think it's at 3 centimeters, and you just put them. You ask at two varying points, right? So the first one was at the start, you get 3 centimeters, you get the first arc. Then all these second steps.
It really matter, you know.
After that.
It does not matter what length you open it out to. We don't care.
Okay.
It's fine. Like it literally, you can open it to any length, right? We don't care. We don't care about that part. But the point is, after you draw your arc, you need to maintain that same distance between the 2 points. So watch.
Okay.
Right, watch this, right? So I had opened it to 3, right?
Yes, sir.
I could open it to 1, 2, 3, 4, 5. I don't care. I could open it to any amount. The point is where it cuts the lines. You see how it cuts in the line at 3?
Yes, sir.
You're gonna take your compass and place it at that point at intersection, right?
Okay.
Then you're gonna keep the same distance and you're gonna draw another arc. Like so.
Okay.
You see how it cut the other arc there?
Yes, sir.
Right. That's gonna form 60 degrees.
Understood, sir. Same thing from that point to get the 120.
Right, because 120 is just 2 times 60. You understand?
Understood, sir. Yeah, thank you. Thank
No
you very
problem.
much.
So that was a little crash course on construction. Obviously, I had to learn more, but I showed you how to do a perpendicular bisector, how to do 60, how to do 120. Right? So that was a little crash course there.
So what about 190?
Thank you,
90.
sir.
About what?
90. 90 degrees.
Alright, 90. 90 is the same process for the perpendicular bisector. Watch. Okay, I'll just show you an example, right, real fast. Watch. Work now, boy. This thing is real frustrating me, you know. This app. It's getting my nerves. I like how we doing more maths during my break, boy.
Yeah.
We dedicated to the course, but we're real dedicated.
Because maths is fun.
Maths is fun. Right, so I put the 10 over there, right? I put the 10 over there. Gosh, man. I want to move this thing. Right, It's real buggy. Right. So here we're going to do, right? Again, we don't really care about the length. They're gonna draw arc. They're gonna draw arc. If I could just move the thing. Right? So you're with me, right? We don't really care about the length at which we open the 2 points, right? The radius. We don't care. Yeah? You understand?
Yes, sir.
You're gonna draw your arc. You had that down, right?
Yes, sir.
Right. We're gonna do next. You're gonna maintain that same distance. You're gonna go to the point of intersection with your arc and your line segment. And you're going to cut. You're gonna draw another arc. Yeah? Like you're making a 60.
Yes, sir.
So you understand that, right?
Yes.
And now what I'm going to do is I'm gonna take my compass and I'm gonna place it by the intersection. And I'm going to it come like if I'm making a 120, right? Say with me?
Yes, sir.
Right. Cool. So them was steps you learned before. 120. So what you gonna do next? You're gonna keep the same distance. Placing this at this point of intersection. Gonna draw arc. And what do you think I'm gonna do next? I'll place it over here. What angle is that?
90 degrees.
90 degrees, bam.
Whoa.
Yeah.
Where you lose media self.
Wow.
I don't know what you just
This is something where you can't blink once, you know. Or you cannot blink once. You cannot
Oh
blink
God.
once. If you blink once, pressure in the cap, I can't help you there. You can't blink once. I'll go it over one more time. One more time, right? You think I'm patient? You think I'm a patient guy?
Yeah.
Considering what you do this
Very,
with some
very
students, yeah,
patient.
I would have given
great,
up.
That's you,
so
yeah.
patient.
I will tell you something. This is the only thing I'm patient with. Maths and teaching
Oh.
people is the
Hey,
only thing I'm
bro
patient.
person, pee and go in your bed. Stop provoking people this hour of the night.
Why
Shims,
you
man.
alright.
Oh, look, we don't care about any kind of thing. We doing maths here, right? So 0, 10, okay. Here we go, Andy, right? Again, don't blink. Don't blink. Only do not
Yes,
blink.
sir, I won't. I won't.
If you blink, you'll get lost. Yeah, so you're gonna take your compass. You really care the length you open it out to, right? It could be any length. What length do you want to open it out to?
3.
3, okay. 3. I'll use 3, right? It don't really matter. We don't really care. We don't care. So I'm going to draw arc here. Are you understand that?
Yes, sir.
No. It coming like I'm going to construct a 120. To construct a 120, this is what I'm going to do. I'm gonna take my compass, put it over here, and I'm gonna same. You're not changing anything, you know. Same distance between for the compass, same distance, right? And you're gonna draw another arc. Are you with me so far, or are you confused?
I'm with you.
Just
Right. Here what we're gonna do. We're going to go by that intersection, and we're going to draw a
next arc. The 120.
right. So are you with me so far, right?
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir.
I'm gonna use a different color so to differentiate between. So here we're gonna do now, right? You see how we have at no point in time are you going to change the distance between the pencil and the sharp point, right? No point in time. Right, we're gonna do next. Until you can see we have 2 points at intersection. We have one over here and we have one over here.
Yes, sir.
Yes, sir.
Right, you're gonna go by the first point at intersection, right? And you're going to draw arc.
Hmm.
Do you understand?
Yes, sir.
Yes, sir. I see it
Then
now.
then we're gonna go by the second point at intersection, and we're going to draw another arc. What angle is that?
90.
Oh, 90. I see it now.
90.
Right.
Well, amazing.
All right. Not bad.
There's
Thank
somebody
you.
at the hand. So
Yes,
somebody
sir.
at the hand.
It real sweet until it's not asking you to do trapezium and triangle and then madness.
Yeah.
Yeah. Well,
This is the only time when it likes.
right? Well, I want to take a 5 minutes break for me. Right? I see Marisha.
Yes, so
I'm not going
we'll
to.
get during that break time, so we will kill you.
I'm not going over construction again. Huh? I do that quickly. I'm not gonna go over it again. I'll go watch your recording. Yeah.
Thank you, sir.
Yeah. No problem.
Thank
Marisha.
you.
I just say that
Also,
Thank you, sir.
sir, quick question.
Yeah.
Okay, regarding the exam, would we be directly asked to construct these, or would it be like given questions that would suggest that we have to construct it?
You need to construct a triangle and thing. But like I really not prepared to do that right now because with this app, I
No,
need to
I'm
log
just
in.
asking.
Yeah. So like they would tell you I have a line segment AB, and they might say the line segment AB is 6 centimeters, and they might say angle ABC is 60 degrees. So yeah, draw the 60 degrees at that point. And then they might say line AC is 7 centimeters. So when you construct your angle, you measure 7 centimeters, and then you connect it like in a hard. It's something hard in a hard, right? Here
Yeah,
what
I get what you're
here,
saying.
here what I go do. Tomorrow I will try to have construction questions on this. But the problem is like when I had to insert a picture into this, had to be like below a couple kilobytes or something, and it's get trouble. Yeah. I
Okay, so
see.
and one more thing, right?
Yeah.
Do they like always bring this?
Hmm. You guys always bring this?
Do they like always bring? Yeah.
No, they didn't bring it in 2026 January.
Okay. Thank you.
That's what we prioritize. It's a noise. Even if it comes, it's not a lot of marks to losing. You know what I mean? So I don't prioritize it. I don't think it come in January 2025. I mean June 2025. Did it come in June 2025? No, it did
It
not.
did, sir.
Oh,
It did?
it did?
Yeah, I
Oh,
remember
yeah,
doing
it did.
It did.
It did. I can't
Yeah,
remember
buddy.
which question it was, but it did come.
They I tell you to draw a triangle. Something so.
Oh, okay, right here. Let me show you what we gotta do, right? I'm gonna do a quick run through. So they're telling you, construct a triangle PQR such that PQ is 9. Here we're gonna do, right? The first thing I would do, PQR. So like, wait a hey, you see how they tell you PQ is 9 centimeters?
Yeah.
I go and use that as the base. Why not? So my triangle could look a little something like this. So if my base is PQ, what the top could be?
R.
R, right? So I need to open up. I need to draw a line segment here as how much centimeters?
9 centimeters.
Good, 9 centimeters. And then they say an angle QPR is 60. What angle are you talking about?
Angle P.
Right, so here what you want to do. All you're going to do, right, you're going to open, you're going to take your protract, as always mix it up. You're going to take your compass, right? And you're going to open it out some random length. And what you're going to do is you're going to draw an arc. You understand? You're going to draw an arc. You can draw an arc. You with me?
Yes,
And then you're going to
sir.
draw another arc over here. And that would create one angle over here.
60.
60 degrees.
60.
Okay.
And this is PR. PR is 12 centimeters. So you just have to make sure this line is 12 centimeters and connect it, and that's it. That's it.
All right.
Something hard, but not hard. All right?
Okay, sir. Thanks.
No problem. All right.
Now telling me about it. Well, before, when I did do the exam last year, I wasn't quite sure about this construction until now. So,
But here now, it's 3 marks. In the grand scheme of things, you could lose that 3 marks. It wouldn't affect you that much. It's 3 marks. But it's not hard. It's not hard to understand. I wouldn't say it's hard to understand. Right? I see Nishana ratio. Nishana, talk to me fast. Fast.
So what to do if your calculator clunk out?
Cry. How we have to be? I had to cry.
So I was like it not coming on.
Yeah, what's up, Casio?
A Casio.
oh, he must have them.
So I had it too, but I forgot how to use the sharp.
All right. You had to change our battery fast, girl. You had to change our battery fast. Go buy any jewelry place, and they could change it for you.
Okay, thanks.
Yeah.
I see her heartbreak there when she mentioned Casio, boy.
Because I was like,
I was ready to fight against a shark.
So say he don't like it at all.
If you could fight, you could fight. That's not, oh gosh.
Oh God.
Olia, right? Here's something, right?
With a shark.
Here's something.
Excuse me, sir.
Right, here's something. Olia, here's something, right? You know how your calculator have like a little solar panel? Once it have light in the room, the calculator will work. Once it have light in the room. So if your calculator die mid-exam, and it have light, it should be fine. Should be fine. You wouldn't even realize it died.
Like this?
Excuse me, sir.
Yeah.
Oh, okay.
Sir.
Yeah. Wait, let me show you something, right? Let me show you something. Oh, you can see this?
Yes, sir. I see your sharp calculator.
Yes.
Oh, everything fall along there, boy. Everything fall along.
What?
Way, boy. Oh, way, boy. Until you know what they say, mash it up. It's like a massacre. I'm clear up this. All right. Yeah, boy. Let me show you something, right? You know, a bunch of things click up here, boy. Ways, boy. And like the TikTok and them fall long, they fall long again. I remember this Sonar Popo song,
TikTok
boy.
any
Yo,
most abuse.
yeah, boy.
I think I TikTok ban in you know. Every minute
Let me
you
show
touch
you.
the phone.
Let me show you something quickly, right? So they would worry less. Spotlights. Wait, are you seeing more or no? Are you seeing
If
more?
if we are
Yes,
meeting
sir.
another half a
All right.
year,
All right. Let's see how it's not working, right? Because the
yes,
battery,
sir.
right?
Yeah.
Watch
Uh-huh.
this. Watch this, right? I'm gonna put on the flash on my phone.
Whoa,
Whoa, that's
that's
Insane.
cool.
And I
Right?
just Lego, it would turn off.
Bomboclad. Sharp, me
Yes.
not know you could do that. I
Hey,
thought it
all
was for the
calculators.
Casio.
No. Hey, what? Earlier, this is a perfect time for me to talk about physics, right? You see this? It's a solar
yeah.
panel. It converts light energy to electrical energy. That's what it does. That's the purpose of
Ah,
it. Yeah.
I say
thank
you can
God for
describe you can
something.
I say you can
And
describe the transfer from kinetic, let me put a gravitational potential to then
Yeah.
electricity and more
When I do any physics live, I will do that.
sir,
Ah,
sir,
normal.
sir, I am grateful for you to be teaching maths and physics.
and add maths.
For
Don't forget the
real.
add maths. I'll teach add maths as well. Don't
Well, I'm
forget
not
it.
doing hard maths, so it's only two. I wish I was doing that, but it's only
You're
two
right.
I
Anyways,
do.
I'll come off
Okay.
there. I'll hope all the rest are good luck for the night and the morning. Sir,
Alright.
thank you very much.
Not a
Until
problem. You
next
don't know.
time.
You don't know. Later.
Us.
Take care.
Later, sir. Simple.
Excuse sir.
Yeah. Talk to me. Talk to me.
As
Real
I said,
questions, boy.
as
Real
I said,
questions.
it might be like way out of reach do anything on anti-science, but you know any recommendations like
Nah.
teachers do it?
Don't really have any recommendations. I will look for you though. I'll look out for you.
Yeah, sure. Thanks.
Yeah. Right.
Short boy, look like we are talking about boy. We are talking about that into science boy.
Hmm.
So
All right.
somebody say they're so desperate to pass the one and charge the calculator in the sun.
Hey, wait. This is a perfect opportunity for me to explain some more physics to educate you guys. So the solar panel, it converts light energy into what energy? Light energy into what?
Check
Electrical.
energy. Energy.
Electrical.
Electrical.
Electrical energy.
And this could be used by your calculator's MCU, like the processor, whatever, for it to work. Now, I'm asking you something, right?
Mm-hmm.
The battery that's in your calculator, it's a dry cell battery, meaning that it can't be recharged. It cannot be recharged. So when I say thing like charge in the sun, that's a big myth. All that's happening is like, okay, when your battery dies, it reverts to using this as a power source as opposed to the battery. But there's a myth. Like the battery that's in your calculator, it cannot charge because it's a dry cell battery. Dry cell batteries, um, once the electrons are depleted, it's drained. You can't charge it back. You can't push electrons back into it. However, wet cell batteries, that's what you call it, like the lithium ion batteries are in your phone, you could pump electrons back into it via your charger. But the battery that's in your calculator is not rechargeable earlier. So don't say things like charge in the sun. You can leave your calculator whole day in the sun. And when you put it in the dark, it won't go and come on. Because the battery in your Sharp or your Casio is a dry cell battery. And dry cell batteries are not
Chargeable.
Chargeable.
right.
Chemistry
Exactly.
teacher soon.
Look how
Chemistry
Sir
teacher
put
soon.
physics and chemistry in the same sentence. Talk
Right.
about
Chemistry teacher soon.
lithium,
Electrons. Like, okay.
electrons. Okay. You're cooking, sir. You're cooking. Clock that.
Because a battery, until you know about Q is equal to IT, charge, current, time. Did you know that charge is just the amount of electrons you have
Yeah.
Okay, when I do any physics lab, I will explain all that. But physics real cool. When you're charging your phone, you're just pumping electrons back into the battery. Yeah. Yeah.
Okay.
I see Brandon
So
raises.
is this calculator okay?
So if I walk in that exam with two calculators, they won't tell me anything, right?
They shouldn't. They shouldn't. They shouldn't. They should not.
I have two
Okay.
of these and a regular one.
You should be
Yes.
fine.
So so
Okay.
topic you're gonna do now, vectors alone.
I'm gonna do vectors alone. Yeah. Because
Okay.
whole out tomorrow I'm gonna be outside. We're gonna be outside bad. We're gonna be brawling. Tomorrow we're
Okay.
gonna be brawling.
So
All
yeah,
in mathematics.
Brawling. I
what
like
time?
that one. I like that one. Olia, post up on your WhatsApp status and don't forget to tag my boy.
Berlin mathematic vibes.
Yeah,
You're
boy.
welcome. You're welcome.
Tomorrow.
I don't know, but I will let you know. I'm thinking like 4.
In the evening.
Yeah. In the morning, hey. In the evening, boy. Yeah. In the evening. Yeah. Olia, take a screenshot of this and put it on your IG story, whatever story, status, whatever, and tag me, right? Brawling mathematics. Brawling mathematics.
Strike a
Brawling.
pose. The strike a pose.
Wait, yeah. What to do, boy? Wait, I don't know what to do, boy.
Pull up a calculator and pose with the
Wait,
calculator or something like
wait,
that.
no. Wait, yeah.
Yeah. Oh gosh, that's a Superman pose there, boy. Wait, no,
No,
shucks.
no.
Wrong thing. Ben 10 pose, boy.
Boy.
Boy, we had the Ben 10 maths teacher.
No. Until you know the picture with the guy with grills and he like you know how he like iced out
Yes,
watch.
sir.
Yeah, that's the meme, boy. That's the meme. But this is actually a Casio watch calculator. Yeah.
Big up to Miss Maths vibes.
Yeah, big up to my girlfriend for getting my nuts. Big up Miss Mark vibes.
It's
Yeah,
so
man.
cute. Aw.
Right, so let me get on. Right. Brawling mathematics. What I just say, boy? Brawling mathematics, dog. What the hell? Hey, right, vectors. Again, vectors is like
Mathematics.
brawling a bit too hard there, my guy. So vectors, again, all your again, vectors is sort of like directions, right? That's what you have to know. Vectors is essentially directions. Let me teach you the basics of vectors now. So like, here what, in school, they just tell you how to learn a bunch of formulas and learn a bunch of whatever. But when you understand how it is working, you don't remember none of that. Let me show you. So in school, you would learn the triangular law of vectors. And so you learn that triangular law of vectors or triangular rule of vectors. Until you learn that? Yes or no?
No, sir.
I never learned triangular rule of vectors.
Nope.
People
No,
only
I learned vectors by itself, but I never learned that part.
Let me show you
Clearly, these
something, right?
teachers decide everything for me, boy.
Wait, let me show you something, right? So say I wanted to go from A to B. How I go from A to B, boy? How I could go from A? Wait, let me just add in a middleman. Oh, right? How would I go from A to B? It's just direction.
By
From
going
A to
up.
O and O to B.
Going across and then going up. You gotta go across from A and then go up to B.
Right. So then A to B would just be equal. And you see, you don't have to remember no law and thing, you know. You should look at this and see. Earlier, let me know if it's hard. And so you can see that if you want to go from A to B and you have to go from A to O to B.
Yes,
Yep.
sir.
Yeah. You don't have to remember no rule or anything.
AO to AB.
You don't have to remember no
AO
rule
to
or anything.
OB, sorry.
So, but when we doing vectors, right? Let me just show you with a column vector as well. Oh, you know it's a column vector?
No.
So you could refresh my memory. I heard it before.
A column vector looks like this. X, Y. And it instructs you how to move on the Cartesian plane. The Cartesian plane is just the X and Y axes, right? So the X, it tells you the movement. It tells you the horizontal movement. And Y, okay, if X is the horizontal movement, what do you think Y does do?
Vertical movement.
Vertical movement, right? So let me explain something. Brawling mathematics. I love that one, boy. I love that one. That tough. That tough. Don't forget to tag, man. Don't forget to tag, man. Real funny, boy. I had a big up Renisha for that one, boy. Big up Renisha one time, though. So let me explain something, right? In vectors, you need to know two main types. You need to know is a position vector and a displacement vector. Do any of you guys know where a position vector starts from?
No, sir.
The current position it enter whatever
Sir, the origin.
the origin and
Yeah. So a position vector is a vector that starts from the origin. Right? So like you could have a vector O to A. So typically, the origin is denoted by a capital O. So if you see something like O to A, then you know that the vector has to start from where? Earlier.
O.
Yeah. And if you follow this instruction, and if you follow this instruction, it will take it to where?
A.
Right, because the vector would take you from O to
A.
right, O to A. Let me show you. I'll probably confuse, so I'll show you what I mean, right? So again, I said that the first element tells you the horizontal movement. Now, and the other one tells you the vertical movement. So for those of you guys that don't know what horizontal means, it's not a problem. This is what I mean by horizontal. So horizontal, you could either move in what directions?
Left or
Left
right?
to right.
Left or right, and vertical is up and down.
Right. So when we talk about left, right? Left, you're talking about negative. If you see a negative number, move to the left. If you see a positive number, you move to the
Right.
right. Vertical movement. What do I mean? Vertical. So like up,
Down.
up. I think up is positive or up is negative. What do you think?
Positive.
Positive.
And down is
Negative.
right. So here what? Here what? I want a little read this for me, right? So again, we know we are starting from where? This vector tells us we're starting from where? O to A, starting where? So starting at O, which is the origin, and then we see in positive 2. If it's positive 2, we're gonna go to the left or to the right?
To the right.
Right. And all you would see this in transformations as well. As a translation. The translation tells you how to move because it's a vector. Right? So this tells us 2 to the right, and then look at the other one, 3. That's telling us vertical movement. Since it's positive, it's gonna be 3 what?
Up.
Right, 3 up. So stay with me, right? Stay with me. So I know where do I know I'm starting from? I'm starting where?
The origin.
Right? I understand that is all right?
Yes, sir.
Right.
Yes, sir.
And I'm going to go 2 to the
Right.
and then what?
Right.
And then what?
3 upward.
3 down.
3 upwards.
No. Watch.
My bad.
Right? 3 up. Doesn't that take me to a point?
Yes, sir.
What do you think we can call that point?
Sir.
O 2 3.
No, A. That point is
2,
A.
3.
Point is A. Because the vector, because this vector over here takes us from O to
A.
right. So if you want to represent O to A could be represented as this. Oh God. I understand, right? O to A, to go from O to A, I go 2 to the right and then 3 up. I understand?
Yes, sir.
Now let me ask you a question. What kind of triangle is looking like?
Right angle.
Right, a right angle. You know that this is 2 and you know that this is 3. Could I find the hypotenuse?
Yes.
Yes,
Using
sir.
using
We can find the
right. And that brings me to another point. If you want to find the magnitude of a vector, the magnitude is just the resultant part. It's just like the diagonal. And so that's just, if I apply Pythagoras theorem, that's just going to be the square root of 2 squared plus what? So we have 2 here and we have 3. So 2 squared plus,
3 squared.
yeah, right. If you don't understand it, that's
That's 4
fine.
plus 3. That's 4 plus 3. 4 plus 9, sorry. 4
Plus
plus
9.
9.
So I'll understand that the length for this would be square root of 13.
Yes, sir. I'll be
Yes.
13.
Square root of 13. So like what I just showed you guys is how to find the magnitude of a position vector or any vector really. And I also showed you guys what a position vector is. So a position vector takes it from the origin to another point in the Cartesian plane. Are you understand?
Yes, sir.
And if you want to find the magnitude of a vector, the magnitude of any vector, that comes from Pythagoras theorem as you would have just saw. And it's just going to be the horizontal part squared plus the vertical part squared. And that would tell you the magnitude of a vector. So if I asked you for the length of if I ask you for the length or the magnitude of O to A, how would I calculate that? So we have 2, we have 3. So like, okay, if you're confused, right? If you're confused, 2, 3, x, y. Where's x? Where's x, guys?
2.
Right, what? If you're confused, right? Watch. See, x is 2. So if I wanted to find the magnitude of that, I'll say 2 squared. And if I wanted to, where's y? Somebody tell me where's y? Fast. Where's y?
3.
3.
And that will be the square root of 13. Where's the square root of 13?
3.60. Well, 61 when I round it.
I can't blow all your mind, eh? I really like to blow all your minds. 3.61, right?
Yes, sir.
I just put units. I'm gonna blow all your mind real bad. Watch this, eh? Watch this all here. Wait, it don't look like it was to scale. It don't look like it was properly scaled. Yeah. Earlier, yeah, it wasn't a scale diagram. Otherwise it'll work out. Yeah, but
But
can
so
you
if you
guys
kind of look to the top, you kind of see in the tree in line with the E.
the 3 in line with the what? The 8? But here what I'm saying, here what I'm saying. What kind of triangle is this?
A right angle.
A right angle.
A right angle.
And as such, the hypotenuse is OA. Let's see, now OA is the hypotenuse, O to A.
Yes, sir.
And so OA squared would be equal to 2 squared plus 3 squared. If you're confused, watch. This length is what?
2.
And this length is what?
3.
Yeah, so 2 squared plus 3 squared. And to find for OA, that just 4 plus 9. So what we do in there is really Pythagoras theorem, right? And so that's how you find the magnitude of a vector. To find the magnitude of a vector is just the horizontal part squared plus the vertical part squared. So I hope you guys understand that and you're with me.
I understand.
Good. So I'm gonna go over another example, right? If you're confused, don't worry, I'll go over another example. But guys, this is how you find the magnitude of a vector. This is how you find the magnitude of a vector, right? Magnitude of any vector. Magnitude of a vector. Magnitude just means the size of the vector. All right, cool. So let me do a recap, right? Kimura, see your hand raise.
From the start, kind of was over, and I was a bit confused from the start. So
Listen, a vector is just direction. That's all. Vectors is just directions. If I wanted to go from A to B, how do I do now? A to B, how do I do now?
going up.
No. You always say your horizontal first, then your vertical. So like, check this out. I want to go from A to B. To go from A to B, I could go from A to O, then where?
O to B.
O to B.
Right. So imagine you're traveling, right? You want to go from A to B. To go from A to B, you gotta leave A, you could go to O, and then from O, you could go.
To B.
Right. So this is a triangular ruler vector. So if I want to go from A to B, I go from A to O, and then O to B. You understand this part?
Yeah.
Right. Now I'm going to move on to column vectors. A column vector looks like this. The first element tells you the horizontal movement. So horizontal means left or right. If it is negative, you go into the left. If it's positive, you go into the right. The second element tells you the vertical movement. What does vertical mean?
Up or down?
Up or down, right? If it's positive, it's up. If it's negative, it's down. Understand? Right. Now we're going to move on to position vectors. A position vector is a vector that just starts from the what's O? What does O represent?
Origin.
Right. So in the Cartesian plane, this is the origin. Understand? You're sure you understand, Kimura? If you don't understand, talk to me, you know.
No, I understand.
So Kimura, this is in the column vector form, right? Can you see that?
Yeah.
So the 2 would represent what movement? Horizontal or vertical?
Horizontal.
Right. Since it's positive, are going to the right or going to the left?
Going to the right.
Are going to the right. So I'm saying 2 to the right. And then this 3 over here is telling me what? Are going where?
Vertical.
Right. 3 to the what? Up or down?
Up.
Up, 3 up. So here what I'm saying, right? Position vectors start from the
Origin.
Origin.
right. Because it literally telling you O to E. So we want to go from O to E. So here what? We're starting from O, right? And
Yeah.
according to the instructions, we're going to go 2 to the right and then 3 up. And that would take us to the point E because the vector says O to
E.
O to E. So this is our position vector here. It just tells you how to traverse the Cartesian plane. Like how are you going to move in the Cartesian plane? It tells you how to move it. It gives you directions. It gives you directions. Understand?
Yeah.
Yeah, sure.
Yes, I do.
All right. And if you want to find the length of a vector or the magnitude, this is the formula. So, surely where this comes from? What does this come from, guys? What does this come from?
Pythagoras theorem.
Pythagoras theorem.
Right. This really comes from Pythagoras' theorem earlier. This really comes from Pythagoras' theorem. Okay, let me go through a couple examples to just see if I understand everything, right? Quickly. So I'm going to put down a point and I want you all to tell me what this point would be as a column vector. Right, so this is y, this is x. Bam. So I'm going to put a point here. Wait, not too easy. Right, and I'm going to call this point C. So Kimura, right? Kimura, you tell me, if I wanted to go to this point, what would the vector look like?
3 to -1.
Right, so 3 to the right, and then what? So 3 to the right, how am I going to reach here?
You have to go down. It'll be negative.
I have to go down 1. So if I'm going down 1, that'll be -1. So 3, -1. And that vector would take me from the origin to where? Tell me, Kimura. It took me from the origin to where? So, what did it take me? It took me from the origin to where?
Say -1.
No, it took me to C. It took me to C. Yeah, watch. O to C.
Okay.
And so the vector O to C is 3, -1.
Okay.
I'm going to give you another one, right? Let me just say I call on this point F. How would I go from O to F? What's vector O to F?
Say that again?
What's vector O to F? So again, you had the first thing you had to tell me, again, so if you're confused, right, remember, you're starting from the origin. How would I move if I want to reach F? That's the question I'm asking you. How would I move if I want to reach F? So you tell me horizontal first, then the vertical. So tell me.
Horizontal, it goes to -3.
-3 there, and then what?
And then it goes vertical up to not -1, +1.
Right, so the vector is -3, 1. Are you understand?
Yes, sir.
So somebody wants us to repeat because they're going too fast.
Key. All right. Let me see what I could. Which part? Which part I lose it from? Okay, I'm gonna try.
So I just saw it in the chat.
Right. Sure, when we're doing questions, I'll try to explain it more, but we're just covering the concept here, right? I'm just trying to cover the concept here. So, everybody, just remind me, what is our position vector? A vector that starts at the
Origin.
right, it starts at the origin. So you see O followed by some other letter, right? So like OF or something. Cool. And when you're writing your vector as a column vector, because in maths, the main one you see is a column vector. A column vector is given in the form XY. What does X tell me? What does X tell me?
A vertical movement.
Horizontal movement. Horizontal.
My bad, horizontal. My bad.
Horizontal, right? Horizontal. And like horizontal is in what directions?
Okay.
Horizontal is left or right? Left.
Which resembles the horizon.
Yeah.
Vertical is up or down.
Right. And left. Wait, okay. Left is positive or negative? Left. Where's left?
Negative.
And right is?
Positive.
Positive.
Righty. Y tells me vertical. And that can be up or down. If it's up, where will be?
Positive.
Positive.
Down, negative. Bam. So all you understand, position vector, column vector, and triangular, those are vectors. Let me give you another example. Let me give you another example of something, right? Let me just call this LON. Somebody tell me fast how I could go from M to L.
MO plus
MONOL.
Right. I hope they could see that like logically. I hope they could see that. Like it don't have no fancy maths to this, you know. It do have no fancy maths. Let me just draw a person here. Call this person Bob. Actually, Bob is a fat man killer. If all you know the math vibes, all they go understand who Bob is, right? Bob is a fat man. He's Bob.
I thought you was gonna say so. I thought you was gonna say Bob the Builder, you know.
No, this is fat man Bob boy. Fat man Bob. He eat too much. So Bob, he starts at M. He wants to go to L, right? But he say he had to exercise. He say getting too big. Look at see he too big. So instead of going from M to L directly, you know what Bob do? He going from M to O. How else he had to move?
From O to L.
Right. And after this, he get a little slimmer. He lose some weight, you know. He lose some weight. Big up Bob. Fire W. Fire W in the chat for Bob.
Excuse me, sir.
Wait, boy, Bob been a dumpling before.
Yeah, boy.
Like Bob, yes.
Right. So
that is weight like Bob.
Sir Antoine, when you're doing it right, you see I'd have ML, and then we went from M to O plus O to L. You basically get back ML. So you're starting at your starting point and you're ending at L. Yeah.
and O is like the middle man. O is like the intermediate step.
Have the both in common there.
Correct. Right, cool. So you understand a good bit. And if you wanted to find the magnitude of a vector, let me just say I give you a vector LM. Right? Let's just say vector LM is 5, 7. How I find the magnitude of that?
You square root 5 squared plus 7 squared.
Yep, and I'll get my answer. Plug into your calculator, you get the answer. So we understand position vectors, column vectors, triangular law vectors, and magnitude. That's great. Some other key things you need to know for vectors. What other thing you need to know for vectors, boy? Direction. The direction plays a very important role in vectors. So direction. Let me explain. So like, let me just say that this direction over here was, I don't know, I just call it positive u, right? If I go in the other direction, what do you think I gotta call that vector?
Negative.
That's you?
Negative u. So the point I'm trying to make is, in vectors, opposite direction mean that you're doing what with the sign?
add in or subtract
Nah.
in?
What happened to these signs here? Went from plus u to negative. What happened to the sign?
Oh, they change. It's the opposite.
Change signs. Change signs. So here it is. Earlier. Anytime I go in the opposite direction, we're gonna do the signs. We're gonna do the signs.
Change them.
You're gonna change the signs earlier. You're gonna change the signs. So like imagine I had this vector over here. Let me just call this vector 2u plus v, right? If that was 2u plus v in that direction, and I went in the opposite direction, I'm gonna change the signs for every single thing. So this 2u gonna turn to what?
Minus u.
And
Minus
this positive v go turn to what?
minus b.
Right. So earlier, the point I want a little take away, anytime you go in the opposite direction, you do what with the signs?
You switch them.
You change the sign, you just change the sign. That's all, guys. So if you're going in the opposite direction, you change. That's so important. That's so critically important in vectors. Right, good. Right. So I'm going to go over. Wait, let me go over how to prove vectors are parallel, and then I'll do collinear. How do you prove that two vectors are parallel? You could do this. Okay, if you could write that one vector is a scalar multiple of the other one, then it is parallel. And able e. Ali, what does parallel mean? Anybody can tell me what parallel means?
Lines that never meet.
Yeah.
Equal lines that never meet.
Good. Ali, good enough. That's good. But let me ask Ali in vectors. Parallel lines will point in the, generally speaking, if they are parallel.
Same direction.
Well, to be fair, you could have lines that point in the same direction and parallel, or they point in the completely opposite direction and parallel. So I probably shouldn't use that. But like, let me show you an example of what I mean, right? If I have this vector over here and I have this vector over here, and they're pointing in the same direction,
Yeah, so
yeah, will they ever, like, if you extend the vector, will it ever touch?
no, it wasn't what touch.
Right? If I have this vector and I have this vector over here, and both of them going in the same direction,
Yeah.
yeah. Let me show you an example where it wouldn't be in the same direction, but it would still be parallel. This vector and this vector, and the parallel. Yeah, will they ever touch? Will those vectors ever touch?
No.
No, they will never touch. But they're going in opposite directions. But the point is they will never touch. So all these are examples of parallel vectors. And this one specifically is an example of a parallel and a collinear vector. We will touch on collinearity just now. But like, although where's the difference between these, like this, like these two over here and this one in the middle? Where's the difference?
So
Like
one
you see,
meet.
One in the middle going the same way.
well, the big difference is that this one starts from a point here, and this one starts from another point. Did these two start at the same points?
No, sir.
No. Did these two start at the same point?
No, sir.
No. Did these two start at the same point?
Yes, sir.
Yes, sir.
Yes.
So if you have two vectors that have a point in common, they are parallel and they're collinear. Yeah? Well, you had to show that scalar multiples of each other, but it's sounding so complicated, but give me a chance now. I'll make it make sense. I promise.
Chris,
Yeah,
I can
talk
ask
to me.
something.
Talk
So
to me.
you see the parallel one, the third one where you put, right? I would face in opposite sides, right? The one not going downwards. I make the number negative from the number that's from the next line that parallel. Or
Yeah. So like if this was minus u plus 7b or something, then this one would be u what? It'd be u what?
u plus 7.
Nah, you're changing the sign, remember? If
Oh,
it
yeah.
could, so it could be, so that negative u turn to u and that 7b go on turn to what?
Negative 7.
Negative 7b. Understand?
Yeah. Yes, thanks.
No problem. So here what? Let me give you a real simple example. Real simple. Check this out. This is y, this is x, right? 1, 2, 3. 1, 2, 3. Okay. Call this O. So we're gonna have a position vector here. Call that 1, 1. Call this E. Are you understand that? So I would say that vector O to A, I would say that vector O to A is what? What would that be as a column vector? You have to tell me horizontal first, then vertical.
1, 1.
If you're confused, if all you're confused, right? How would I go from O to A earlier? I had to go 1 to the right and then
1 upwards.
exactly. So I traveled 1 to the right and then
1 up.
1, 1. So stick with me. Let's stick with me. Let me see. I had a vector like call this B. You notice that both of these vectors, what happened with both of these vectors, boy? And they look parallel.
Yes, sir.
Because
Yes, sir.
both of them pointing in the same direction. Both of them parallel. Both of them parallel. Parallel vectors could point in the same direction or in opposite directions. These two are pointing in the.
Same direction.
So let me ask you something, right? How much OA is you think it would take to make OB? That's a question to think about.
3.
Said 3.
All you see in that people on Zoom, people on the Zoom, people on the TikTok. Can you all see that it will take 3 OAs to make O to B? Let me know if you're seeing that. It would take 3 OAs
Yes, sir. Yes, sir.
to make
Yeah.
right. So you see how I could use OA to make OB? It proves that they are parallel because it proves that they're in the same direction. Let me explain. I'll go see it when I write it as a column vector. So somebody tell me, what would O to B look like as a column vector?
3, 3.
Are you understand that or no? If you do understand, how would I go there? How would I go there? Well, to go there, I would have to go 3 to the right and then
3 up.
right. So 3, 3. Can you guys write OB in terms of OA? You actually could, eh? You actually could. Let me show you what I mean. If you don't understand, watch. Pay attention. I could write OB as 3 by what? 3 by what?
1, 1.
1 by 1.
If you're confused, right? If you expand this out, if you do scalar multiplication, what is 3 by 1?
3.
3.
What is 3 by 1?
3.
Right. And so I pulled out the 3 and I write 1, 1 on the inside. But we know that 1, 1 is what vector? What is 1, 1? What is vector 1, 1?
OA.
OA. Oh, let's see in that, right? Vector 1, 1 is OA. So I could say that O to B is just how much O is.
3.
And can we see that visually, guys? Can we see that it'll take 3 OAs to make OB?
Yes, sir.
Yes, sir.
In that, right? So what we just proved mathematically is that we could use OA to make
OB.
right. And how much OA is it going to take?
3.
3. So here what? You see the 3 by the OA, and that's what I talk about when I say scalar multiplication. So anytime you can write one vector as a scalar multiple of another, it is parallel. Right. Yeah. Are you understand?
Yes, sir.
So,
Yes, sir.
and these vectors over here would just so happen to be what as well? Since both of them have a common point O. Both of them. People, nah, not positive.
Position vectors.
Both of them are position vectors, but I'm looking for a specific word. That's with C. Starts with C.
Collinear.
Collinear.
Right. Before I move on to collinearity, let's look at some more examples where we look at parallel vectors quickly. So let's do a little speed round, right? Let me just say I had vector OB and vector OB was no, I'm not going to do the 6. No. And let me just say we had vector O to C, and I tell you vector O to C was 8, 16. Is it possible for me to write one of these vectors as a scalar multiple of the other?
Yes, sir.
Yes, sir.
Right, because OC, right? Let's see, not common factor between 8 and 16.
Yes, they are.
If I pull out 8 from that, what I write on the inside?
1/2.
1 and 2.
Right. What is vector 1, 2? What we know vector 1, 2 is?
OB.
Right. So I just proved that OC could be written as a scalar multiple of. Please mute your mic. Somebody mic unmuted. So guys, you see what I'm talking about, right? So how much OBs would it take to make OC?
8.
8.
So 8.
Exactly. So you see how we could write OC as a scalar multiple of OB?
Yes, sir.
Yes,
All you do understand, right? 8 is the scalar multiple I'm talking about. This is the scalar multiple I'm talking about. So therefore, these vectors are what?
Collinear.
Nah, not collinear. These vectors are parallel. But we know that they are collinear as well because both of them have a what point in common? What? Both of them start. Where both of them starting at? Where both of them starting from? Where are both of them starting from? O.
You're right.
They would share a common point O, and so they would have to be collinear as well. But we get into that just now, right? I'll put a note here as well. So I'll probably wondering, so what the heck does collinear mean, bro? What? I'm losing here. Okay. I'll probably losing here. I know losing here, right? But I'll probably confused. Collinear, what I mean? Collinear just means on the same line. And for you to be on the same line, you must have a common point and you must be parallel. Watch. Let's see what I'm talking about, right? Aren't these vectors on the same line?
Yes, sir.
Yes, sir.
Watch
Yes,
that,
sir.
watch that. And the same line. These vectors over here, watch. Same line. But for that to happen, they must have a point in common. So that's collinearity. Collinearity just means that two vectors on the same what? On the same what?
Same line.
Line.
And for them to be on the same line, they must have a what in common?
Common
Right.
point.
Cool. Let me give another one. And I want you guys to tell me if these two vectors are parallel. So like O to D. Let me call O to D 9, 7. And then we just call O to M 1, 8. Are you seeing them vectors parallel, right?
No. Yeah.
No, sir.
Nah. Is there any way you could write OD as something of OM or vice versa?
No.
No, sir.
No. So these are not parallel. They are not parallel. Not parallel. Because we cannot write one of them in terms of a scalar multiple of the other one. Look at the difference, right? Over here was 1, 2, and 8, 16. And you can just look at it and see that if you multiply this by 8, you get back OC.
Yes, sir.
You can't do that over here. You can't do that. So if you can't write it as a scalar multiple of each other, it is
Not collinear. I don't know.
not parallel. Not parallel. Or collinear. Right? Not parallel. So let's move on to.
Give me back co-host here fast.
Say that again?
Give me back co-host fast.
I bet. Although don't forget we're singing, we're singing at the end. Plenty songs. Right.
So check remission, them sleeping or no?
Check Gabriel boy, boom clot.
And what Gabriella too.
Wait, I'm sniping them. I'm sniping them. Ole, give me a second.
What's the comment she face now?
Ole on YouTube. Ole not seeing Radisha and them watch Ole watch them men now. Watch them men. Well, watch them ladies boy. Them sleeping there boy. Them cool.
Them bugger tucker boy.
The knock
They
out.
knock out.
Hey boy. Right. So let me show you what collinear means, right? Quickly. So for a vector to be collinear, it needs to be on the same line as the other vector. It needs to be on the same line. Needs to be on the same line or like overlapping. And for this to happen, number one, the vectors must be what? They had to be what? That's a P. They must be what?
Parallel.
Right. It must be parallel. And you guys, I showed you all how to prove a vector is parallel, right? For any two vectors, it's parallel if you could write one as a scalar multiple of another. So if you had a vector u and you had a vector v, and you could write u in terms of v, it's parallel. Right? It's parallel. And if you're confused, I'm talking about like this. So you see how we say OC was 8 times OB? That means it's parallel. Because I could write one as a multiple and the other one. Could I have done that over here?
No, sir.
No, so there wasn't parallel. So for vectors to be parallel, you need to be able to write them as a scalar multiple of each other. Okay. Part 2, they must have a common point. They must have a common point. Okay, so I think we're ready to answer past paper questions now. Yeah?
Yes, sir.
Yes, sir. You're ready.
Yes, sir.
Right, there we go. Come on here, guys. Come on here. Come on here.
Yeah.
Yeah.
2022.
21.
24.
I will do 2022. Brawling mathematics, guys. I do all of this. Chances are if I turn to a year, I've done the question before. Done it before.
And this man would erase all them answers and do it again for fun. Cause this man just built different.
I've been built different. Well, they don't know what we just say. One math vibes never.
Never two.
I'll find a moving dead boy. One.
Brother, and I don't catch two of them sleeping.
Hey boy.
Wrap up in sheet all thing, boy.
No, that is just that's I don't know what that is.
Okay.
What do you mean, bro?
Boy. Somebody had the honorees.
Zion, talk to me fast. Viltrumites. Yep. Yeah, boy, we have a Viltrumite in class. Are you here in Zion?
He might hardly walk in.
No, sir.
It's better type.
I said type. One of them people go tell me what you're saying. Right. Brawling. How to make a remix, how to make a match remix.
This question is from January or May, June?
This is from
He asked if we could do
morning. May, June?
He asked if we could do 2025 May paper 2 after the vector question.
Bet. I will do
the vector question.
I will do 3 vector questions and we call it a day, right? Call it a day. Yeah.
Yeah, best go sleep early, boy.
So,
Yeah, boy, because tomorrow I gonna be here like whole day, whole night.
Well, that ain't me, boy. I had a lock in with this thing.
Yeah,
So
bro.
what time you think the live gonna be tomorrow?
Think 4 o'clock. Think 4 o'clock, you know. I think 4 o'clock.
So
4 a.m.?
Oh wait, what? What? Are them men serious?
yeah,
Who say 4 a.m. day, boy?
For that one,
Who say 4 a.m.?
Boy.
Yo, I kill me.
Hey, James, you alright? I see you there. You alright?
You wake me up, my sleep, yes? Who say 4 a.m.?
Wait. I have one for you, Renisha. Who say I 3 in maths? Gotta lucky now to get a one, dog.
Yes,
What a
I'm
distinction.
tired.
43 is max.
Distinction.
I go try, sir. Go try. I'll try. I'll try. Okay.
Right, let me go. Let me go. Okay, okay. In the diagram below, O is the origin. If O is the origin, then all of these vectors are what then? If you start from the origin, what kind of vector are you dealing with?
Position vectors.
Position.
Right, position vectors. So
Science
O to
happen.
X. So O to X is U. So O to X is U, O to Y is V. OX and OY are extended so that X and Y are the midpoints of OA and OB. Let me read all of that for you in logic, right? So like, it looks like this is the midpoint of this. Let's see now or no?
Yes, sir.
Yes, sir.
Now, I have a question for you, right? If this is you, I think this is
You.
I'll be you as well.
Apparently two units.
and so
U
if I
squared? I don't know.
no. Hey, who say
Come
U
on,
squared? Who say U squared? Come, let me. Who said that? Give me a name.
Tell out yourself
Me
fast.
and
Anne, okay, Anne. It's a good thing you tell me that. Like, all right, so Anne, O to X is what? O to X is what?
What do you mean by that? Like
All right.
plus U?
If I want to go from O to X, the vector X.
That's U.
Right, O to X is U, right? And it looks like
Mm-hmm.
this point is in the middle, right? And you can see that on the, this is looking at the middle. Looking at the middle of OA.
Yeah.
So like, okay, wait. Let me make it real simple here, right? Real simple. Imagine I had a line, right? And this line was 10 centimeters, right? What the middle will be?
Yes, sir. 5.
Right? So this portion is 5 and this portion is
5.
all right. So if this is the midpoint here, right? And I'm telling you that this is you, what do you think this is?
The whole line.
U. I'm not sure.
The whole line you're talking about is just the
Okay.
feet.
Ann. You understand this or no?
Yeah, I understand that part.
Right. So the whole thing is 10, but the midpoint will cut it in half. So if this is 5, what is going to be?
5.
Okay, so
Oh,
if this is you, what do you think this could be?
U.
Yes. That is it. You understand?
All right. Yeah, for sure.
Good. Right, and the whole thing, O to A, what would O to A be, guys?
To you.
2U. Right, because O to X is U and X to A is another U. So altogether it is 2 U's.
To you. So
Right? O to
that's not like
Y.
you're making a love song, there, boy.
Hey. I remember my mother's Muti song, boy. I wouldn't sing it in this class, but everybody know who Muti is?
I
Oh,
know what you're talking about, sir.
the love song to Jada. Oh God, boy. That song I wrote. I'm not saying no, I can't sing that in this class. But anyways, O to Y is V. And so what do you think Y to B would be? Tama on. If O to Y is V,
V.
yeah, this will be V as well. So the whole
Yeah.
thing on the whole thing would be what?
2V.
2V.
I'll drop a W for Ann in the chat there. Big up Ann one time. Big up
Big up
Ann.
on
Yes,
one time.
guys. Yes,
One
guys.
time.
Big up
Thank you.
W. Right. Okay. Right. So they want me to express B to X in terms of U and B. So I want to go from B to where? I want to go from B to where?
X to X.
B to X, right? So I'm starting from where? We're starting.
You're starting from
From B.
B.
Okay, guys. I'm going to connect. So I want to go from B to X, right? So I connect B to X. So you can see it now. You can see it. This is how I want to move. I want to go from B to X. So if I want to go from B to X, well, I leave in from where? I leave in from where? All right. Right. So again, I go and draw Fat Man Bob. Fat Man Bob, he want to lose some more weight. He's slim down, but he's still kind of fat. Right? He say he want to focus on his health, right? So this is Fat Man Bob over there. And if Fat Man wants to go from B to X, how we could do that? He could walk from B to,
V.
and how else he could move?
From O
O
to
to X.
Right. And Fat
So
Man
would it be 2V plus U?
it will be minus 2V plus U.
Oh, because it's going in the other way.
Yes.
So
Watch.
it's how we looking skinny and you call it the name is crazy.
Hey, Ollie wouldn't get that, right? But like, I had this physics class, one of my past physics class, and we was exploring Archimedes' principle, and we was talking about the upthrust, right? And we say like Fat Man Bob was too heavy, and he would sink in the seawater because his weight would like overpower the upthrust, the buoyant force of the water, and so he sink. But anyways, so like I hear what I'm saying, right? And if O to B is 2V, right?
Mm-hmm.
If you go in the opposite direction, that 2V gonna turn to what?
A negative.
Yeah, it gonna turn to negative 2V. If I don't understand, watch it one more time. Watch it one more time. O to B is 2V. Are we going in the
Opposite direction.
opposite direction? So if we're going in the opposite direction, instead of 2V is gonna be
Negative 2V.
negative 2V. Right. So B to X is just going to be negative 2V. And then we have, when we reach here, how we had to move?
Upwards.
Upward.
Using the vector of U. So minus 2V plus
U plus U.
Yes. Watch it again, right? O to B is positive 2V, but we go in the opposite direction. So if you go in the opposite direction, you do what with the signs?
Change it.
Switch it.
Change the sign.
Right. Right. So it go turn to negative 2V. And it go in the same direction here. So if it go in the same direction, will I change the sign?
No.
No, it would just be U. So negative 2V plus U. All you understand?
Yes, sir.
Yes, sir.
People on the YouTube, give me some gas. All you understand or no? People on TikTok, all you understand? It's just simple directions. It's just directions, guys. It's just direction. And if you go in the opposite direction, we're going to do the signs.
Change it.
You're going to
Yes.
change them.
Right. So that is why I changed 2V to negative 2V. I didn't change the signs here because I was going in the same direction. U and U. Didn't change that. No. What's another way I could write minus 2V plus U?
U minus 2V.
Yeah, U minus 2V. So if you had either one of these answers, you'd get full marks. Pick up yourself. Yeah. Now, if you're confused about this, let me explain something, right? These two mean the same thing. Ollie, watch this, right? Ollie, understand? Yeah or no?
Yes, sir.
Okay, good. So that's my answer. B to X is minus 2V plus U. Good. So given that Y to A and B to X, this is where things get hard. I'm gonna lose that good bit of here, right? I'm just saying that. But try your best to pay attention. So they're saying YA and BX intersect at M. And BM is how much times MX?
2 times.
Right, so let me see if I can visualize that for you guys, right? So according to this, these vectors had to be what? They had to be what?
Intersecting.
No, they had to start with P.
Parallel.
Because BM is a scalar multiple of
MX.
right. Which one looking bigger, BM or MX?
MX.
No, BM. BM is the bigger one because how much MX does it need to make BM?
2.
2.
2.
So which one bigger?
Okay.
BM or MX?
BM.
Because we need BM is bigger because we need 2 MXs to make it up, suggesting that MX is smaller, right? and they want me to express b to m in terms of u and v. So, Ollie, stay with me. This is like real dangerous waters. So, let me try to interpret what they're saying. So, they're saying ya and bx intersect at m. So, first, I should connect y to a and b to
X.
right. So, ya and bx. Did I already connect b to x?
Yes, sir.
Right. What do you guys suppose I should connect next?
Y and
Y to A.
Right. I should connect y to a. Are you guys seeing the intersection? Yes or no?
Yes, sir.
Yes,
Sir.
All right. And they want me to call that intersection what? Intersect at?
M.
So this is M over here. Now, as you guys could see, we have different regions. We have MX over here, and we have what over here?
BM.
Right.
BM.
Now I want a little open a little eye and look at the thing logically. Which one looking bigger, Olia? Which one looking bigger? BM or MX?
BM to
BM.
BM.
How much MX does it look like I gonna need to make BM?
2.
Two. So I'll understand why they was telling me earlier that BM would be 2 times MX.
Yes.
Yes, sir.
Because when you look at it with your eyes, which one bigger? BM or MX?
BM.
And how much MX does it look like I'll need to make BM?
2.
So, see, maths makes sense, but you have to think about it and be careful. You have to be real careful. So they want us to find for B to M. B to M. B to M. How would we go from B to M? Well, let me explain something carefully. Again, guys, how much MX is it going to take to make this?
2.
2.
So in other words, I could cut this vector into how much parts?
3.
Are you understand now? No?
Yes, sir.
Yes, sir.
Let me run it back one more time. How much MXs would it take to make BM, which is this over here?
2.
So to represent the whole vector, I would need how much MXs?
3.
3. So if this is the case, then I could say, right, so out of the 3 parts, how much is this piece over here?
1.
1. So if you're writing as a fraction, it will be 1 out of?
3.
3.
Right.
1 out of 3.
So it's going to be 1 out of 3. And this will be what?
2
2 out of
2
3.
out of 3. 2 out of 3.
Right. Again, all you can't afford to blink. Get things going to get scary. All you cannot blink. Don't blink. Vector's easy, but it really easy to get lost too. Right? So stay with me. But 2/3 and a third of what? What is the big vector? What is the total vector? What is the big thing?
BX.
Okay. BX. Okay, I run it over one more time because I understand it's scary. It looks scary, but we could figure it out, right? The first thing I did, it talk about YA and it talk about BX intersecting at some point. What do I mean? Well, we connect Y to A and we connect B to X. Are you seeing the intersection?
Yes.
Yes, sir.
When you look at it, which looking bigger? BM or MX?
BM.
BM.
Right.
BM, sorry.
It sort of looks like it'll take how much MXs to make BM?
2.
So we could split this vector into how much parts?
3 parts.
And we split in what into 3 parts?
BM.
BX.
BX.
So this would be a third of BX, and this segment over here would be
2/3 of BX.
right. Real places to get lost, boy. But I feel like we have it under control.
Yes,
Okay?
sir.
So they wanted us to find for B to M. Remind me, guys, B to M would be what fraction of the whole thing?
2/3.
2/3.
Earlier, we know what B to X is?
Yes. Minus 2 plus V. Minus 2V plus V.
Oh, let's see in that, right? Where's BX, guys? Where's BX?
Minus 2V plus C.
Minus 2V plus U.
Right. Right. What you prefer to use, the minus 2v plus u or the u minus 2v? What do you prefer to use?
Minus 2v.
Minus 2v plus
2v
u.
plus u.
Right. So again, bm is just 2/3 of the entire thing. And the entire vector is really just minus 2v plus u. So you see how we have fractions?
Yes, sir.
Yes, sir.
We are going to distribute the 2/3 across everything. And so what is 2/3 by negative 2v? So wait, okay, where's 2 by negative 2? Where's 2 by negative 2, guys?
Negative 4.
Right, so negative 4 over 3v. Right. And then 2/3 by u is what?
Would it be 2/3 u?
2/3 u, yes. And just like that, you'll find your answer. It was definitely a higher level question. But I hope you all can see if you sit down and you make sure and you connect the dots, not that hard. But you had to think. You really had to work for your marks. You had to think. Right? Good. That's your answer. BM is minus 4 over 3v plus 2/3 u.
So, and how much marks one of this question is worth for?
That's a 1 mark question.
Oh, God. Huh?
No way. No
But
way.
hear what, right? Hear what? I explained it extremely in depth. I feel like if you understand it, you can see the
Yeah,
answer.
yeah. Yeah, definitely. Definitely. I understand that for sure.
Watch. Okay. Let me just I'm gonna move like I do in the exam, right? I'll let watch, man. I'm gonna move like I do in the exam. YA and BX intersect at M. Okay. Alright. YA BX. Okay, I'll call that M. That's what they're talking about, right? Alright, there's M. Well, it looks like I could cut this into 3 parts. So I see in 3 parts here. And so how much parts is this? There's 2 out of the 3 parts. So 2/3 BX, because BX is the whole thing. This will be a third of BX. And did we find for BX? Yes, we did. BX is minus 2v plus u. Bam, I get my answer one time. It sounds complicated, but you could get your answer in a couple of seconds. But this is, you see this? I wouldn't lie to you. This is one of the harder type of questions. I promise you that I was never lie to you. I feel like even if I explain this properly, and this come in the exam, somebody could still get it wrong. Because it like, you really had to think fit. This is a harder level question. Right? Okay, are you understand?
Yes,
Yes,
sir.
Okay, I'll go over it one more time because I see people kind of lost, right? Stay with me, guys. So they're saying YA and BX intersect at M. So what I'm going to do, I'm going to connect Y to A, and I'm going to connect what to what? Y to A and? Right. I'm going to connect Y to A, and I'm going to connect B to X. Do those lines intersect?
Yes.
Right.
Yes, sir.
And they said they intersect at M. They intersect at M. And if that is the case, you could see that we could cut this vector into how much parts? Why though? Why? When only look at it with a big eye, how much mx's you think it'll take to make this over here? 2. And altogether we cut it into how much parts? 3. So we cut vector bx into how much parts? 3. Out of the 3 parts, how much did mx receive?
1/3.
1/3. And out of the 3, how much did bm receive?
2/3.
2/3. And 2/3 are what? The whole thing is bx. I admit it's a harder question, but you kind of understand?
Yes.
Okay,
Yes, sir.
right. Using a vector method, show that the ratio ym to ya is 1 to 3. Show all working. It's a tough question. It's a tough question. So like you see, I was never lied to you, I was never lied to you. I will tell you something hard. Alright? This really requires a lot of critical thinking. Let me see if I can like reason it out and show you what will happen, right? So let me locate ym. And you can see ym anywhere. Ym.
Yes, sir. That's the intersection.
Right. That's ym, right? Are you with me?
Yes, sir. Yes, sir.
Okay. And you can see ya over here.
Yes,
Yes, sir.
All right. So here what? Immediately, I am thinking that I should probably find for ym or ya. I should probably do that. If I want to do anything, I should probably do that. But before I do anything, right? Again, this is our far reach, but can you guys see that we could potentially break this up into three parts?
Yes, sir.
Yeah, so
Yes,
Yeah,
sir.
and out of the
Yes.
three parts, if I split it up into three parts, right? Out of the three parts, ym is what?
1.
1/3
1/3 of?
YA.
YA.
And that's the concept we're going in to solve this. That's what we had. That's what we had to internalize. I know it's tough, and I know this kind of tough. I know. I tell you, no, it's kind of tough, right? But we could figure it out. We could figure it out. So again, you could see that we could potentially cut this into three parts. If you cut vector ya into three parts, then how much out of the three parts is my receiving?
1/3.
1.
So then I would say, so like, if you're wondering what this mean, this telling you that ym is the whole vector, and how much ya's would it take to make ym?
So basically like a ratio.
Yeah, there's a ratio. But look at it. This is telling me that ym, so ym is 1 and ya is 3. So this is telling us that to make ya, I would need how much yms?
3.
3. That's what it means. That's what it means. So let me show you how we could figure this out. So before we can do anything, we need to find vectors. What vectors you guys think we should find? What vector
YA.
we should find for ym?
YM.
Actually, let me find for ya first. That's real easy. If I want to go from y to a, guys, how are we doing that?
Y to O and O to A.
Let me let's see now. If I want to go from y to a, I go from y to o, and then what next?
O to
O to
A.
A.
O to a. I hope all you understand that. Do you guys understand that?
Yes, sir.
If I go in this direction, am I going in the same direction as v?
No, sir.
No.
So instead of positive v, what will be?
Negative.
Negative V.
Okay. And then I'm going to go, I want to go from y to m, right? Now I'm saying I want to go from y to a. Y to a. So right now I am at O. What next do I have to do to go to A?
Plus 2U.
Excellent. Pick up all yourself, well, you're really getting through these tough questions. That's brilliant. Right? So look at it again, guys. I want to go from y to what?
A.
A.
How could I, if I pass the negative mindset, I'll go see it real simple. How are I doing that? Well, I could go from y to O, and then what?
O to A.
O to A.
Exactly. Now y to A is in the opposite direction to V. So I'll change the sign to negative V. It's negative V now. And then O to A, this is U over here, and this is U over here. So altogether I go make
Plus 2U.
exactly. So y to A is literally just minus V what?
Plus 2U.
Plus
Yes.
2U.
Okay, was that hard to figure out? Was it that hard to figure out?
No, sir.
No, sir.
It wasn't that hard to figure out.
Mm-mm.
So here what? Now we need to figure out y to m. That's what we need to do, y to m. Because that's the other vector they're talking about. And we saw here, you see this ratio over here? What does it tell us? It tells us that we need how much yms to make ya?
3.
3. That's, I know it's looking complicated, but that's what it's telling us. And you can see it for yourself. You need 3 yms to make ya. That's what we're trying to prove. So let's find for ym now. Let's try to find for ym. Ym. How are we going to go from y to m? How are we doing that? Can we see?
From
Can
YB?
we see
Y to B and B to M.
Yeah.
y to b and b to m?
B to M.
Right. So let me try to understand that, right? So ym, let me write it quickly. If let's stay with me, I'll go see that it's manageable. It's hard, but it's manageable. If I want to go from y to m, again, y to m, this is what I want to do, right? I could go from y to b, and then what?
B to M.
B to m. Here what, right? Before saying all the cook dancing and like saying all they can't do it, try sit down, pass aside the negativity, pass aside the fright, and at least give it a strong shot. If all they interact with me, all you go see it's not that bad. It's on the harder side, but it's not that bad.
Excuse. So I have a
Yeah.
question, right? Just zoom out a little bit there. I want to see something. Right. So if it is going from Y to M, right? You could go to Y to O and then Y to M, X, then come back, but then it could be negative and going like that. You could do it like that too.
Wait, another way you could go from y to m. You could go y to
Yeah.
o, o to x, and
And
y
then
to
to M.
I mean
Yeah.
x. Yeah, this is perfectly fine. That's perfectly fine.
But you're gonna have to be Y negative to the O and that kind of thing because you're going backward in a sense, right?
Correct. Yeah.
Okay, and the next thing too. From B, Y to O. How much segments you could have in that? 4 or just 3 or 2?
What do you mean,
Like how so like how
like
you
over here?
have so like how you have from B to X 3 segments, right?
Yeah.
Right. You could have the same amount for BY to O or that had to be 4 because the line longer.
4. No. It's a midpoint. This is the midpoint. So just 2 segments.
Oh, okay. I understand. Oh, I didn't see the midpoint there, you know.
Yeah. So like this over here is v, and this over here is v as well. So this is the midpoint. So the
So from
whole
one,
yeah. So that's
let me say, so Y to B, only one part you could get from that, which can make it 2.
wait. Y to b is just v. Y to b is just v. Just v.
Right, but if you had to split that, there's only one split you could split that from one point to the next.
You wouldn't split it because they don't have any. You don't have any vector split in it. It's just v. It's just v.
Oh, okay,
It's
I
just v.
understand. All right.
Yeah.
It's just V because it cut. It cut. Basically, just cut from 2.
Okay,
Yeah.
understand.
Yeah. It's
I was
just
just trying to figure out something, I know too.
all right. Another way you could work the question out is y to o, o to x, and then what? I want to go from y to m.
X to M.
X to M.
Yes. But I'm not gonna do all of that, right? Instead, I'm gonna use 2 movements. Y to b and
B to M.
good. So like if we are going y to b, that's in the same direction. So that's going to be what?
Positive V.
Positive would be
That's gonna be positive here, right? However, actually no, this real simple, boy. You go just have to find 2/3 of
Yeah, it's
bx.
positive.
You go just have to find 2/3 bx, right? Do we know what bx is?
Yeah.
Yeah, we know that bx is minus 2v plus u. Oh god, my Apple pencil dead. While we're reaching flow state, that's crazy. Wait, so let me see if I can use the fake Apple pencil. Because I want to interrupt the flow state. Right now we're in flow state.
So, but M to BX is also equal to BM.
Oh, we find already. Oh, well, it's real easy, boy. Yeah, we find already. Wait, I figured out what I know. Yeah, boy.
So
The fake
your your attention span is like a goldfish.
It is. I tell you, I have ADHD. Like real bad. I don't think. Yeah, boy. So I'll wait for the upper pencil of the chart. But you already have b to m. B to m is minus 4 over 3v plus 2 thirds u. You already have that. So you just need to add that to v and simplify, and you'll get y to m. And to prove the ratio, we'll need to prove that it takes how much ym's to make ya?
1.
3.
3. Look at the diagram. How much ym's it looking like it'll take to make the whole thing?
Oh, 3.
3. Yes, 3. Watch it follow itself, right? I already know trying to trick all you know. Watch. Kristen, our series on.
Yes, I was waiting to so you could finish talking.
All right. Well, let me finish the question. Huh? Let me finish the question. I'll finish the question and then we'll go to.
Okay.
Right. So, Alia, enter the last question. We find b to m already.
Yes.
Yes,
Yeah,
sir.
we did already. B to m. We know that b to m is this over here. I don't know why I was gonna find it again. I tell you, Alia, I just do good in exams, not because I just remember, but because like I could understand and figure it out on the spot. Remembering is not my strong suit. Figuring things out is my strong suit. All right, so when you look at this, right, guys, are you seeing any like terms?
The v.
Yes. You're not seeing it, right? But what is the coefficient here? What is the coefficient understood to be?
1.
1. So here what? You have a v term here and you have a v term here. This is 1v and this is minus 4 times v. So all you had to do, you just had to find 1 minus 4 over 3. What is 1 minus 4 over 3?
Minus a third.
Right, that's minus a third. So it's going to be minus a third v, right? Plus 2 thirds u. And this is the moment where I blow your mind. Are you ready to be mind blown? Are you ready, guys? Our final is sticking in. Are you ready?
Yes, sir. We
Yes, sir. Yes, sir.
Okay, watch this badness. Watch some badness here. Watch some level badness. What is a common factor between minus a third v and 2 thirds u?
The 1/3.
The
3.
1/3. If I pull out a third from this, that would just be what?
v. Negative.
Negative v. And if I pull out a third from that, what that would be?
1/3 of you.
Nah. Watch. Okay, I need to understand something, right? 2 thirds is literally just 2 multiplied by a third. Isn't that what 2 thirds is?
Yes, sir.
So if I pull out a third from that, what am I left with?
2u.
Positive
1.
30.
And guys, what is minus v plus 2u?
Y.
Ya. So I just proved that ym is just a third of,
ya.
and that's the answer. That's it. That proves it. Because the ratio is telling me that it takes 3 yms to make ye. So I just proved that because I proved that ym, watch. I just proved that ym is what? What's out of the whole thing?
A third of the whole thing.
Exactly. So yeah, that's it. It's a tough question, guys. Tough question.
So
I'll go
I
over
just want to ask something.
3 marks.
So,
3 marks.
So that two you get it right. That 2 would represent the 2/3 or something.
No.
How you end up getting that 2?
All right, let me show you something, right?
I understand everything to the point of where you get that 2 from.
2 thirds is just 2 multiplied by what?
A third.
2 multiplied by a third, right?
Yeah.
So I want you to recognize that there's a third here and there's a third here.
Mm-hmm.
If I were to pull out the third, all right, minus v, you understand or not?
All right. Okay, now I understand. Yes. Yes.
Yeah.
Now I've seen it. All right. Thanks.
No problem.
So you know is the biggest problem in this question, I find?
What's that?
The fact that we do everything in one diagram.
That is why I'm saying that real dosage. That's it, real dosage. How you expect the chair and them to do all of this in one diagram, boy? Yeah, but this is the answer, right? Because this is saying mathematically that ym is just what fraction of the whole thing. Ym is just is what?
A third YA.
Exactly. And can you see that visually? Can you see that ym is a third of the whole thing?
Yes, sir.
Okay, if you're not seeing it, look at it again, guys. Watch. 1, 2, 3. Out of the 3 parts, how much is the ym?
1.
1 out of the 3 parts. So didn't I just prove that? Didn't I just prove that ym is a third of ya?
Yes, sir.
Yeah, so that answers the question.
Okay, no problem.
Tough question. Yeah, once in a while, vectors will be kind of tough. Vectors will be kind of tough like this. Yeah.
Mm-hmm.
Is this like the hardest way that they could bring a question?
I would say this is up there with like hardest ways they can bring the question.
Okay.
Yeah. Yeah, for sure. So like when you read this, what does this mean in English? That is telling you that ym is a third of ye. That's what the way to prove really. But they're not telling you that though. You gotta know that. It's crazy.
So, can I ask a question? All right.
Yeah.
So, when I watched the part quiz, I saw what you did in the first part, and I immediately got the answer for that. But would I have to like, I didn't know like, okay, how to work it out, but I got the answer.
Okay. I need to let you understand something that ratios in vectors is very different. Like it different. It's a bit different. Like it is a bit different. Yeah. It is different.
Okay, so
Yeah. When we do some more questions, you'll see what I mean, that the ratios are a bit different. It isn't like how you typically think about it. So this is telling me, like when you read this, that tells me that ym is a third of ya. That's what it's telling me. That is what it's telling me. Yeah. Yeah.
Excuse me, sir. I
Yeah.
have a question. Right. So these vector questions, right? Is it like always, if you don't get the answer to the first question, like you will get the whole thing wrong? Or most of it
Most
wrong?
of it wrong. Most of it wrong. Most of it wrong. Most of
All
it
the
wrong.
time?
Yeah, all the time. Because the questions are correlated. So like they're like linked. So
Okay.
here what? Let me look at 2025 vector question. This one should be easier. I hope. Because that one kind of scale a bad boy. Kind of scale a bad.
Yes, sir.
Right? Again, as never lied to you, know. Never. Never. Right. In the diagram below, OPQL is a parallelogram. O to P is what? What is O to P?
R.
Oh, let's see. In that, O to P is R.
yes, sir.
And O to L is what?
S.
S.
Right. And they are saying that
S.
T, right. So they're saying T is a point such that P to Q is equal to,
Q to T.
okay, what I mean.
Q
That's
to
telling
T.
us, what does that mean, guys? That's telling me that PQ is literally equal to,
QT.
right.
QT.
And this is a parallelogram. So parallel sides in a parallelogram have the same what?
Length.
Same length. So I have a question. If this is S, what do you suppose this is?
S. S.
Right. This is S as well. And they literally told us that PQ is equal to,
QT.
so
QT.
so what would that be?
QT.
S.
S.
S. Yes. Okay. I didn't lose a little so far, right? Are you with me?
Yes, sir.
No, we here.
Okay, let me try to explain this part to you guys, right? They're saying the point P divides PL in the ratio 2:1. Let's try to understand. Forget about the ratio one thing, right? Try to understand it visually. Which one bigger, PM or ML?
PM.
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 Let me ask you that question, right? Logically, how much ML do you think it go take to make PM?
2.
2.
3.
3.
Okay? Those are saying 3, right?
2.
No, you go take 2.
Let's see what I'm talking about, right? Watch. This is ML, and to make PM, you'll need 2. So I hope you guys understand that. You guys understand that or no?
Yes, sir.
Yes,
So,
Yes, sir.
so what are they talking about here? What are they talking about here? And you could see that M divides PL in the ratio 2:1.
Yes, sir.
Because we could
Yes,
split
sir.
it, we could split this vector into how much parts?
3.
3.
And out of the 3 parts, LM is how much?
1.
1. 1.
Right, I'll be a third, and MP will be what?
2/3.
Because how much of the parts does PM have?
2.
2.
2/3. Good. I really hope all you understand that, you know. It's like the hardest thing to grasp.
Yes, sir.
Yes, we understand.
I'll run it back one more time for the people that don't understanding. Alright. So, Alia, visually, you could see that I could cut this vector into how much parts? How much parts?
3.
3. Out of the 3 parts, how much does this vector have?
1.
1. So that will be a third of the whole vector. However, this vector over here has how much of the parts?
2.
So this vector here will be 2/3 of the whole thing. Are you guys with me?
Yes, sir.
Okay, good. Let me continue, right? So I was understanding the question. So like with these ratios thing over here is just hot your head, right? Just try to look at it visually, please. It will make your life a lot simpler. Make your life a lot simpler. Yeah. And so let's see that it's much simpler when you look at it.
Yes, sir.
A
It's
lot
much more easier.
Yeah. So find in terms of R and S, P to L. We want to go from P to where? P to where?
P to L.
Right. I was waiting, you know. Right? So P to L. So if the whole vector is PL, right? The whole vector is PL. Then truth be told, PM is really just what? PM is really just what?
2/3.
2/3 of PL, man. Big up on yourself. And ML is really just
Sir,
what?
so
1/3 PL.
1/3 of
Yeah.
P.
Yeah. Somebody was saying something?
I was asking, wouldn't I have to go from P to O, then O to L? Or I don't need to do that this
That's
time?
correct. That's correct. Big up yourself. That's correct. I was just explaining something extra now, but
All
but
right.
the question is asking us how would we go
Okay.
from P to L? How are we going from P to L? Well, you'd have to go from P to O and then O to
L.
right. Now, this O to
Mm-hmm.
P is positive R, but we are going in the opposite direction. So what's that gonna become?
Negative R.
Negative R.
Negative R. And as you can see, we're going in the same direction here. So what's that gonna be?
S.
Positive S.
Good.
Positive S.
So P to L is really just what?
Minus R
Negative
plus S.
positive.
Right. Oh, there we go. That was hard. Or that was easy.
That was easy.
That was easy, sir.
That was kick, right? That was kick.
It was easy.
Right. Let me answer O to M now. O to M, boy. How we could go from O to M? Well, if they're asking me for O to M earlier, you know the first thing I'm gonna do? We think I should connect.
O to L.
Oh, some people asking me. Yeah, here it says. Some people asking me this. Somebody say, but question, can't you go from P to Q and Q to L? That's 100% correct. If you wanted, alternatively, you could have gone from P to Q and Q to L, as you would take it from P to L still. And that would have been S. And you're going in the opposite direction, so minus r. Same answer, s minus r. Minus r plus s. It's looking complicated earlier, but it's real simple. Like, are you understand why I say it looking complicated, but it's simple, or like, nah?
Yes, sir.
We understand.
Like, people on TikTok and saying, Ollie, watch this. We want to go from P to L. How are we doing that, Ollie? P to L. I could go from P to O, and I could go from O to L. But you see, the thing is, we're going in the opposite direction. So we change the r to negative r. We're going in the same direction here, so I'll leave it as s. Minus r plus s. If you wanted to do it another way, and you could go from P to
And that's the
Q.
answer.
Yeah, that's the answer. If you wanted to go a different route, and you could go from P to Q, and what next?
Yes, sir.
You tell me, after P to Q, what next? I want to go to L. What is it next?
Q to L.
Right. Now, I'm going in the same direction here, so I'll leave it as S. I'm going in the opposite direction here, so I'll change that to what?
Minus R.
Right, so S minus R. Isn't that the same answer as R minus R plus S?
Yes, sir.
Yes, sir.
Yes, sir.
Yes. So, different ways to answer the same question. Let's look at O to M now. How would we go from O to M? Well, the first thing I advise you to do, guys, is connect O to where?
M.
Right. Now, how we could do that, boy? Well, there's two ways you could do it. I see, and you could go from O to L and then what?
L to M.
L to M.
Or you could go from
O to P and then P to M.
P to M.
all you want to do.
O to L.
O to L
to M.
and L to M.
You want to look short.
I go explain something though. When you do that, you gotta change some signs. But I think I can handle it. I can handle it.
Yes, sir.
Right. And if I just put in this out right, in the first part, we found for P to where?
L.
Right. And we know that P to M is what? Is what fraction of the whole thing?
2/3 of PL.
2/3.
And we know that M to L is what?
1/3 PL.
Are they doing good, boy? Nice. Oh, let's see in with me. Nice. And we want to go from O to M. O to M. So how are we doing that? Well, we had to go from O to L and then
O
what?
to L to L to M.
L to M.
L
Wow.
to M.
But here's the thing earlier. So like, okay, O to L, I'm going in this Apple Pencil dead boy. Earlier, we're going in the same direction from O to L. Let's see in that.
Yes, sir.
Yes, sir.
Yes, sir.
So that will remain as what? What will remain as?
Positive S.
That would remain as positive S. Positive S. However, you go in from L to M. What you gotta do?
Excuse
Yeah.
me, sir. Where you
Yeah?
get 1/3 again?
All right. My Apple Pencil. It's a lifetime charge, right? Let me explain something. When you look at this vector, right?
Yes.
It looks as though you could cut it into how much parts?
2.
2 now.
1, 3. Wait. 1, 2, 3.
Yeah. Out of the 3 parts, right? Out of the 3 parts, how much is M to L? How much parts I have?
That'll be 1.
One out of, so it could be 1 out of the 3 parts of the whole vector. The whole vector is PL. The whole vector is PL, right? So this would be a third of PL because it's 1 out of the 3 parts. And P to M is 2 out of the 3 parts. So I say 2/3 PL. You understand? Okay,
Yeah, no problem. Yeah, I understand.
right. Earlier, let me finish the question, huh? So we know that this will be positive S. However, LM, that would be negative what? That'd be negative ML. Are you understand now or no?
Yes, sir.
Yes, sir.
No, sir.
I'll go it over again, right?
Sir, why is it doing so?
Anytime you go in the opposite direction, what do you do?
Sir, but isn't that up?
No, but here what I'm saying, right? Here what I'm saying.
Excuse me.
Wait, this was P to L, right? That was P to L. That's vector P to L. Are you with me, right? That's P to L.
Yes.
Yes, sir.
Right. P to M is also in a direction, but it's just 2/3 of PL. M to L is also in a same direction, but it's just a third of.
GL.
Exactly. So M to L is in this direction, where you are going in this direction. So instead of positive ML, it's going to be
Negative.
negative ML, because I'm going in the opposite direction. So now
Oh,
that
I
happens.
see, sir. I see.
So it's
Right.
still kind of confusing.
Yeah, no, it's just confusing. It's just confusing. I'll go it over one more time, right? What's your name? We will do it together. What's your name?
Jariel.
Jeriel? Okay. This vector is P to what?
P to L.
Right, P to L. P to L. Can we agree that P to M going in the same direction?
Yeah.
Yeah, but isn't but okay, PM going in the same direction, but it's just 2/3 of the whole thing. You understand that?
Yes, sir.
It's not the whole thing, it's 2/3 of the whole thing. But you understand it going in the same direction as PL.
Yes, sir.
Good. M to L, we're going in the same direction as PL, but it is what fraction of PL?
1/3.
Exactly. So ML is going in this direction. Yeah?
Yes, sir.
However, to go from O to M, we're going from O to L, and then L to,
M.
but L to M, is that in the same direction as ML or in the opposite direction?
The opposite direction.
So instead of writing ML, we're going to write?
Negative ML.
Yes. Yes. You understand?
Sir, question.
Yeah, kind of.
Yeah, it's confusing. I wouldn't lie, confusing. Yeah. I try. Yeah. Somebody asking me something?
Sir, is it because you already initialize P and M as positive 2/3, then going opposite way would just be negative?
Yeah, that's it. That's it, watch.
Okay.
P to M is in this direction. M to L is in this direction, but we go in the opposite direction. So instead of saying positive ML, what we go say?
Negative ML.
Yeah, negative ML, because we're going in the opposite direction, guys. There's an easier way to work the question, and I think I would prefer that. If you go the other route, you wouldn't have to do no change of sign or anything, because you're going to be going in the same direction. Are you seeing that?
Yes, sir.
That'll be easier, I think,
Yes,
for
sir.
you. But let me continue. No, a lot of people are going to be confused. I know. But I try my best to. But like, I know a lot of people. I'm going to lose a lot of people. Right? Because it's like a real lot of thing. Okay, so let me continue. So if I want to go from O to M, first of all, O to M is, well, we have S,
S.
right?
Positive M.
And then we have minus ML. Minus ML. Now here is the plan.
Mm-hmm.
We know that ML is what?
Third, yeah.
1/3.
1/3.
Right. Do we know what PL is?
Yes, sir.
Yes, sir.
Remind my guys.
Minus R
Or
plus.
negative R plus S.
And so now we expand, right? If you're confused, right? Again, ML is in this direction, but we go in the other direction. So instead of writing ML, we go right?
Negative ML.
Negative ML.
Just because we are going in the opposite direction. That's all. That's literally it. It's looking complicated, but it's simple, right?
Sure.
And yeah?
But why are we multiplying negative 1/3 by negative R plus S?
Okay, what is ML? What was ML?
1/3.
1/3
1/3
what? 1/3 what?
of PL.
Right.
Oh.
And earlier, we found that PL was?
Negative R plus S.
Yes.
Okay.
So instead of because they want the answer in terms of
PL. Well, R
I'm
and
on
S.
this. So you need to convert ML to a third of PL. And PL is just what, guys?
Negative R plus
Negative
S.
R plus S.
Yes. So now you have to expand the brackets.
Okay, no problem.
So negative a third by minus R. Have a negative by negative. What's a negative by negative?
Positive.
A positive.
Positive.
And well, that's R. And then you have minus a third by S. What is minus a third by S?
Minus 1/3 S.
Yes, minus a third S. Now you're not seeing the coefficient, but it's there. This, what would the coefficient for this be?
1 positive 1.
1.
Positive 1. So we have 1s and negative a third s. So in the calculator, quickly, you could put 1 minus a third. What's 1 minus a third, guys?
2/3.
2/3.
2/3, yes. So it's going to be 2/3 s plus a third r. Yeah. Now, would you guys like to see the other way to work the question that I think would be simpler?
Sir, can
Yes,
you
sir.
please
Right. I know I'm gonna lose plenty of people with this question, but I don't feel like I could do much. Like, this question is like a higher level question, and it testing like a lot of your innate abilities. Plus, like, we real tired and things too now. I'm real trying to explain things. So here is another route you could take, right? If you're not talking, mute yourself, please. Right. So we wanted to go from where to where? Where to where?
O to M.
O to M. O to M. So I'm gonna draw a line connecting O to
M.
Good. Because we want to go from O to M. O to M. That's what we want to do, guys. Now we need to figure out what's a way we could go from O to M. Well, you could leave O and you could go to P. And then from P, you could go to where? Where could you go to?
M.
M.
Yes. P to M. Let's run it back one more time. We are going to draw Fat Man Bob. How much weight do you think Fat Man Bob lose by?
He's skinny.
This is Bob. But this is Bob now. Wait, boy. Bob really lose weight, boy. So here what I'm saying. Wait, let me just drop Bob somewhere else. Ollie, big up Bob now. Drop a W for Bob in the chat. Bob lose real weight. Big up Bob. One time. Big up Bob one time, boy. Are you giving Bob no love? Man, lose some weight, boy. Weight loss journey, let we go. Alright, this is Bob. Bob want to go from O to
M.
Right. You want to go from O to M. To do that, he's gonna go from O to
P.
and then P to
M.
Right. And he would have reached and he would have went watch. Well, have you seen it?
Yes, sir.
Right, watch. He started at O, he could go to P, and then from P he can go to M. Yeah. I think Bob should eat some food. He looking a bit too skinny. I remember how fat Bob was. Yeah, Bob lose some weight. So let me go through this method, right? If I'm going from O to P, then we're going in the same direction R. Will the sign change?
Nope.
No, sir.
No, sir.
No. And then you're gonna go from P to M. Now, do we know what vector PM is in terms of PL?
Yes, sir.
Good.
PM is just 2/3 of what?
PL.
PL.
Are we going in the same direction as P to M?
Yes, sir.
Will we have to change any signs?
Nope.
No, sir.
No, we won't. We won't. So this is a simple route. And so if I want to go from O to M, it's just going to be, well, positive R, plus 2/3 PL, right? If you're confused, right, here what I'm saying, guys. You know, I should put the full work in and done. Let me not confuse nobody. Here what I'm saying, right, guys? Can everybody see that to go from O to M, you'll have to go from O to P? Are we going in the same direction?
Yes, sir.
Yeah. And P to M, are we going in the same direction as P to M, which we know?
Yes, sir.
Right, so that remains as 2/3 PL. Do I have to change the sign?
No, sir.
No, I don't have to change the sign. My Apple Pencil just died again. Oh. I'll crash out now, guys. Let me see if the fake Apple Pencil will work. Give me a second. Why the fake Apple Pencil not working, boy?
Was it fake?
That's true. That's a good reason. That's a very good reason. Give me a second. I just gotta disconnect the real Apple Pencil. Okay, working now. Let me go. We're not sticking though. We're not sticking. We're not sticking. Right? So earlier, one more time. R. Then P to M. P to M is 2/3 PL, yeah?
Yes, yeah.
Do we know what P to L is?
Minus R plus S.
Negative.
Minus R plus S. So we are going to write. Oh, the fake Apple Pencil having a hard time, but you're writing real bad. Okay. Yeah. That'll be R. And P to M was what again?
Minus R plus S.
No, that was PM. Wait, watch
So we're
it.
not seeing there right now.
Oh, they're not seeing? Oh, my bad. Come on a second. How do I get like my equipment can't last my endurance. Like it can't keep up with me, you know what I mean? Like you
I
just imagine
mean,
just
like,
imagine we're doing 40 hours on March now, boy. Just imagine we're doing 48.
like boss man, them equipment here last will go 24, 48, and 72 hours and also.
Well,
You just overworking them equipment here, that boy.
they're ready for me, boy. They're ready for me.
So
So
somebody that's it as a sign.
no, that is not no sign. That no sign. Hey, Olio. That not no sign. P to L. Where's P to L again? P to L is minus R plus S. Let me get rolling. Brawling math vibes, brawling maths. So minus R plus S. So here what happening, right? Here what happening. We know that PM is 2/3 of PL. Yeah?
Yeah.
Yes,
So I go into write 2/3, and instead of writing PL, I'm gonna write one instead.
Minus R plus S.
Right. We're gonna expand your brackets now. So 2/3 by minus R, and then 2/3 by S. What is 2/3 by negative R?
Minus 2/3 R.
Right? And then we have 2/3 by S.
2/3 of S.
Right? So again, you're not seeing it, but what's the coefficient of this?
1.
1.
1R. Because earlier, I know you were trying to trick earlier, right? How much R do you see in here?
1.
1R. Like it
1R.
literally just seeing 1R. So 1R, right? 1R. I can't explain it simpler. And so you have two R terms. So you're gonna say 1 minus 2/3. What is 1 minus 2/3, guys?
1/3 R.
Right. 1/3
1/3.
R. And this should be the same answer we got last time. Bam, badness. Watch. Yeah. Isn't it the same answer? In terms just like different, but like, yeah, watch. Same answer, guys.
Yes,
Same
sir.
answer. What do you prefer? This or the other method?
This method.
This one.
Okay, well, I will just put this as the default then. This should be like this. Okay, this should be like an eye-opening experience. Anytime you're working with vectors and you're dealing with a complex vector, do you want to go against that complex vector?
Nope.
No. So try to figure out how you could go in the same direction as it. So you wouldn't have to do nothing complicated. So again, if you're dealing with a complicated vector, are you going to try to go in the opposite direction to it or in the same direction to it?
The same direction.
So you wouldn't have to change
the sign.
Exactly. This was a tough one, boy. But big up all yourself for powering through, though. Big up all yourself for powering through. Big up all yourself for powering through. Right. Let's move on. Prove that points OM and T are collinear. Bro, what does collinear mean? Collinear just means that they're on the same what? They're on the same
line.
Same line.
On the same line.
And for it to be in the same line, the vectors we must be able to write them as a scalar multiple of the other. So like something like U is equal to KV. And the vectors must have a what in common?
A same point, like a point.
Same point.
Common point. So we must be able to write them as scalar multiples, guys. Scalar multiples for sure. That's a must. And it must have a common point. Must have a common point. Let me tackle this, right? And I'll let you see how bad maths is, right? Check this out. Check this out. We're talking about OM and T, yeah? OM and T. Let's see now. OM and T.
Yes.
Watch badness. And they already looking collinear.
Yes, sir.
Yeah, because what does collinear mean?
Same line.
Same line.
Aren't these points on the same line?
Yes, sir.
Yes.
Yes, sir.
But that is not enough for them. That is not enough for CXC. They want mathematical proof, which is not bad. We could figure this
Oh
out
God.
easily. We could figure. Oh, yeah, don't say oh God, Auntie. We can figure this out. We could figure this out, guys. Don't get scared. Here what? Here what? Right? Remind me. What is the vector is? What's this vector?
S.
Right? What's this vector over here?
S.
S.
Well, let me ask you a question. Right? What's the entire vector here? O to what?
O to T.
O to T.
If we could show that if we could show somehow that OM wait, I'm saying if I could show that OT could be represented as a scalar multiple of OM, and they would prove that they're parallel.
Yes, sir.
Yeah.
Yeah.
Yes, sir.
Yes,
Wait,
sir.
just by observation, how much OM is it looking like it would take to make the whole vector?
3.
3. I hope I can see that. I hope I can see that. Yeah? Let me run it back again. I'll run it back again. I'll run it back again. If I could somehow show that I could represent OT using OM, it would make it a scalar multiple. It would make it parallel. Just by observation, guys, how much OM do you think it take to make the whole vector?
3.
3. So here what? We should probably find for O to T, and we should probably find for what other vector?
O to M.
O to M. O to M. O to M.
Okay.
If you're confused, right here what I'm saying, vectors are scalar multiples when you can write one in terms of the other one. So like, so guys, just from intuition here, I'm trying to end up with something that looks like this. So I want to get something that says OT is how much times OM. What do you think that will be? The end answer. OT would be how much times OM? 3. 3.
3.
Actually, I'm not trying to trick all you know. It like in right in front of you. How much OMs it would take to make MT?
3.
3. So if I could prove that the whole thing is just 3 OMs, then I prove that it is what?
Collinear.
Not collinear per se, but parallel. The last step is that both of them have a common point. I never see it now, but both of them starting at what?
At O.
Yeah. So here I know a lot of people are gonna be lost, but for the few people that lock in and they like understand and big up on yourself, watch back the video, and I'm sure you will understand. You just had to stay with me. Okay, so let me find vector O to T now. Okay, O to T. How are we doing that, boy?
O to P.
O to T. How are we doing that? So I can go from O to P. What next?
Q.
P to T.
Right. That was hard or that was easy?
Easy.
It was
Easy.
Right. So O to T. Let me ask you that question. Are we going in the same direction as O to P?
Yes, sir.
Yes,
right.
sir. Yes, sir.
So same sign, guys. Same sign. And we're going in the same direction here. So that's one S. And then we have another S. So this whole thing will just be what?
2S.
2S.
Right. Because to traverse P to T, how much S's that take?
2 S's.
2 S's. Good. So O to T is just R plus
2S.
That is all, guys. That's all. Nice. That was real simple. That was real easy. So now we need to find for O to M.
So, and you already solved for OM?
Let me see. Yes! Alia. Oh, Alia. Our life is so simple, boy. Alia, watch. And we find OM to be this. Wait, I'm looking at something. Yeah, it will be better to use this. Yeah. Badness. So and we find OM. This I follow not talking, mute yourself now. Right? Didn't we find OM to be a third R plus 2 thirds S?
Yes, sir.
Yes, sir.
Let me show you badness, right? Let me show you badness. So we could either prove this, or we could prove that OM is what our OT.
A
Let me see how
scalar.
bad. Wait. Let me see how bad all is, right? So I'm pretty sure I'll understand this. That it would take 3 OMs to make OT. I think I'll understand that. But if you're thinking about it differently, OM is what fraction of OT?
A third.
1/3.
Third.
So, and I could also say OM is a third of OT.
Yes, sir.
Yes, sir.
That's actually the easier one to prove. Let me show you why. Oh, it is real easy. All your habits. I know all your habits. Are you seen anything we could pull out here? What we could pull out here, guys? What we could pull out? What we could pull out?
We wanted R.
A third. If I pull out a third from a third R, what go right?
R.
If I pull out a third from 2 thirds, what go pull out?
2 from the S.
Alia, I know I see R plus 2S somewhere, you know. What is R plus 2S?
OT.
Right. So just like that, we would have proved that OM is actually just a third of
OT.
And since I've wrote it as a scalar multiple, it means that they are
Collinear or
parallel. What tells you it's collinear is the fact that they have a common point and they're parallel. This over here is just telling us that it is parallel. But we know it's collinear because both of them have what point in common? Both of them have what point in common?
O.
Yeah, both of them have point O in common. So I'll go over it again, right? To prove that two vectors are scalar multiples, I need to be able to write one in terms of the other one. When you look at this vector over here, how much parts do you think I could cut it into?
3.
3. Out of the 3 parts, how much is OM?
1.
1. So OM would be what fraction of the whole thing?
A third.
Right. So enter could say OM is just a third of OT.
Yes, sir.
But and I need to mathematically prove that I can't just pull out of a hat, right? I need to show that, right?
Yes, sir.
So what we do was we found for vector O to T. That was easy, right? That was real easy. That was just R plus 2S. Yeah?
Yes, sir.
Good. And then we're looking at OM, right? We're looking at OM. And then the last question, we find OM?
Yes, sir.
Right. Mask that question, right? When you look at a third R and 2 thirds S, what it look like it could pull out?
The 1/3.
The 1/3. Okay, if you okay, I think you guys could understand how I get R here, yeah? Because watch. I have a third R plus 2 thirds S. I pull out the third, so I just write R. That makes sense, right?
Yes, sir.
Now 2 thirds is just 2 multiplied by what?
1/3.
A third.
And if I pull out a third, what will leave? What do I be left with?
2S.
Right. So I say a third R plus 2S. No, R plus 2S is just what?
OT.
OT.
Right. So I just proved that OM is just what fraction of OT?
1/3.
A third.
Right. And can you see it visually? Can you see that OM is a third?
Yes.
Yes, sir.
Right. And so this is the final statement. Gosh, man. What happened? Anyways, I write the statement somewhere to the bottom. I would say since OM is equal to a third OT and they have a common point. What's the common point?
O.
Right. If you are confused, look, watch, right? This is O to M, and this is O to T. And where both of them starting from?
O.
O. So they have a common point O. So since OM is equal to a third OT, and they have a common point, they are what? Right, you would say, and they have a common point. O, M, and T are what?
Collinear.
Right. Are they understand now or no?
Yes, sir.
So like, when we talk about collinear, scalar multiple and common point. That's all. That's all. This is a tough question too. Vectors scaring all everybody. Yes, you see, this is the hardest thing we've done so far in our lives. Everything else has been straightforward. You know, I show you it, you apply it, you get your marks. But this requires you to think outside the box. Yeah. I'm gonna do one more vector question. And we call our night.
Excuse the N2 was and then one.
Ale, relax now, relax.
So it's you again in trouble and remember you have a bedtime.
Brawling mathematics, guys. Brawling mathematics. Again, Mrs. Math Vibes go understand that, you know, I'm trying to improve educate math literacy in the
So what you
Caribbean.
doing tomorrow?
Eh? I doing whatever all I want. It's fine, whatever all I want. I just here helping all you right through. Whatever all I want help with, I helping all you with. Yeah, I don't have like a fixed schedule.
So we could do 2024.
2024. That was harder one. You
My
mean
rule enough.
I Stefan. Take care.
Yeah, later, fellas.
Later, bro. Take care.
Right.
Right. So guys, which other vector question I want to do?
Somebody say 2024 just now.
I think she meant like the whole paper tomorrow, but yeah, we can look at 2024. I
No,
presume
I
only
meant you vector question.
oh, June, right?
Yeah.
I bet. Will this be any easier? Let me see.
So every year I guaranteed vector question just come.
Yeah, boy. Again, honestly, like I promise you, like I could turn to any year and I do these solutions already. Promise. Alright, let me go. This looking easier, much easier actually. Because it don't have any other ratio and thing in it. Alright. Anybody wanna help me? Who wanna help me with this? Who would help me with this?
So I could help you.
Sure. Get the question I read for me.
In the
Sir, what
pentagon,
year?
This is 2024, but don't interrupt somebody when they're talking, right? Yeah, continue reading the question.
in the pentagon OABCD, OA is parallel to DC and AB is parallel to OD.
Wait,
OD is
before we do anything, can you see that visually? Can you see that OA and DC are parallel?
yeah.
You see that like you're unsure. You know what parallel means?
Yeah, I can see it parallel.
Good. I ain't judging you or anything, you know. I'm just asking straight up if you understand what I explain. It's fine. Right? So, parallel. Can you see that AB and OD are parallel?
Yeah.
Good. And they're saying that OD is what?
2AB.
Okay, what does that mean? Let me pause for a minute. OD is 2AB. What do I mean? Well, we know that tell me.
It takes 2AB to make up OD.
Perfect. Perfect explanation. And we know that AB is what? What is AB?
B.
Right. So OD in other words is just what? OD in other
2B.
words is just what? 2B. Right. So instead of writing, so we're gonna write for OD.
2B.
Are you understand now or no?
Yes, sir.
Right. And they're saying that Telma, what's your name by chance?
Maya.
Maya? Okay, no problem. So OA is 2DC. What I mean?
To get OA, you need to put 2C. You need to get 2C to make up 2 OA, sorry.
Right. And so we know that O to A is what?
A.
Right. So here's a question for you, right? Logically, what do you think the answer is, boy?
DC is equal to half A.
Yes, half A. Because watch, check this out, right? Maya. We know that O to A is A, right?
Mm-hmm.
So to find for DC, you can divide by 2 on both sides. And so you go see that DC is just what a A.
A half A.
But you don't have to do all of that, you know. You can look at it and see it. All you look at it, right? Look at it with all your eyes. A is this. This is DC. It sort of looks like DC is what of OA.
Half.
Half of OA.
Right. So if O to A is A, wouldn't half of that be a half A?
Yes, sir.
Yeah.
Yeah. Yeah. Right. So Maya, we want to find A to D. So A to D. How I could go from A to D? I want to go from A to D. How I doing that, boy?
You could go from A to O, but you'd have to change the sign.
Right. I could go from A to O.
And then from O to D.
Right. So, you see that I'm going in this direction here. Like you said, guys, can you all see that O to A is positive A, but we're going in the
Opposite
Opposite
direction,
direction.
negative A.
you change the sign. Over here, though, we're going in the same direction, so it's going to remain what?
Positive.
Positive.
Right. So A to D. What is A to D going to be? That's just going to be negative A what?
Plus 2B.
Right. Negative A plus 2B. Hope you guys with me. That was easy or hard?
Easy.
Easy.
That was an easier one. Now B to C now. We're gonna go from B to C. B to C, boy. How we doing that? We're gonna go from B to C. How am I doing that?
You're going from B to A.
Then A to O, then O to D, then D
And
to
then
C.
D to C.
Now I'll tell you this, right? We just find AD, right? We just find AD.
Yes, sir.
So if you wanted, then you gotta go from B to A to D to C.
Yes, sir.
And you're
Yeah.
get your answer in one shot, right? What do you wanna do?
A to D.
So we can just say B plus C.
Well, here what's it? I feel like this easier logically because this could be negative B, right? This could be negative A, so you have negative B, you have negative A. And then this is 2B over here. And then this is half A. What do you prefer?
Please excuse me.
Yeah?
You could go back how you find D, because I kind of miss out on that day.
It's something real sleepy boy. Way. Hey boy. It's like a mash up.
I actually fell
Mash
asleep
up
during
we.
that part.
Hey Olia. This is what we call a crash course, you know, like crashing out. Crashing out. Yeah, we want to explain for you again?
How, hold on. Yeah, how you find D?
You mean A to D?
Yeah, A to D, sorry.
Alright. So if I want to, I'm gonna call back Bob, right? Bob said he wanna lose more weight. At this point, Bob like real skinny. I feel like he should stop trying to lose weight. But he continuing. If I wanted to go from A to D, right?
Uh-huh.
I could walk from A to O, and then what?
O to D.
Yeah. Now, if I'm going in A to O, it's in the opposite direction.
Which is going to be negative.
Yes. So negative A. Then we're going to go in this direction, which aligns with this direction. So same direction, 2B. So minus A plus 2B. You understand?
Yeah.
All right. So yeah, tell me what they want to do. Are they want to move from B to A to O to D, D to C?
So if I'm being honest, B to A and A to D look a little more simple.
Yeah. And it's just like it'll be negative.
Yeah.
B to
Are they fine? Are they want to use this or not?
Yes, sir.
Yeah, let me use it now.
I don't think it's hard at all, yeah. I think they can figure this out. So we're going This how we gotta move, right? Yeah or no?
Yes, sir.
Yeah.
Right, so we're going in the opposite direction here. So that would turn to what?
Minus
Negative.
B.
Right, we're going in the same direction here. So we gotta know if we gotta do no funny business. And if you know what AD is?
Yes, sir.
Yeah.
Yeah, this is what AD is. So we gotta do no funny business, same sign, everything nice. Then we go in here. Same sign or different sign?
Same
Same
sign.
Same sign.
Yeah, no funny business there. Same sign. So it's real straightforward, I would say. Well, probably wouldn't say straightforward, but I think y'all could figure it out. So B to C. B to C is negative B, right? Negative B is this part. And then A to D, right? A little bit more, no?
Yes, sir.
Yes, sir.
Yes,
Right.
sir.
Can you guys remind me what A to D was?
Minus A plus
Negative
plus
A
2B.
plus 2B.
Right, negative A plus 2B. So far we've covered this and we've covered this. What else do we have to do?
You have to add in half of A.
Half A.
Right, I need to add the half A. So we are looking out for like terms, right? So we're looking at all the A terms and all the B terms. So I see in minus A and I see now half A. So anybody want to tell me what I would simplify to?
Minus a half A.
Right. If you are lost, you're not seeing it, but this really means minus what A?
1A.
1A.
Yeah. So you have minus 1A plus a half A. So all you had to do in your calculator is just put negative 1 plus a half. Where's negative 1 plus a half, guys?
Minus a half.
That is all. That's literally it. And for the B terms, we have negative B, which again, negative B means negative 1B.
1.
So
you
it
have
must be 1B.
right. That would just be 1B.
So that would just be B, I guess.
Yeah, that would just be B.
Yeah.
Right? So in the calculator, all you had to do, just put negative 1 plus 2 if you're confused. Where's negative 1 plus 2, guys? What's negative 1 plus 2? Negative 1 plus 2.
Positive 1.
Positive 1.
Right, and that'll be 1B. Which we could just write as
B.
right. So minus a half plus B. That's the answer. Right, somebody said they're lost. I see somebody on YouTube like, okay, that's the thing with vectors. I like can't blink, you know. I like can't blink. If you blink, you're gonna get lost. So I'm gonna explain it back again. Guys, we wanna go from where to where?
B to C.
B to C. How are we doing that, sir? Are we starting from B? From B, we could go to A. From A, we could go to D. And then from D, we could go to C. And that would essentially take us from B to where? B to where?
B to C.
Right. We're going from B to A, right? That's in the same direction or opposite direction?
Opposite.
Opposite direction. So the sign going to change.
Put negative B one time. We're sticking for. Put negative B one time. Then we go in A to D. Right? In the first part, we found A to D. We found A to D. We find it. And we see we're going in the same direction. Will anything change?
No, sir.
No, because you're going in the
Same direction.
right. So that is just negative A plus 2B. We do have a hot we had about that. And then you're gonna go from D to C, which we know to be a half A. So all you have to do is just combine everything now. So I say negative B minus A plus 2B half A. Minus A plus a half A is
Minus a half A.
and minus B plus 2B is
B.
B. And that's the answer. That's it.
But still, vectors looking like food.
I wouldn't say looking like food, but I'll say it's one of those things that you don't really have to revise for. Like here what I'm saying, right? Hear me out. You know how a lot of things you have to memorize formulas learning for? Like you could come into a vector test, and well, and you could and just see how to read off the directions. What I'm saying is you could figure it out in the exam. Like this is like heavily reliant on your problem solving skills. Like, did we use any formulas over here, or like we just read off the diagram?
Just read off.
We just like all you had to do is not get overstimulated, which is hard. I know we're looking real complicated, but if you could like pass like that, it's not hard, but it looks extremely difficult. I know. I can relate to it, you know. I'm not saying it's like the easiest thing in the world, but I'm saying if you're lucky, you can figure it out. Right. Part 3 states the conclusion about the magnitude of AD and the magnitude of BC that can be drawn from your responses in 1 and 2. Right. So guys, do we know what A to D is?
Yes, sir.
Yes, sir.
Now before we even do anything, right, let me ask all that question. We are comparing AD and BC. So we're comparing AD and BC. First of all, them vectors looking what?
Parallel.
Them looking at parallel, right? Them looking parallel. They're looking parallel. You can see that with your eyes. And well, they just ask us for the magnitude, right? So they want us to talk about size. So let's do that quickly. So to answer that question, here we're going to do, right? So stay with me, right? So this is not hard.
So it's 2 times?
Yeah, yep. See, look how they're figuring it out by themselves. You know hard? And B to C. B to C is minus a half A plus B. So let me ask all that question, right? What would I have to multiply BC by to get back AD? Wait, I forget something. I forget the minus a half. Wait, let me show you something, right? If I were to multiply BC, wait, if I were to multiply this entire thing by 2, can anybody tell me what you might get?
You get negative A plus 2B.
Right. Let's see now. No.
Yes, sir.
Yes, sir.
Okay, good. So here what I was saying, right? Let me try to fix up that. So we know that BC is equal to minus a half A plus B. So we need to multiply BC by how much to get AD?
2.
Right. So in other words, 2BC would be equal to what?
180.
Right. And if you're confused, here, watch it good. If I multiply BC by 2, wouldn't I get AD?
Yes, sir.
Yes.
Because what is 2 by negative? What's 2 by negative a half? What's 2 by negative a half?
1.
Negative. And what is 2 by B?
2B.
2B.
Right. So in other words, isn't 2BC literally AD?
Yes, sir.
Yes, sir.
Yeah. So what do you think bigger? BC or AD?
80.
Right. Because to make AD, how much BCs I need?
2.
Right. Pick up on yourself, buddy. And so what could I state about the size? They wanted us to state a conclusion about the sizes. So I would say that AD is how much times bigger than BC?
2 times.
I'm going to go over it one more time because I understand some of you are really confused. Right? I don't like to leave people confused. So one thing I don't like to do is that. So let's stay with me, right? So just looking at it visually, right? Just looking at it visually. It sort of looks like AD is how much BCs?
2.
2. I hope you all can see that, you know. Look, BC is literally just half a what?
AD.
Right. And we're trying to prove that mathematically. So to do that, you need to look at the vectors. So A to D, where's A to D, boy? A to D is negative A plus 2B. And we know that BC is equal to negative a half A plus B. So my question is, guys,
So you forget the A.
keep forgetting the A though. Why doing that, boy? Why doing that? This is not the first time I forget the A, you know. It's not the first time I forget the A. So let me ask you a question now. If I wanted to get back AD, what would I multiply this by?
2. 2.
Can you all see it?
Yes, sir. Yes, sir.
So what if
Right.
you just divide it?
Here, what, right? Another way you could do the problem is you could actually pull out negative a half from this. But I feel like it might be a bit more complicated.
Yeah.
Yeah. Okay, but I can show it quickly, but it's gonna be a bit more complicated. If I pull out a half, from this, right? I'd have to put negative 2A here. Yeah, this is gonna be more complicated.
So I think you shouldn't do that. You might just tie up them.
Yeah,
So
I
if
think I
I
might
be
just.
honest with you, I just divide AD by BC and I get 2.
All right. Well, look at it, eh? Look at it, guys. What would I have to multiply BC by to get back AD? That's what I'm asking earlier. If you're confused, what would you multiply B by to get 2B?
2.
2.
Right. What would you multiply negative a half to get negative 1?
2.
So I hope you could see that AD is just 2 BCs. And if you're trying to prove that, that's not a problem. AD is just minus A plus 2B, is it not? And that's AD, right? I'm not trying to trick you. That's AD. That's literally AD. And BC is negative a half A plus B. If you multiply BC by 2, what are you going to get back?
80.
Exactly. What is 2?
Minus A plus 2B.
Exactly. 2 by negative a half is negative 1. So that's going to be negative A. And 2 by B is just 2B. So I hope you guys can see this. This is like the easiest proof I could think about.
Yes, sir.
Might be a bit more complicated.
Yes, sir.
Another way you could do it potentially, but this might confuse some people. You could pull out 2 from this. But I feel like that might confuse because it is a higher level thought process then. If I pull out 2 from this, that'll be negative a half plus B on the inside. For those of you guys that see it, or like can see it or not. If I
Yes.
pull out 2 from this.
Yes, sir.
But I feel like for most people, easiest thing here is to prove that AD is just 2 BC. All you understand that part at least?
Yes, sir.
Okay. So by showing this, you are proving that AD is how much times BC?
2.
2 times.
So AD is 2 times bigger than BC. All you understand that or no?
Yes, sir.
Generally speaking, all the drawings are typically close enough to scale where you can see it. But you need to show the mathematical proof for it. So I see it. You need to. Otherwise, you're not gonna get your marks.
So how you gonna work? Like, okay, no bother.
What's that?
I say like how I was going to word it. But you just put in the equation.
Yeah. This is your mathematical proof, you know.
Okay.
If you could say that AD is 2 BC and you could prove it, then you're literally telling them that AD is 2 times bigger than BC. Yeah.
Yes.
So that's it for vectors, boy. Vectors was a rough. I was a bit brain intensive. Yeah, boy.
So you have so like what topics are you doing tomorrow? Everything?
I'm just doing the topics I only ask. Like,
So you could do measurement.
I feel like a lot of people want to do measurements, and measurements was in the agenda today, but bearings and vectors take up all of that time. So yeah,
how about matrices?
yeah, we could do that.
Excuse me, can you complete in the square?
Completing the square, no problem. I could do that.
Excuse me, you have any odd maths marathons?
Yes. As soon as maths finish, every day is odd maths.
So what about physics?
After odd maths, every day is physics.
No break for you, sir.
I literally tell you that after the 7th of May, I gotta be there every single day till the end. I'm a man of my word. I say I gotta do something, I gotta do it. You know what I mean? So
I really appreciate that.
yeah, no problem, no problem. We had to pass them. We had to increase the pass rate, buddy. Maths kind of real dim. Like unless
Yeah,
you pass rate
that's
maths.
32%, and I increased by at least 50.
Yeah. I trying to tackle that because if I realize, right? A lot of people need in-depth explanations. Most of the videos there is like real fast paced and like only like the top 1% go actually understand.
Yeah. Mm-hmm.
Which is like sad because that them would have been churn I would have passed anyways, right? So
Agreed, sir.
I feel like people for that pass rate to go up, people need like real in-depth explanations to like see how everything works. Yeah.
So our next question. So let's say you do good on your SBA and for people when you get like 55, like how much marks do you need to get one on average?
I can't tell you that now because CXC does never reveal the pass, the grade 1 mark or the thresholds. But I'll tell you this, right? I'll tell you this. Here what I'm saying. If you do good in the SBA and you do and okay, paper 1 is just repeat. I'll tell you that no.
Yeah.
Paper 1 is just repeat. And I have a playlist that's is everything you need to know for paper 1. I have physics, art, maths, and maths. Everything you gotta know. I don't know why it's at 315 views. I had to go up, right? But everything you need to know right here. The paper 1 is just repeats. You could easily get full marks on that. And that would contribute to the percent of your final grade. Where you getting your SP?
Me?
Yeah, where you getting your SP?
18.
18, that real good. So if you get close to full marks in your paper 1, it's like 28. Let me just say you get 28, right? Like 28% now. 28 plus 18.
Yes.
Then you're technically 4 marks from objectively passing. I think you can rack up that marks in paper 2.
Okay, sir.
I would at least aim to get above 50. Because that's like a technical pass. Right?
That's it.
We're not aiming to just pass, I want to aim to excel. Aim amongst one of my students say this, aim for the space, aim for space. So if you fall, you're floating. Partners, that was tough. That was tough. And then, yeah. Right? Hear what? People saying I understand in class, but can't understand on the paper in exam. Well, hear what? As soon as I feel like I understand something, all you need to immediately practice. That is what. That's what most people don't do. They go like, come to my class, and they go feel like they understand, and they go think that's enough. No, that's not enough. You need to do practice by yourself. And that's like the extra part of the equation people don't do. You gotta do your own work. Right? Real people raise on their hand, boy. Way. Yeah, Marisha.
Hello, sir. I have a question.
Talk to me.
I don't think everybody knows this, but because Jamaica was like affected by the hurricane and everything, like my schools or some schools in Jamaica got the option to choose between doing both papers or one. So I'm asking you if do you think it's such like a high chance that CSET might like increase the difficulty level for paper
No.
one since
Paper
that
one will just be repeats. Just repeats. I tell
so how do you think
I could swear my life. You know why I'm telling you that? You know why? Because in 2020, right, when I write CSEC maths, it only had paper ones because of COVID, right? Marisha, you would think they'd change things, right? You would think they would change things, right? Because it's just paper 1. But no, it was just repeats. It was just repeats. Never changes.
so how do you think the kids who are doing paper one would like learn or how would it test their knowledge effectively?
It wouldn't. It wouldn't. When I wrote in 2020, some of the most top performing math students in my class got like 2s and 3s and had to query it to get a 1. Yeah.
Okay, sir.
That was horrible. That paper 1 alone is horrible. That's why I say it. Don't wish for paper one. Don't wish for the paper to get leak, you know. Because hey, you spend like 5 years of your life. Your parents spending money. Right? You going lessons. You invest in time. All for the paper to take a scrap. You know how much money and thing you're wasting.
So,
I don't
but
think.
if this paper one just repeats, that like easier to just learn it off.
Yeah, but sometimes it might change a word or two. So you should probably understand how the questions does work. Yeah.
True.
So if they change up something slightly, you know what to do. But generally speaking, it's the same kind of thing. Yeah.
But still, good day. You enjoy your night.
You have a blessed night, man. Take care. Right. Maya, I'll see you here and talk to me fast.
So just to be sure, after we do all the paper twos, you're still going to be live for paper ones as well?
Although don't understand. Wait, when I tell her that I'll be there after the 7th of May, that's what I mean, you know. Like, I'm gonna be there all, yeah, right through paper one.
Okay.
Everything.
Okay.
They don't know mass vibes to the world. Right? I see Annie Rishian. Annie, talk to me fast.
So I was just wondering if tomorrow we could do matrices.
Sure, no problem. We could do a bunch of matrices tomorrow.
Okay, thank you.
No problem. Tira, see you raise your hand.
So this is it for tonight. And what we doing tomorrow?
Yeah, so what are we doing tomorrow?
Yeah.
I just doing a bunch of questions really, but I feel like I definitely want to cover matrices. I seen a real asking for matrices and measurements. So matrices and measurements for sure. For sure.
And what time is starting?
Probably 4 p.m. for the latest. Yeah.
Okay.
Right? Let me stop share.
So, but I thought the people and them who wanted to sing was here for singing. I didn't really see nobody to sing.
I see nobody. I gotta sing for myself. I gotta sing for
Real,
myself.
for real.
They look like they knock out. They
I
knock
feel
Yes,
out early.
everybody knock out. I real see them wanting Michael Jackson.
Everybody
Yeah, but
knock out.
remember, some of
It's
them
not
have
my
exams
lover.
tomorrow
She's
as
just a
well. So,
girl.
like,
Sing 30 in honor of Romano and Hania.
Are we gonna sing for them, buddy? What do you want to we to sing for them?
They wanted us to sing 30.
Is it
Diana.
Diana? All right. She said, what did she said? I'm all right.
Hey,
So let me get you
your music class too, eh?
wait, let me get you right. Wait,
I don't
wait,
know that song. Wait, I had to look up the lyrics. Wait.
wait, let me I'll go and sing this song, right?
All right.
Nah. I feel like I'll go record, but I'll post it up on this other something and say this man can sing.
No.
No. Oh, I will.
Wait, anybody gonna sing with me?
Yes, sir, yeah, we'll join along. Don't worry.
Yes, sir.
All right. Make me stay, so take your weight off me. I know your every move, so won't you just let me be? I've been here times before, but I was too blind to see. Let's say you introduce every moment. That's time to introduce me. She's saying that's okay. Hey baby, do what you please. I have the stuff that you want. I am the thing that you need. She looked me deep in the eyes. She's touching me over stuff. And then I turn it back. She's not me. I try that thing. That's the day. I never hear anybody sing one.
It was
Right?
beautiful. It was beautiful.
That's the way you
Yeah. I never hear nobody sing with me, you know. I just sing by myself, boy.
So good. We just had to let you do so.
Yeah, it was
Hey,
too
say,
good.
you have me question. It is who ends up.
Well, if I do weddings,
Yeah.
yeah, boy. I do weddings.
I tell you the function.
Bet, man. Bet. All right, so that's the day. Anybody have energy to do a TikTok video? Third life? I find the energy real dead, boy. Like, real fast today, boy.
I think Renisha dropped us.
So literally everybody just sleeping.
Which
Okay, boy.
Thailand.
All right, so I'm make a TikTok day. All right, so we do like 10 hours of maths as per usual, about 10. And like, but today everybody fall asleep. People literally fall asleep on the Zoom, boy. But the survivors, have some survivors here. Hey, big up me out one time, boy. Are they good? Are they good?
Yes, sir.
Yes, sir. Vibes to
I
the
tell you,
world. Yes.
I tell you, the vibes real dead yesterday,
A bit
boy.
tired today, honestly.
Yeah, but the vibes real dead. But I will see you all tomorrow. 17 hours straight down to the exam. Math vibes to the world. Peace and love. I got anything to say to them?
One month, but never two.
Bye.
Same math. Ooh.
Peace and love, guys. Later.
Bye.
Yeah, guys. Bye bye.